Wow, amazing. Welcome to APEC, everybody. I am Tim Ventura. I am your moderator. We have a really exciting conference session for you today. We have a lot of new people involved with the conference. We have overwhelming interest. We have a lot of people visiting the website. And so I wanted to kind of take a moment to remind everybody about what APEC is and what makes it special. This is something that I might talk about more in detail later, but let me start out with this. I wrote something down, so I'll just try and read this quickly. APEC is an open, volunteer, community-based conference that brings together scientists, engineers, and innovators in a supportive, open forum to discuss research into emerging propulsion technologies. You can think of APEC as being like a cheerleader for innovators and their ideas, and as a community center for a very small, tight-knit community with a very rich 75-year history of ideas. We help bring people together and collaboratively solve problems and share insights. In other words, we have a lot of innovators, geographically diverse all over the world, that are working on similar things. By putting them together and letting them share insights, our hope is to cross-pollinate and solve problems that might just be too big for one person to do themselves. We ask speakers, presenters, attendees, and our audience to only share as much as they feel comfortable having public. That is because everything APEC does is openly shared online through our website, our conference videos, and our social feeds. So I have said this before many times. I will say it again. If you have secret sauce, don't share that. And that is something I say to every presenter. APEC is not a business. We do work with a diverse group of scientists, engineers, innovators, and startups. Some of them have startup businesses, most do not. We try and work agnostically as a bridge to help connect them. Our focus is on the people and the innovations. And so our conference is not involved with their business dealings. People have asked what would happen if the APEC conference ended. They may not remember this, but in 2023, we did end the conference. It's a lot of extra work. It consumes weekend time. And there's just so much that's involved with organizing it and coordinating things and all of that. We closed the APEC conference and we said, we did a great job. We think that we've concluded this. We were met with overwhelming regret by the community. People asked us from all over the place. I had hundreds of emails from people saying, Tim, please start doing the conference again. So about 6 months later, we did. And we do it. We actually do 2 conference sessions a month. We have an open mic, which is a non-recorded Zoom open discussion. We do that once a month. And then 2 weeks later, we do the webinars. So that is what we've been doing now since the end of the pandemic. The Alt Propulsion Conference, again, is a bridge, a connector, and a good faith effort to help a community that has been overlooked and marginalized for decades. I'm sure that there are lots of community centers out there for other small communities that are similar to what we do. Our focus, again, is on emerging propulsion and the innovation community that developed it. This is a mission that I am incredibly proud of, and I am so happy to be able to contribute to this in perhaps some small way. Okay, Greg, welcome, sir. My apologies for the dialogue, the monotribe there, or whatever we call it.
You know, it was terrific. And Tim, you guys are doing such an awesome job. Can you hear me now?
Good, yes, I can. I can. You were having some tech issues, but that hits me a couple of times.
Well, it's my first time to use StreamYard, so I'm trusting that if I get into trouble, Tim, you're going to get me out, okay?
No, it looks great. So StreamYard, a fellow named Bernie Conkin actually turned me onto this several years ago. It has a lot of advantages. One of them is you can multicast to a lot of different social feeds at once. But then it also has higher quality. So we're able to record in true 1080. And that's not only for yourself as a presenter, but also the presentations. So,
well, good.
Yeah. Well, Greg, if it's okay, let me put your presentation up. I usually kind of introduce them, but I did run kind of overtime. If it's okay, let me, I will bring your slideshow up there. You have been working on absolutely brilliant work. You have done several presentations in the past. I am so honored that you were able to come back today and present with us again. If it's okay, let me just take myself out, and I will be here in the background if you need me.
Before you go, Tim, how do I advance the slides? I guess that's my
Oh, I'm terribly sorry. So if you put your mouse over the screen, you'll see a slide button. This is a StreamYard thing.
Okay,
And
slide button, which
yeah, you can either select a specific slide or you can do the forward or backward button.
Okay, let me see. Okay, there it is. Okay, terrific. Good. We're
wonderful. Set. Okay, thank you, sir.
Thank you. Well, Tim, it's good to be back, and I'm so appreciative of this opportunity to share with the community something that we are really excited about. And let's go ahead and get started with the first slide. And again, we're going to be talking about AC MOST, which is a brief primer on adjacency compression, multiple observable shell theory, and its potential role in UAP detection, tracking, and targeting. Now, if you note at the bottom of that first slide, you'll see this presentation is the first public introduction of AC MOST, and as such is intended to serve as priority registration for the underlying scientific ideas, concepts, methodologies contained therein. Please cite appropriately. Basically, the verbiage just is saying that this is the first time that this has been presented. And when you make a public presentation for the first time, that presentation immediately becomes essentially a priority registration, which means you heard it here first. And I'm so glad that we are able to do this for you and for the APEC community. No one else has seen this. This is the first time through. And I'm not going to say it's going to be a perfect presentation, but certainly it will get the points across. So let's go ahead and go to the next slide. Here's my contact information. Robert Gregory Cathcart, go by Greg. My email's here. Tim also has the ability to contact me if necessary. My bio is that I am a writer, advisor, experienced technologist, company founder, et cetera, et cetera. But I do have a very real interest in education, particularly for underserved communities. I've been involved with artificial intelligence initiatives for over 4 decades. I was doing AI when AI was not cool. I remember my first graduate professor saying that the day would come when AI would not only drive cars, which I found hard to believe, but that AI would also be flying airplanes. And my comment in class was, you first. But guess what? Here we are. And it looks like it's just becoming more capable all the time. I have a particular interest in artificial general intelligence, which I believe we haven't come close to yet. We're not there yet. And I know that's a big argument. Our large language models, AGI, some people believe that they're becoming cognizant, but it's not. At this point, I'm going to say no, not at all. In fact, I made a presentation that was produced by Polyplexus, which was a DARPA initiative for new technologies. And I said that until we reach a new paradigm, that LLMs will be primarily not conscious or cognizant. So I'm not a physicist. I want to make sure you understand that, and you'll understand even more in just a moment. But I have made had a lifelong interest in foundational physics, and I currently live in Texas and Colorado, and I have no doubt who has the better football team. I can tell you that right now, Texas. But we support Colorado as well. I'm also co-founder of Animas High School, which is an award-winning public charter school located in Durango, Colorado. Next slide. The presentation background, public interest in UAP has grown significantly in recent years, even more so just recently with the release of documents by the Trump administration. I'm sure that many of you have looked at those and had a chance to really immerse yourself in what's been released. I have some comments about that later on. You'll understand why. I do believe that there is more forthcoming. We'll see how this goes. But in this presentation, we're going to look very briefly at the means of detection of anomalous transit, including technologies, capabilities, and vulnerabilities. We will be paying particular interest or spending some time on IR detection, tracking, and targeting. And we'll also talk about the potential of information theoretical frameworks in determining how anomalous transit may be detected and tracked within our present reality, and how these networks might explain the 5 observable of UAP. Now, this really was the initiative for the project, and we'll get into it in just a moment. The following ideas are highly speculative, so I hope you enjoy them. We've made a lot of progress, but we are not a full-blown theory yet, and I'll explain that in just a moment. Note all material that is presented here is open source. Of course, we authored the specific AC-most paradigm, and anyway, but the rest is open source. 5 parts of this presentation: the incentive for AC-most development, a review of AC-most, a review of IR and modern warfare, and importantly, AC-most IR signatures, and you'll understand the connection in just a moment, and implications for the future. All right, part 1, the incentive for AC-most development. About a year ago, I presented here at APEC a particular case study. The overall presentation was on human bias in detection, but we also did a thing on ATRMs, autonomous tunable resonant metasurfaces, which was very interesting. But I highlighted this case study, and it really was the impetus for what I'm about to show you with AC-most. On November 6, 2018, a U.S. Army AH-64 helicopter encountered 3 unidentified aerial phenomena during a training flight in Arizona. The video shows 3 unknown objects flying in loose triangular formation. The 3 objects suddenly began moving erratically around each other while maintaining a steady eastward trajectory. An analysis by former U.S. Air Force personnel concluded that it was anomalous. The objects were calculated to be moving at approximately 1.28 Mach, and their movements during flight were determined impossible for any drone or any other aircraft in the current known inventory of the United States military. You can find the video released to the public by the DoD here. I'm not going to try and do that in StreamYard, but I think you'll find it interesting. It's not long. I have had access to and looked at a much slower motion version in doing some of the analysis, but I think you'll find it very interesting. Essentially, what's happening is an AH-64 is taxiing onto a runway, and in just a few seconds before takeoff, one of the individuals, whether it was the pilot or co-pilot, spots these objects in the air. And essentially, the dialogue goes like this: do you see those 3 really high flying jets? The second person says, probably F-16s or something. And another person says, no, I'm not looking up there. Now, the dialogue caught my interest immediately. And in looking, let's look at these blown up a little more. Here's the initial runway view. Now, here's the pilot looking up through a HUD. And if you can see the red rectangle here, you'll see 1, 2, 3 of these objects. They're barely visible here, but this is what the pilot was talking about. Do you see those 3 really high flying jets? And we'll go on to the next slide. So now we see in the red rectangle, once the pilot is looking towards these objects, they begin to move really erratically. You'll see now that they're much closer together. In the slow motion versions, here's another one where you see just 2, and there's a reason I've shown this, because these objects were making incredible maneuvers, but at the same time, they were appearing, they were disappearing, they were blending, they were melding. It was the most remarkable sight to see from a slow motion version. Now here, we're going to blow up these 2. And if you'll notice that the pilot here is in his viewfinder is targeting 1, 2, 3 in the upper left-hand side. In the middle frame, you can see how these 3 begin to meld together. And in the lower frame, you can see how 2 are beginning to join and 1 is essentially by itself. So I labeled these targeting, response, response. Initially, I had thought that this was particularly an evasive maneuver. We did an analysis. The Apache Longbow video images were analyzed as follows. We did a Fibonacci sequence analysis. We did potential EM response behavior. We did radar interference. We did optical phenomena. The two last are interesting. We did an internal shape patterns, and I'll explain that in just a moment, within the objects, and then we did a higher dimensional perspective. To spare the details for how these analyses were done, they were done. And my issue here is that we could spend a lot of time talking about these, each and every one of these items. It's not important. And it's also important to know that we have not ruled out every possible terrestrial cause. That's really important. It could have been something ordinary. We just don't know. So we looked at it and said, all right, here's what we looked at: the geometric figures that were actually shown within these items. When they're slowed down, they're blown up, and you look at them closely. Some appear as blobs, some appear as rectangles, some appear as triangles. What was interesting was Michio Kaku did basically a summary of what we might expect to see if wormholes had entered our current reality. And he talked about an extremely bright light and an exit point at the exit point of the wormhole or entry, possibly observing geometric shapes morphing in and out of the blob-like structures visible through the wormhole throat. Geometric shapes would represent the wormhole's entrance structure on the other side. And he also said there's a possibility of observing multiple wormholes simultaneously for purposes of stability. Now, it seems like it's, a slam dunk. This is okay, right? We're seeing everything that he had said that we probably would see if this event happened. And I looked at it, and something bugged me. I just did not buy the entire event, at least my own explanation of the event, or Michio Kaku's, or anyone else's. We talked about in that earlier presentation a case for tunable resonant metasurfaces, and then characteristic response to the presence of active targeting. And essentially the idea was that once these objects were targeted, there was an EM transmitted, right? Because they're using radar, they're using infrared, but infrared passive would not involve the targeting through an EM, but something spooked them. And so we have camouflage. It could be cloaking or morphing, countermeasures, erratic maneuvering, manipulation of return signals, including jamming or spoofing, as a means of escape. And I must have looked at this thing 100 times. It never seemed to set well as to this being, whether it's wormholes or whether it was A-trims. It just didn't sit with me properly as far as, is this exactly what actually happened? The more I thought about it, the more I realized that I was probably wrong in this initial analysis. So let's go to the next slide. I looked at it for, like I say, probably the 100th time. And I suddenly realized that what we were probably actually witnessing here was dephasing. And that really caught my attention. The idea is, what are we missing? Why was there a dephasing response? Was it part of evasion? Is this dephasing? Why is it dephasing? Why is dephasing out of what? What's its origin? Is it dephasing in and out of reality? How is that even possible? And is this part of a transit? And so we looked at it, and I decided that we need to change the approach. Most people say, well, what technology is possessed by these objects that allows them to do this? And basically what I said was, look, what do we not understand about physics and the universe to be able to understand how this even happens? Dephasing is kind of a big deal in our current reality. And so I thought further about the 5 observables, one being cloaking, one being instantaneous acceleration, anti-gravitational, transmedium, and hypervelocity with lack of signatures. And all of those, in one way or the other, violates our basic understanding of physics. And so we decided to launch a project, an ambitious one. So let's move forward. I want to give you a note on process before we talk about what we were able to accomplish as part of this analysis. Our methodology for answering interesting questions. First is to build an information theoretic model, and you'll hear more about information theoretics, why it's important. We test to ensure that there are no non-negotiable violations in the selected environment which the model represents. To give you an idea, if we build a model, then we have to be able to reproduce gravity. We have to be able to reproduce Lorentzian invariance. We have to be able to reproduce GR, space-time geometry, field theory. I mean, we have to be able to reproduce it all, or it's nonsense. That's the minimum requirement. The second requirement, then we take that and we say, all right, if the model is not violating, then maybe it can tell us something if it is complete enough. So we test for that. And then we begin the process of interrogation, where we ask the model questions, and then we begin to analyze the result of those, or the answers to those interrogations. Tools for research, I have in the AI era here, proprietary homegrown AI systems, commercially available specialist AI systems, broadly available generalized systems, and expert oversight and collaboration with manual processes. So AI doesn't do you a lot of good unless you have a group of experts that are able to review how the AI was interrogated and what the answers were that it provided. In what I'm about to show you, you'll see all of these. And this is the way research is done now. And it is something that we're all going to have to get used to. Also, note on process, we went to work on this. We did 15,000 lines of interrogation-specific code, more than a dozen derivational families, more than 10 conceptual branches, more than 200 simulation runs with failures too numerous to even count. Some of those were laughable. More than 100 completed model interrogations. So what happened? This happened. This is an introduction to AC most. And again, it's adjacency compression, multiple observable shell theory, and information theoretic framework for explaining UAP transit and behavior. So basically what we're doing here is we're saying, let's take an approach which might essentially become unification or might resemble unification. And let's build it in such a way that we can determine how it is possible for the 5 observables to occur in our present reality. It's a very, very unique approach. I don't know of anyone else that's tried anything like this. It is mathematically significant. It is thorough. It is very, very unique in its approach. I'll show this diagram in a moment, and I'll explain each and every one of these items. But before we do that, I want to deal with a bias, since we talked about biases last time. And when it comes to lattice theory, which is what we're going to be looking at, people tend to respond, at least in the scientific community, respond a couple of ways. One is that we live in a simulation. And I want to address that right now. We are not saying that or suggesting that we live in a simulation, although that might be possible. The fact is, that's not what we're saying. We are not suggesting that the lattice is real. So there is no underlying physical lattice that upon which our reality sits. What we're saying is we're suggesting that the information theoretic lattice is an effective mathematical abstraction or approximation of how reality is created. Lattices. In AC most, an ordinary lattice, we're all familiar with them. And what you see on the right-hand side of the slide here is a standard cubic lattice. It has fixed spacing. It has nodes which represent positions, links which represent the neighbors that they're associated with, and it is largely a passive structure. An AC most lattice is entirely different. Primarily, it's information relational. Its effective adjacency may vary. Nodes represent relational states or regions. Links represent compressive influence channels, and it is an active structure. So before you try and visualize this underlying lattice, let me explain first. It is 4-dimensional, which is difficult to begin with since we typically deal with 3 dimensions. And let's talk about its structure in a moment. And I want to talk about the applicable geometries initially that we dealt with when we were trying to determine how to approach this problem. Early attempts, variations, and spectacular simulation failures. Hidden lattice to single observational lattice. We started by saying, okay, we're going to work with a three-dimensional lattice underlying reality. We'll treat our reality as a single three-dimensional lattice, and we'll move information. Again, this is information theoretic. We're going to move it from the underlying lattice to what we perceive as reality. We tried a different geometry because we failed there. We tried a rhombic dodecahedral to a cubic lattice, fail. We tried 24 cell to cubic, spectacular fail, because of the amount of information that we were trying to deal with within a 24 cell and move that into a three-dimensional cubic cell. It was like trying to fit 10 pounds of stuff in a 5-pound bag, right? 24 cell to rhombic dodecahedral, fail, and this one still hurts because that was a tremendously computationally significant analysis. It was an epic fail. And then we just hit on an idea. What if we took the hidden lattice, as it were, and by the way, all of these geometries have to tile space. In other words, there are geometries that don't tile space or fill space, but we needed geometries which filled three-dimensional space. That's what we started with. And then we decided that we were going to go with a four-dimensional hidden geometry, which we chose the 24 cell, that would feed into a cubic cell or a cubic geometry that was three-dimensional, and that would be reality. And what we found was that we had to simultaneously project multiple realities. And I'll explain that to you in just a moment. It took more than just a single cubic. It took essentially what we wound up doing was going with a rhombic dodecahedral three-dimensional lattice combined simultaneously with a three-dimensional cubic lattice, and I'll explain that in a minute. In ACMOS, the 24-cell hidden compression lattice, remember, we can't see this. We just don't have that ability. But it is a hidden compression core, and we've identified that as a hidden layer that feeds into a rhombic dodecahedral observable shell lattice and simultaneously into a cubic observable shell lattice. We call the rhombic dodecahedral lattice A, and we call the cubic lattice lattice B. And the reason we had to use two is we realized that we were dealing with a simultaneous transfer or transmission of information into a reality that had two very different and distinct representations. And we'll talk about that in just a moment. What is an adjacency compression lattice? An adjacency compression lattice is a structured network of adjacency relations that compresses many local connections into a few effective relations while preserving the most important behaviors at a larger scale. It is a relational structure that stores, reduces, and transports information through the principle of adjacency. Now, remember, we're looking at an information theoretic description here. That's our background, right? Information theory. And so we're using that to create reality, and we'll explain some of the fine points there. In ACMOS, the lattice structure performs or supports compression. Information is reduced by removing redundant local adjacency information. Projection, hidden core information is translated and expressed into observable shell form. Transport, energy, phase, influence, field information, or identity moves through adjacency channels. And registration, projected state is stabilized into an observed object, event, or measurement outcome. And I'll explain this just a little more. In compression, lattice roles include the 24-cell core, which provides the deepest compressed identity of possibility and structure. Cubic cell compresses information into location, distance, and metric behavior. Rhombic dodecahedral shell compresses information into a relational overlap, fields, and interactions. Shell overlap, which is critically important, stabilizes all of this compressed information into an ordinary observable reality. Now, I don't know, as kids, we used to take our finger and we'd say, okay, how many fingers do you see? Well, if it's close to your nose, you're going to see 2, right? So imagine with the AC most paradigm, as you move your finger out, it becomes a single entity. So it's an easy analogy to say, all right, I'm transmitting one type of information through one channel. And simultaneously transmitting additional information, but a different type of information through another channel. These meet, they overlap, and they result in what we see as an observable reality. Now, this will be important later on. All right, what makes AC most unique in the unified theory landscape? AC most does not begin by assuming that space-time fields, particles, or forces are even fundamental. It attempts to derive those from a deeper geometric process based on adjacency relationships and compression dynamics. Geometry comes before physics in AC most, whereas general relativity starts with a space-time geometry, quantum field theory starts with fields, string theory starts with vibrating strings, loop quantum gravity starts with a quantized geometry. Emergent gravity theories typically start with thermodynamics or entanglement. AC most starts with a discrete adjacency structure based on information and asks what observable physics appears when information is compressed, projected, or registered across multiple geometric layers. Other uniqueness, the hidden layer is geometric rather than physical. Observable reality is a registration process, and it's very important in the detection, which we'll talk about later, of UAP. Multiple simultaneous observational lattices. Information is fundamental. Matter may be represented as information. Energy may be a manifestation of adjacency change. Motion may represent propagation of registered patterns, and physical objects may be persistent compression structures. Gravity emerges from compression geometry, adjacency density gradients, compression gradients, shell registration pressures, and information routing preferences. A common origin for quantum and relativistic effects. The 24 cell is highly unusual in these approaches. There's no question about that. Transit and hidden to observable dynamics, and this is very important, and we'll be talking about this in just a moment. Constructive rather than descriptive. So there are a number of things that make the AC most approach unusual and unique in the unification landscape. To sum it up, reality is produced by the registration of compressed information through a hierarchy of discrete geometric structures. Space-time is emergent, matter is emergent, forces are emergent, and observation is emergent. And we'll talk about more of these in just a moment. It'll get a little more interesting in a second here. Compressed core information. What's in the compressed core? What is it made of? It carries identity, possible histories, admissible transformations, hidden adjacency relations, conserved structure, latent alternatives, and allowed shell projections. So those of you that are many worlds fans will find that there is a similar function here, but not quite the same as many worlds. Sequence of information flow, 24 cell core contains a compressed possible state. It's full of possibilities. That state projects into an observable shell structure. The cubic shell provides localization. The rhombic shell provides relational coupling. The shells either fail to stabilize, and this is important, to stabilize an identity of a particle or a thing, right? Or they lock it into an observable state. And it's the realization where we're going to find some interesting things occurring here as far as UAP go. If locked, the state becomes a portion of normal reality. Projection is the translation of compressed core information into observable shell form. Shell registration is the stabilization of that information into a definite observable object, event, field, or measurement outcome. And this leads to an obvious question, and this is important. What happens when registration is incomplete? It doesn't happen the way it is supposed to exactly. Let's look quickly at a registration state and possible appearance. The role of the cubic shell provides location, distance, shape, local neighborhood, metric-like behavior, and classical separability. The role of the rhombic shell, remember we're pulling these together as they simultaneously project. The role of the rhombic shell is coupling, interaction, overlap, transport channels, wave-like behavior, field propagation, and gauge-like relations. The role of the 24-cell core is persistence, possible histories, and there are multiple possible histories for a given item, hidden symmetry, allowed transformations, conservation constraints, and shell projection rules. Registration state and possible appearance. Now here's where we said, okay, look, what happens if things don't go right? What if we have an imbalance in the way that an object is registered within these observable shells? Remember, we are creating an environment, or we're defining an environment which supports our own physics, but at the same time helps explain the 5 observables. If the cubic shell is strong, rhombic shell weak, we have they're localized but weakly interacting. If the rhombic shell is strong, cubic shell is weak, field-like or diffuse presence. Core strong and observable shells weak, hidden or transit-like state. Shells phase mismatched, blur, flicker, phase anomaly, and failed registration, IR echo, radiation, and what we termed a relaxation event. Now, a lot could go wrong, and the effects of things going wrong are interesting. We see some of these types of effects in the 5 observables, but that led to another question. And that is, could registration be intentionally manipulated? And here's where it gets really, really interesting. The 5 observables: cloaking, instantaneous acceleration, anti-gravitational transmedium, hypervelocity with lack of signatures. We have a term that we use called shell conditioning. And the idea is to alter the object's local shell environment in real time. AC Most proposes that ordinary reality arises from the overlap of multiple shell layers. So what could you use to change how an object is registered within these observable shells? Structured electromagnetic fields, tunable cavity boundaries, metamaterial shells, symmetry-specific field geometries, interferometric feedback, IR, near IR, and AI-assisted pattern detection. And these would all be necessary to create an object or to embed an object within a geometry or with surface characteristics that would allow it to change its registration in the multiple shell environment. Shell conditioning targets to strengthen ordinary shell registration, to weaken shell registration, to shift cubic rhombic shell balance, to alter field coupling, or to modify or to modify phase behavior. Shell conditioning and transit. There's what we call registration or re-registration. An item that is registering within the shell is going to, in some instances, based on the imbalance that occurs, and think about the descriptions of various UAP events: IR afterglow, visible flash. Now, this is all mathematically supported, so these things are theoretically absolutely possible. Phase anomaly, recoil, timing anomaly, polarization, structured emissions. Shell conditioning and time. AC Most treats time as an ordered shell registration and theoretically affect local time-like behavior. So in other words, a registration shift could change clock rates. There could be a phase lag. There could be delayed emissions. There could be altered coherence windows, changed update rate relative to outside reference systems. Shell conditioning and gravity. AC Most interprets gravity as emergent compression geometry. It does not block gravity, but might modify the object's participation in the shell geometry through which gravity emerges. So there might be a weight anomaly. There might be an inertial response shift. Free fall deviations, gravitational phase anomaly, recoil, back reaction when conditioning changes. So this, you'll notice this this drawing occurred with the latest release of documents. The two things that caught my attention the most were both hand drawn. Essentially, this is one where shell conditioning cloaking AC most would define cloaking as a weakened or phase shifted multi-shell registration. There could be optical dimming, sensor disagreement, reduced IR-EM signatures, phase distortion, partial hidden shell state, and indirect IR or recoil issue. I include this. This event happened where there was a bright flash, which aligns with AC most. Suddenly this object appears in reality as a solid thing. Again, AC most would support that. And then in the description of what the witnesses saw, it immediately disappeared, cloaking, boom. That caught our attention, especially relative to AC most, and it would certainly support it. Here's the overall three lattice architecture of AC most. It's pre-geometric hidden substrate. It's adjacency-driven transport. Dual 3D observational endpoints. Again, this is a simultaneous registration of information that creates reality. Shared macroscopic appearance. The observable lattice on the very inside, the blue lattice is 24 cell, then lattice A being rhomic dodecahedral, and lattice B being cubic shell. So again, on the right-hand side, superimposed observable reality. Again, the idea of the fingers and what we're actually seeing are two realities superimposed, simultaneously projected. And this appears to be a really good approximation for how things really are. We did a series of interrogations. I think I mentioned that we had over 100. We asked questions like, how might AC most be proven or disproven? It is falsifiable and it is testable, which is a refreshing thing in foundational physics these days. What IR signatures might be identified with AC most, and this is important. I'm not going to read every one of these, but each one opens up a very interesting set of possibilities. Where and how does time manifest itself in AC most? How does gravity emerge within AC most? Could time, gravity, or other environmental factors be manipulated within the AC most environment? It was an extremely interesting exercise to work through these interrogations. How would time be experienced within a shell-conditioned environment? Would this violate relativity? No, it doesn't. How could a dynamic shell boundary environment be built around an object, changing the object's local observable shell registration without directly touching the object itself? And this is important. How does AC most explain spontaneous particle emission in a vacuum? Will a transiting or cloaked object always present an identifiable EM signature? Without going through the rest of these, it was great fun going through and interrogating this. Each one of these questions could result in days of presentation in and of itself. Questions: could AC most be used as a framework for grand unification? Short answer is yes, but there is an extraordinary amount of work to do. Is it worth pursuing? In my opinion, yes, it has great potential as an underlying framework. All right, IR in warfare in space. We'll come back to AC and IR signatures in a moment. IR environments and advantages. First, we started with central to asteroid detecting and tracking. There's a thing called VMSE, NEOWISE. It's cryogenic infrared telescope with megapixel IR cameras. This is deployed now. All sky infrared survey, near Earth asteroid and comet detection and characterization. NASA has a NEO-Surveyor, mid-infrared detector arrays with and mercury cadmium telluride detector architecture, purpose-built planetary defense telescope for finding potentially hazardous asteroids and comets. Most relevant modern detector material, again, we just mentioned that briefly, modified arrays based on Teledyne's Hawaii infrared detector architecture. This is primarily used in space. And I bring this up because I think it fits into an overall scheme that's going to become very important. IR is a core sensing layer of modern warfare. It's passive, works in darkness, able to penetrate haze, dust, and smoke. Examples include tactical thermal sights, airborne targeting pods, infrared search and track, fused night vision goggles, missile seekers, missile warning systems, and directed infrared countermeasures. Allows detection, classification, tracking, designation, strike, warning without emitting radar energy. Technologies and usages: thermal detection, photon detection, system types and primary use, thermal image, FLIR, targeting pod or turret, IRST, airborne search and track, fused NVG, laser designator, rangefinder, imaging IR missile seeker, and defeat inbound IR guided missiles in DIRCM. Operational roles of IR in modern warfare include surveillance and reconnaissance, targeting and fires integration, battlefield awareness and self-protection, counter UAS and camouflage detection, combination of radar, IR, and acoustic sensors to detect and track UAVs. Now, this was identified in Ukraine. I thought this was really interesting in what they did, but they were able to combine IR again with radar and acoustic sensors to target and track UAVs. Initially deployed in Ukraine, I'm sure that other nations will follow suit. Navigation in close combat, autonomous and semi-autonomous systems. All right, IR signatures and AC most, and this is really why we did this entire project. Traces of shell core integration. Again, what we're saying here is that nothing's free. There will always be a signature that's going to be available and findable, locatable somewhere. So traces of shell core interaction include thermal and non-thermal, spectral and phase relaxation traces. Most IR relevant stages during transit become pre-transit shell tension, partial decoupling, re-entry, re-registration. And we're back to that whole idea of registering within an observable environment. Post-event shell relaxation. IR detection would look like the following: a near IR precursor, mid IR relaxation echo, delayed afterglow, non-thermal spectral peaks, polarization structured emission, local heat without ordinary cause, IR emission without corresponding visible source, IR optical mismatch, and sudden disappearance or appearance of thermal signatures. Let's go to the next slide. How would all this be combined? If an object were moving through shell states, there would be a pre-entry, pre-exit shimmer, most likely, thermal profile discontinuity, delayed IR afterglow, and spectral continuity. Targeting at source, queuing, and localization. This means pointing information towards the probable location of a reentry or an exit, and relocking anomaly formation. So what would be involved? High-speed optical cameras, interferometers, microwave radio sensors, magnetometers, acoustic sensors, LiDAR, polarization imagers, and spectrometers. The sensor chain, if this were to be deployed, would be wide field IR detection and anomaly classification, narrow field spectral lock and phase interferometric confirmation, and trajectory or re-entry prediction, which would probably be assisted by AR. The detection stack would include wide field IR camera, cooled near IR detector, mid IR detector, time resolved IR spectrometer, polarization resolved IR optics, high speed visible cameras, laser interferometer, thermal reference sensors, EM and acoustic monitors, synchronized timing systems, and an AI anomaly classifier. Basically, this would be deployed to accomplish the following: detect, use wide field IR which notices a localized non-ordinary transit. Classify it, spectral and temporal data, determine whether it is thermal or non-thermal. To track, repeated IR leakage, afterglow, or spectral fingerprint is followed across frames. Cue other sensors, interferometers, optical cameras, and EM sensors, and are pointed toward the anomaly. Predict re-registration, precursor IR and phase gradients, estimate where the object may reappear, and confirm the system checks the delayed IR echo, phase anomaly, polarization structure, and optical IR mismatch. So in other words, this stack would be rolled out and be used to, in some cases, to autonomously identify a transit that has occurred or is occurring. Last slide, I think. Implications for the future. Is AC most the answer? Can it be proven? Is it falsifiable? And that it can. It is falsifiable. We've outlined a set of experiments that would be able to falsify AC most at a relatively reasonable cost and effort. If it was found to be supported, in other words, if during that testing phase, we've looked at what to expect if it exists based on this experiment, it would be phenomenal. It would really be an interesting situation. It doesn't prove that it exists, but it hasn't been falsified either. If it fails that test, then it's falsified. That's cut and dried. What could, if AC most comes out to proven to be correct, what could it do? Well, it would revolutionize the detection, tracking, and targeting of UAP. It could be used in planetary defense. Now, I'll take just a moment. I'm going to finish up here in just a second to talk about the Golden Dome. Those of you that are familiar with it know that it is a planetary, or essentially a national defense system, but a planetary defense system, as it were. And the idea is that you surround the globe with satellites, and then you use capabilities within those satellites to detect, track, and target weapons that have been launched against, in our case, obviously, our nation. It is really interesting how it works. IR plays an incredibly important role in this. And if you do a little homework, you can find out essentially what many of the IR capabilities are of things like Starlink. And in fact, Starlink may serve as the initial detection system for IR identification of weapons launch. At the same time, there is a military layer to this, which works in conjunction with the Starlink satellites. That basically they serve a custodial purpose. So once a weapon has been identified in launch, it is then handed over to the military segment of the system, which then it performs a custodial role. It escorts that weapon to termination, whatever that may be. In the turn, it is, I believe it is essentially Starlink is part of deployment. It's being deployed now. Remarkable. Grand unification theory for in the future, if AC most is proven correct, it would certainly be a unification pathway and something to consider as far as finally tying together the quantum world with the space-time geometry world. We think there's potential here. We think it's information theoretic. It will be very interesting. Technology and science, obviously, we did an interrogation where essentially we asked the model what happens, or how could an object in transit minimize use of energy, and it came back. The model comes back with this idea of compression wave surfing, which totally is a mind-blowing concept. But the idea being that in the core, consider this the subspace, right? Within this core, although it's not a literal subspace, but in this core, the ability to compression surf, to surf the wave as part of transit becomes very, very energy efficient. In the area of space exploration, the distances are so great. We wonder sometimes how we would ever be able to travel these distances. Well, hey, you've seen the answer on Voyager, right? Subspace. While this is not a subspace per se, if it is a close enough approximation, then perhaps that idea can be pulled forward and used. Again, we're not saying there's a physical lattice there and you get out your surfboard and you surf it, but the mathematics certainly support it. And so is there a possibility of minimizing energy use, which is a very, very interesting topic in and of itself. Lastly, let's go to the last slide here. Again is my information. So Robert Gregory Cathcart, there's an email to use there. Love to talk about this stuff. It is a remarkable project. So I think at this point, I will turn this back over to Tim and let you guys take it from there. I will say before I go that we are extremely excited about this. There is a ton of work left to be done, and we think that the potential is enormous, but we would want to verify quickly whether we want to falsify this if it's not going to pan out. And there's a way to do it. But anyway, Tim, back to you, and we'll let you take it from there.
Greg, that is awesome. Thank you so much. So let me take the slideshow down. And again, we have your info there. So I'm going to take that down. And guys, let me do this before anything else. And I slowed us down doing my little speech at the beginning. I'll bring everybody in here. Guys, let's put our hands together and give an enormous applause to Greg. Greg, thank you. Thank you. And I know you'll have another one for me in the next year or two. When you're ready, bring that one in as well. I love putting this material up. I love the scientific approach to UAP study. And really, you're digging in on like a core level and drilling down to like, what does this mean? What is the potential physics underneath it? And that's super exciting.
Thank you. Nice.
Okay. And so we are just about at the top of the hour. Guys, is it cool with you guys if I go right to Isaiah? Okay. Yeah, let me do that then. So I will take everybody out. And Greg, thank you again, sir. Thank you so much. And my apologies for rushing everything. It
was fun. It was great. It was great fun. It always is. Thanks, Tim. I appreciate it.
And thank you again. Thank you again. Okay, Isaiah, welcome, sir. So
thank you.
For folks who aren't aware, I was down at your house. You and Jared lived near each other. I stayed with Jared for a couple of days. Thank you. I owe you a tremendous debt of gratitude for having me over. I owe Jared a tremendous debt of gratitude, as well as jelly beans and some candy bars, because I may or may not have a sweet tooth that I should admit to. So next time I come down, I need to bring a big bucket of jelly beans with me at the very least.
Oh, I'll have a 5-gallon for you.
Yeah. Well, so like, I'm not even sure where to start. I think the thing to start with is, again, in our community, right? Because we're getting a lot of exposure now outside of our community. And so for folks who aren't aware, the Searl Effect Generator is one of the mainstay devices in your traditional like anti-gravity community, right? It's like one of the first things that I learned about when I got into this area.
Yeah.
And I mean, people have been like fanatically interested in this since the 1960s, like, yeah. So it is, I mean, quite literally, it's wheels within wheels, right? The more you dig, the more there is. There's such a massive story there. You are one of the premier builders in the world. And like, I say that when I record our videos, but like, I cannot applaud your work enough, because various people throughout the years have tried to build little variations on SEGs, and they have either failed outright or they have cut corners and they've run into all sorts of obstacles. You have pushed through all of that, man, all of it. Like, it's just like a hot knife through butter. So it's amazing. Absolutely amazing.
Thank you, Tim.
Yeah.
Yeah.
So let me bring your presentation up. This is beautiful. You didn't have to do one, man. I was thinking if you wanted to come on and just talk about it, that would be enough. But if you have a presentation, that's amazing.
Yeah, it's a little over a year's worth of discoveries, and I just wanted to showcase I think basically every single one I can think of is here.
Well, let me do this. Let me take myself out. And again, thank you so much for running us through this. And like, for anybody who was watching, they need to pay attention, because you were the person, you're doing amazing work. I mean, we gave a shout out. There are a lot of other people that have done remarkable work in the Searl environment as well, right? But like, right now, you're there and you're making it happen. So
thank you, Tim. I really appreciate that. And you're welcome to my house anytime. Hello, everybody. Good afternoon. My name is Isaiah Ritchey, and I just wanted to go over with the latest updates of from last May of 2025 until now here in June. So first slide, this is the basic SEG. structures, energy, geometry, mathematics, geometry, magnetism, and motion. And the basic one just starts. It has the main stator unit composed of 4 materials, and then you have the 12 rollers on the first ring set. These are some of the upper left-hand corner. This is a law of squares. It's the mathematics that I use. It's what John Searle used to build the machine. Let's see. So let's get into this. It's pretty in depth, and I just wanted to go through everything I've discovered here. So what is the SEG? As you can see in this visual illustration, it's basically, SEG stands for Searl Effect Generator. It is a linear motor operating on a frictionless magnetic bearing, similar to how a maglev train levitates above its track. It functions as both a motor and a generator, operating as an open system that extracts energy from its surroundings, mainly from what I've uncovered, thermal energy. That's the general idea. Much like a hydroelectric dam takes in water, but this is more at the quantum scale. It's in the spirit of what Tesla envisioned from the wheelwork of nature. The SEG converts ambient temperature and radiation into a usable electricity. It is built from 4 materials. The innermost layer, what I'm using, is rare earth, a combination of rare earth elements. Teflon as a dielectrically negatively charged dielectric Teflon, the magnetic layer, and then the copper emitter. These 4 parts form one segment. In each segment of the rollers, there's 8 segments to a roller to make one roller, and 4 parts per segment. And then you have a 3-ring system. So you have the innermost ring composed of 4 layers. Then you have the 12 rollers around it. Then the second ring system goes around the first, and that has 22 rollers. Then you have the third and final, which has 32 rollers. And then on the outside, you can see on this image is the inductors to pick up the relative motion of the rollers as they move around. Mainly what this is originally intended for, John Searle built it, was for generating electricity for his house. But according to him, it also flew, and 2 other witnesses I've been able to have corroborative, I can't even say the word, that they both saw it fly as well. Let's see. So I'll move on to the third image. So this machine I started building back in 2009. This was the first model, the upper left-hand corner. It was just bare bones basic. It never actually ran. Now, coming up to 2023, May 17th, that was the first model where I actually had a roller going around it. These little modules around that first one that have the blue lights, those pulse the roller. The maximum RPM I could do on that was probably about 120 RPM. It was pathetically slow. Now, moving up today, with the bottom image is my most recent incarnation of the SEG. It's version 6. I'm presently working on version 7. And that one has inductors on the outside. They don't push the rollers. Those are inductors. I have a nice control module on the left side of it. And that system can do, the motor system that drives it can do a maximum of 800 RPM. But the best I've ever observed with one of these rollers was 575 RPM before it flew off. So those are the modules I've created. Let's see. So this from May 2025 until June 2026. These are a comprehensive list of everything me and everybody I've worked with have been able to uncover. Basically figuring out law of squares, how the mathematics works on that to be able to correctly design the rollers, and the first, second, third, and if you want to do a fourth, fifth, sixth, and on up, the stator rings with the appropriate type of rollers and the appropriate weights. It also gives the magnetizing frequencies. Magic square mathematics also found that there is a ratio, exact ratio between the height of the roller to the stator. The roller from the first, second, third needs an 18% air gap. and then the spacing from the rollers to stators for number 1, 2, and 3. The impressions, I'm working magnetic impressions with the rollers. I've successfully been able to do 34 wave impressions, and then lightly have done 68, and working towards 136 wave impressions, or frequency, if you will. And then also working towards the stator to have the matching type of frequencies. Waveform imprinting. Lately discovered a couple weeks ago, I can use alternating pulses using only 100 volts to put waveform impressions. So lowering that the larger amount of voltage required to put the waveforms, I'm down to 100 volts on ceramic magnets. Top versus bottom field symmetry. In rotation, it induces rotating, which I'll go through here further down. And also the frequency response on magnets. The ceramic magnets had a mechanical frequency response of about 18, 19 hertz. And also discovered a way I can do that with neodymium magnets, finding the mechanical resonance. I'm using a particular type of rare earth instead of pure neodymium. I'm using a mixture of rare earths, so the cost is substantially further down. And then the indexing, I did 136 slotted ring magnet. And let's see, segmented in, oh yeah, and this one is because of an accident that happened in the lab, which I'll go through further down. So this is kind of a list I'll cover as quick as I can. A special thanks to everybody here, and my faith is a Christian, so I just want to thank the Lord Jesus, my beautiful wife Marigold, Jared Yates for his help, Josh Varner, Jason Verbelli. Many years ago, Fernando Morris helped me. He since has passed, which is very sad. A gentleman by the name of Skylar, Matthias Bage, and Tim Ventura for all his help, his hosting me here, really getting me exposed. I just couldn't thank you enough, Tim. So I just wanted to mention that, and particularly for my wife. She hears about this project day in and day out, and she has unlimited patience with me in this. So I just wanted to thank her. Thank you, Marigold. So figuring out law squares was really one of the biggest leap forwards, because I could mathematically reason and figure out exactly frequencies, why the squares work, how they worked. So understanding this, and that there was a true real number of proportions between the roller height and the stator height. You know, these rollers you see here are those are the parts that orbit around the stators. And the outside dimension of copper is 1.405. And these give all the weights on the left-hand side. These upper right-hand pictures, these are pictures I took and then had ChatGPT enhance them a little bit. So you have the inside part, which is a rare earth, and then you have the Teflon, which is the plastic, and that goes around the rare earth. That is charged negatively. And then you have the magnetic layer, which essentially has the software or the programming, if you will, that goes around the Teflon. And then the copper goes on the outside of the magnetic, and they all fit together. You press them together, and so those four make one segment, and there are 8 segments for one roller. Now here's one of the versions that I'm presently making for version 7. All 3 rings, the weights, the sizes of each stator, and each stator has its own square value, which you can obtain the magnetizing frequency. What I've found is if you're using a 4-layer system, you know, the neodymium or rare earth, the insulator, the magnetic, and the copper, it gives you 4 layers. So you find the sum of the numbers using one of these squares, you multiply that times 4, which is 4 layers, and that gives you the magnetizing frequency. And this is the best I've understood squares. Skylar helped me with this, and it gives me exact numbers, exact weights to work with. Basically, the weight times 4 gives you the magnetizing frequency. Now, this is something I probably will eventually do, is create a one ring set based upon the golden ratios or Fibonacci SEG architecture, the math, and I've broken this down so I could do stator 1, number 2, number 3. I'll probably just build 1 and build rollers according to this math. In my opinion, I believe based upon the weights and the thickness of the layers, this potentially could be a better type of SEG. From what I've seen, the copper stator layer, the copper is thinner, the magnetic is wider, the insulator is really thin, and the rare earth is far thicker. I still have yet to work towards what the exact type of magnetic impressions would look like, what numbers they'll be exactly. That'll just be by trial and error. I have this listed here, what they should be, but they really will come together when I actually build it. But there is a harmony, much like law of squares you see, but this is golden ratios. This was a fun one to put together because it flowed so well. I didn't run into any obstacles with the math. The math just harmoniously came together when I mathematically built it. This on the lower right-hand corner is a possible magnetizing jig I'll use. This was a interesting development. So from the first ring set, 12 rollers, to the back end of the, not back end, to the beginning of the second layer, and from the second layer's rollers to the third, there is a precise air gap to keep. What I found, it's about 0.23 to 0.25, and I went with 0.25 was 18%. So basically it's 18% of the width of the roller is the air gap. So that way, as the roller speeds up and it starts to very lightly come away from the stator, it's held magnetically together. So as it speeds up, centrifugal force pulls away. It won't go smacking into the second stator, and the second stator's rollers won't smack into the third. So there's this nice air gap. And from what I've observed, 250 to about 285 RPM is optimum before fly off and for smoothness of the system. This is one of the magnetizing modules that I've used for magnetizing the, I should say, modifying the magnetic field on the ceramic magnets. The last one I did, I got 68 very faint wave impressions on one of these magnets, and unfortunately the capacitors died on the system I was using. So I'm looking to replace those soon and then continue tests. The lower right-hand corner picture you see is for changing or putting waveforms onto the neodymium-based magnet. If you look closely on this kind of middle lower image, you'll see that these wires are slanted precisely at 21 degrees. Those fall in line with squares, and they produce the very coherent waveforms that I've seen. So here's just a sample of some of the waveforms that I'm doing. This upper left-hand corner, these are extremely tiny, 136 tiny waveforms. And then you'll see some bigger ones. And then around a ring magnet, I'm holding on kind of the exact middle. That has very uniform waves. And then one of these, you can see the ring magnet with uniform waves. Now this one, where it's the full ring magnet, that was actually physically cut into the ring. I wanted to see what it would look like if it was physically cut. So some of these, let's see, one of these, it's combined DC pulse methods, and sometimes I'll reverse current and go back and forth. One of the windings come up here, I use alternating field techniques, so the voltage drops from 250 volts down to 100, and I'm still getting impressions because the winds are going opposite. So it's repeatable. I've done probably around 30 of these tests on these ring magnets to find the optimum voltage. And the neodymiums, I found it was 2,850 volts. Ceramics was 250 volts and no more. This is the one I found out a couple of weeks ago using alternating windings. That was a game changer for me because I could just use 100 volts and get wave impressions around a ceramic ring magnet. Neodymiums, I need to crank up the power and do more testing once I get the capacitor system working again. So eventually we'll build a module to where you can just slip in a ring, push a button, and because the windings are alternating, it'll produce waveforms with far less voltage. Now here was the first trial run. There was 3 wires, 1 in the center, 2 on the left and right. You can kind of see the hand-drawn image, basically alternating windings, and you pulse the current at the same moment. And on this middle lower image, that was the waveform I got. So this just only using DC pulse, but it kind of acts like an alternating field, but all at the same moment, only with DC. This was a lot of trial and effort to get this module correct. This is a system that was a big game changer for me that I've seen only Jason and Fernando being able to do. And they modified the ring magnets so when they're next to a spinning piece of copper, the ring magnet rotates. That was a complete accident. That was figured out last year. And once I discovered what I had done, it took me several days to be able to re-figure out what had happened. But I was able to come up with a module, and the whole real big way, not the way it works. I don't understand the reason it works. I just understand that one of the way it works is if that piece of copper is on top of the magnet and there is a wire literally, I think if I go to the next slide, I'll show it. Oops. Okay, so maybe not. There's a wire underneath the ring magnet that fits in that slot with the yellow peg. As long as the wire is angled underneath the magnet, it will only work with that piece of copper on top. I don't know why that is, but I get these wave field impressions that cause rotation only with that piece of copper on top of it. So I'm hitting these with about 2800 volts, and it doesn't diminish the field. It doesn't erase it. It just kind of tweaks it on the ring. So actually, I'll show this. I 3D printed a large version of one of my ring magnets. And so instead of it just being completely flat like ring magnets you buy, the field, you have a perfect north, a perfect south. Well, what this does, it pushes it down on one side. So basically, that would all be solid north. You come exactly 180 degrees, or what I do in my module, I flip it. So I get a 180 degree rotation. And when I do the second pulse, it pushes the south out, or it pushes the south up. So I almost get a full face of south and a full face of north. So in a slide coming up here, I'll demonstrate the module I use to rotate it without contact. The bottom here, it shows the actual waveforms of what it looks like on the ring magnet. One of my systems is I do this alteration of changing the bias field. So you have a peak and a valley, and then you take the ring magnet, put it into another module, and it impresses the 34 and hopefully 100 up to 136 waveform impressions onto the one ring, and then essentially the ring magnet is done. This is from an idea I got from Floyd Sweet of finding the mechanical resonance of your magnets. So I built this enclosure so no air currents would go through here, and then you have a signal generator hook up to a 100-watt audio amplifier. I found that ceramic magnets respond mechanically to between 18 to 24 hertz. And then neodymium magnets respond between 8 to 9 hertz. What I do with this is, because my magnets are pretty small compared to Floyd Sweet's, I use a very thin razor blade, and it'll flutter like a butterfly wing when I hit that resonance. And what you see here in that case is a small ring magnet. Underneath it is a coil. And with neodymium magnets, it has to be a little bit different. I actually have about a 6-inch long, a giant needle magnetically suspended from the top, hanging down, barely touching the magnet. And when I hit that resonance point, or actually that big needle will start to fluctuate, but it's only between 8 and 9 hertz and nothing else. So it's mechanical resonance. According to Floyd Sweet, when you hit that mechanical resonance with a magnet, you can imprint a different frequency. I have done no experimenting with that yet. It's one of the ventures I want to go soon and start working towards that goal of opening the, not opening, but doing that type of experiment just to see if there's anything valid to it. And if there isn't, I'll just move on past it. This is one of the odd behaviors I found with using my type of modified wave fields on the sides of these bar magnets and then putting a ring magnet to it, was that the ring magnet would go around the bar magnet up to 4 or 5 times. It would almost treat it like it was a round magnet more than a rectangle magnet, only if it had this conditioning. And so I believe it's kind of reprogramming that bar magnet to behave more like a round magnet, so that this my ring magnet will go around and around and around. Eventually, it will stop, of course. I'm eventually going to build a module so it will lightly pulse it and it'll just continue in motion. It'll be kind of an attention getter. It'll be pretty cool looking. But as the wave field impressions get better and better, I expect to have better performance. Ideally, it would just go round and around that bar magnet as easy as it would a round disk magnet. Now, this is the module. I've got to say, these little, I'll say on the module, see me, you have these 2 little handheld pole finders. That was Jared's idea. It was brilliant. And what it does when you turn the button and turn on this copper band, it rotates it up to about 800 RPM. This is totally for testing the ring magnets. If the magnetizing went correctly, the ring magnet, when held within about a 1/16 of an inch, no contact, it'll spin in relation to the eddy currents generated by the rotating copper. There's no contact necessary to create the rotation. But because of Jared and him telling me to get these little handheld mechanical pole finders, when I held one up next to that spinning piece of copper, it spun wildly. You don't have to start it, you just get it near it, and it would just spin really fast. So that's what gave me the idea to start altering the ring magnets. One peak, one valley, basically would have a solid face of south, a solid face of north. Further tests I'm going to try for maybe like 4 or 6 or 8, 12, maybe 34 up and down impressions to act essentially as magnetic gearing, no contact necessary. So that's what this whole module was built for. It's completely portable, and it works on a Milwaukee battery and a brushless motor, so it never gets hot, never warms up. Dynamic coupling observations, contactless operation. That was a lot of fun. So thank you, Jared, for that inspiration. This is the rare earth elements I'm using for the core of the stators, stator 1, 2, and 3, and then all the rollers. Basically, I got these rods. They're very interesting when you ting them like with a piece of metal. They resonate like a tuning fork. Pretty cool stuff. They're composed of 80% rare earth mixture, 15% iron, 5% magnesium. And I'm testing that they behave similar to neodymium, because there actually is neodymium in them. They have, I think, about 5 other type of rare earth elements in there combined with neodymium. The factory I buy them machines them to very tight tolerances to the size I need, which I believe is 0.798 inches wide, and they perfectly fit inside the roller. And then I do the final machining of cutting them, facing them off. The ideal weight is 13 grams each. So I'll size them all down. I'm going to start with a set of 96, and eventually I have enough material here in my lab to do the full 3 rings. So it'll be 528 parts. It's going to be a lot of fun. They have to be cut with coolant spraying over them, otherwise they will start fires. They spark like literally like sparklers, 4th of July sparklers when you cut them, and then they can just burn holes through the saw blades or the cutting bits. It's insane. So when I keep them with a liquid coolant spraying over them, they cut cold, they cut like butter. It's real easy. At least I think it's easy. This is how I'm intending to charge the Teflon insulating layers. So this middle lower image, you see the pegs with all the small rings. That's about 600 rings that I printed out using nylon 6 as one of the test segments. I'll probably will eventually use just Teflon, but this is just a test to see if they retain a negative charge on them using a Van de Graaff generator. This Van de Graaff generator you see here, my unit is pretty similar to it. I just had AI kind of reconstitute the image. So I'll charge them. From what I understand is you heat the plastic up before its melting point, and then you let it sit on a negatively charged plate. And then when the plastic cools down to room temperature, they continue their charge as an electret. So that's probably one of the last things I do before finishing the SEG is do these parts, put the whole thing together so they don't lose their charge, and then start doing tests. These ring segments for the rollers all need to weigh exactly 4 grams. The nylon is about 1/4 of that weight. It's like 1.4 grams. So they'll mainly be for testing. Actual Teflon needs to weigh 4 grams. So eventually we'll have to shift to real Teflon eventually. The bigger ring you see here is for the first stator, and eventually going to gear up and do stator number 2, number 3, but those will be bigger rings. This is a ring, I don't know who challenged me to make it. I think it was either Josh or Jared challenged me to make this ring. And so I came up with a module, the cutting module, connected to a rotary indexing table, hooked up to a lathe chuck. You'll see on the right-hand image here. And then there is a Dremel tool, which I use I wonder if it's here or the next one. Okay, it's not. I use a 0.02 millimeter cutting tool. It's extremely thin. And then I find the dividing marks to precisely put 136 evenly cut slices into one of these ring magnets. And then after that was done, there was all the coolant. You can see the little blue hose spraying into the enclosure. So everything is really cold. There's no sparks, and all the debris is washed away. So once that ring is finished and cut, I could actually put it on the film. That is the clearest shot I've got, but seeing with my own eyes, you can actually see the super teeny tiny 136 micro waveforms inside that ring magnet. So ultra miniature waveform geometry. Now, after I did the one peak, one valley magnetic modifications on one of these ring magnets, I put it on the oscilloscope and just dial it in the oscilloscope. I use 2 Gauss meters at the same time with 2 probes measuring one ring magnet. So I get, channel 1, channel 2. I just want to see how they look together. Successfully, I've done the one peak, one valley numerous times. And then 17 points, 34 points. One ring came out partially okay with 68 points. And mechanically, I've done 136 magnetic points so far on these ring magnets. The ultimate goal is 136, and then one peak, one valley, which induces rotation. But this is an oscilloscope, actual oscilloscope image of one of the ring magnets that I've done. This is another effect. Thank you to Jared again for reminding me to do this. There's so many things that get discovered and they kind of, you just forget about them. But this is the one that I brought in, that he reminded me, was that when these magnets are magnetized correctly, they have a very visible spring effect of essentially you put the magnet on a piece of steel, the steel sheet. I use a steel sheet, and you merely just push it with your finger. It will rotate or it'll move and then jerk forward like it hit a spring. Yeah, it's like a spring pop behavior. Rapid release and re-engagement creates observable spring action. So what Josh and Jared and me believe is when you put the rings together, 1, 2, 3, 4, 5, 6, 7, 8, and you kind of reorient them so it winds down. So one of these waveforms starts at, like 0 degrees, and then the last one ends at 180 degrees difference. You have a full waveform traveling across. That's the idea. It can definitely be done. So the bias field is altered, traveling all the way down, and so it creates this spring effect. Literally, you push it, and they they bounce like springs. And I have observed on a few of these, it's really weird that as it rotates across, it goes like that. As it kind of comes to rest, it'll vibrate like a, I can't do it, but like a literal spring. The ring magnet will just vibrate for a few seconds and stop. It's pretty weird, but one of the unusual things that we've all seen these ring magnets do. Now, this was a complete accident. I was doing some tests with the with the module I have that rotates the ring magnets with no contact. So I put 6 rings all together. I was eventually going to do 8, but I only had 6 done. So I put them all together, put them on the module to rotate it, and it rotated beautifully when the copper was spinning. I took it off the module holder, fumbled it, fell to the this whole 6-ring system fell to the concrete, and 2 of them broke. 4 segments remained intact, and 2 of them retained their field. I immediately put the remaining ones that weren't broken, I put it back on the module to test, and it wouldn't spin. And I'm like, oh shoot, like, what a letdown. But then I realized as I took it apart, only 2, one of them retained its unique field. So I realized, like, okay, with enough striking force, it loses the impressions that I put on it. How interesting. So does that mean with the correct frequency response, I might be able to put frequencies onto these ring magnets? Possibly, I don't know. But it gave me hope that even though a couple of them broke, some of them lost their field, maybe with the right type of frequency, like that Floyd sweet box I have, I showed in a few other slides back, maybe I could imprint frequencies without having to use the high current, high voltage magnetizing modifications I've been doing so far. That has yet to be observed. It has yet to be experimented with. So yeah, my future direction is investigate whether resonance-assisted magnetic conditioning can influence field pattern acceptance without requiring high voltage capacitor discharge levels. That's my hope and dream. I have yet to test it to see if it will or not. With some of the stators, I've done successfully placed patterns onto them. These are the jigs that come up with for stator number 1, stator number 2. So far, I don't have the magnets for stator number 3, so I can't really create a jig for the stator magnets to fit into. Stator number 1 has 6 magnets that form the entire ring around the main stator. Stator number 2 has 11, and so they have to be wider in radius. That's why the left and right one have slightly different radiuses. But there is a 14 gauge copper wire forming a half waveform inside there. So as the stator piece slides into this jig, you basically just dial in the voltage you want and the amperage, push the button, and it permanently imprints a sine wave onto the stator. And for me, I need 2 fields on each stator piece. So I flip it around, put it back into the jig, and then push the button again. Future tests have to come to put not just the main bias altering waveform, but also the 21-degree micro impressions like I'm doing on the ring magnets. So basically the stator is a bigger copy of the ring magnets of sorts. Except the only thing different with the stator is that it's up and down, it's vertical. The ring magnets, essentially they have 2 radial poles, north and south, if you will. It's kind of like a radial pole. It's an isolated magnetic pole, and then the orientation is on the axis. So these are the modules I'm coming up with. These aluminum terminals here are for the positive and negative. And one of I don't say the trick, but one of the techniques I use is I flip-flop the polarities. So I magnetize it one polarity and then flip it around and magnetize it the other way. Or I modify, I should say, not magnetize it, modify it. So this kind of I'm winding up a little early here. This is the final slide, Tim. Future research. The next coming years, this is what I'm intending to do. finish the full 3-ring SEG and all 66 rollers with the correct waveform impressions and the correct weights. Testing for weight loss of the entire module. I expect the entire platform with motors and equipment and rollers and rings will probably weigh around 150 pounds for the entire thing, somewhere in that zone once all the driving motors, because what I'm making is basically a programmable DC magnetic bearing motor. I'll be testing for weight loss, RF and high voltage testing. Probably have to use a Faraday cage built around it because I really want to use some high frequencies in RF frequencies into each of the copper on the stators and dial in according to law of squares, dial in the correct frequencies that they should be impressed with. I want to check for, my hope and dream is cooling and refrigeration possibilities with this system. Eventually building up to use multi-phase magnetizers on all parts, on the magnetic parts, I mean. Higher density wave fields for the stator and ring magnets, meaning for just the roller ring magnets 136 hertz, and then each stator will get into the tens of thousands. The final third stator, I don't know how I can do it right now, but ideally it would be about, I think, 106,000 hertz or 106,000 impressions around the entire circumference. Right now, I don't have the capability of doing that, but probably down the line I might. Resonance assisted imprinting on ceramic, alnico, and neodymium magnets. That is something I'm working towards. Also experimenting with alnico magnets and imprinting. How difficult they are or how easy they are, I don't know yet, but I am going to be testing for that. And then one of the magnetizing, what am I saying? One of the systems I'm going to be building down the road, and I already have some of the magnets, is a total real replication, one-for-one replication of Dr. Paul M. Brown. He built this system in the 1980s, and it's this picture you see here. It would have one homogeneous solid ring, and the rollers on the outside of it. I think he had 24 rollers, if I'm not mistaken. I think it's 24. Each one of those rollers was only a half of an inch wide, an inch tall, and then his stator was 5 inches wide, an inch and a half tall, and 4 inches inner diameter. He said he had his own blend of mixture that he made it from, but I'm just going to go with probably alnico, and then alter the magnetic patterns. He claims he put 2 megahertz magnetizing frequencies onto his whole system. So that's something I'm going to shoot for in the future. So I honestly thought that would take a little longer than it did. But that's my presentation for today. If anybody has any questions, and if anybody out there actually has a capacitor that is about 5,000 volts and 100 UF or 200 UF or somewhere in that range, could you please contact me? I really need a capacitor or 2 of those right now, very badly. So if anybody has one or knows where to get one, I could use one. Thank you very much for listening to this. And thank you again, Tim, for having me on this video. God bless you all.
Thank you, Isaiah. Thank you, man. You are a rock star, dude. Let me bring everybody in here. Gonna bring her, and let me take, and we have Eric here actually also. Let me take down the presentation. Sorry about that. Guys, put your hands together. Enormous applause for Mr. Isaiah Ritchey. Isaiah, thank you, man. I mean, again, I cannot say enough good things about the work that you're doing. Like, you are taking the SEG to a new level, and that is after decades of people like just begging for someone to do that. So thank you, dude.
Yeah. Also, I have a Patreon. It's a small community on Patreon, and every STL file, every dimension is available through through anybody who's on there. I don't withhold any information. I'm not keeping anything secret. It's all publicly accessible. So I'm not going to fall in the lines like people behind me for the last century. Everything is open source.
Awesome. Awesome. Guys, did you want to do discussion? We have about 20 minutes left, or we could go to Eric. Either way, whatever works best for you guys.
Eric's having trouble.
No, Eric, I can hear you though. You're there. You're almost there. There's a little bit of background noise.
I can't figure out how to download my thing. I'm trying to just copy and paste it into the conversation.
So it's probably not going to do that. Yeah, you're not going to be able to paste. So you've got is this like a PDF file?
Yeah, I've lost it though somewhere.
Well, I'll tell you, if you want to email it to me, you can email it to me.
Okay, I'll try that.
Or another way you can do it is on your computer. If you go down to the bottom of that window, you see there's a plus button. Down at the bottom of your web browser window, at the bottom of your window, there's a plus button.
Okay.
On the screen,
So maybe,
turn the middle of
maybe,
the screen.
maybe in the meantime, I would like to have some questions for
Oh,
Isaiah.
plus, there we are.
His stuff is really amazing. So first of all, how strong of an
Slides
effect
and
are you actually
PDF.
seeing? So were you able to actually produce something that looks like a thrust or an inertial changing in the system? And if yes, how strong was it?
Well, so far
Okay.
on this system, I haven't tested for anything weight-wise to see if there's any pulling down or pushing up or loss or gain. Mainly it's been focusing on the magnetism, but I've taken pictures and video of the rollers as they reach a kind of a critical speed that they do float across the surface. The noise drops down. And then the induced rotation, that's the only odd thing I observed once until one roller shot off and cracked, was when it got up to about 570 RPM, the system really quieted down. The vibration went away, almost completely went away. I'll have to rerun that test. But
could that going away of vibration and sound could that just be a hydrodynamic wedge of air?
Okay, guys, sorry. If it's okay, let me jump in real quick. Eric, how are you doing? Sorry,
I'm working on it. I just found the file, but not the edited version, so I'm gonna send you that one.
Okay, sorry about that. Okay, sorry, guys.
go ahead, Drew. What was your question?
I was just wondering. You say that you get to a critical speed. When from what I can tell, you should be generating some kind of a hydrodynamic wedge, so like a thin layer of laminar air between your roller and the surface that it was nearest. So could it just be that you've reached a speed at which you've actually got a surface of air, and now you're just whizzing by on an air cushion? Is that possible, or are you attributing it to some sort of magnetic? I don't know what this thing does, but it sounds like you got a bunch of stuff spinning.
Yeah.
And all of a sudden it stops making noise or something. Are you attributing that to just some hydrodynamic wedge issue, or are you thinking it might be something else, some other energy dissipation or something?
For right now, because nothing's charged either positively or negatively, I believe it's the noise and the vibration drops down because as speed increases, so does centrifugal force. So the roller's pulling away from that stator and loosening its contact, and it's basically becoming almost frictionless. It's barely touching that copper that goes around the stator. So I really believe it's more centrifugal force lessening the friction.
Yeah, I'm guessing you're generating you've got a roller rolling across the surface. If you can do that fast enough, and the force in the layer gets thin enough, eventually you're going to be compressing a layer of air in there. So you basically have an air bearing for all intents and purposes, because the air can't go anywhere.
Correct. And I have taken a photograph of it. That gap is about 0.25 millimeters thick. It's very thin, but there's a line of air between that roller and stator as it goes around.
Okay.
So it's
What,
very, very thin.
for those of us who really don't follow the Searl effect, what's the goal? Why the spinny stuff and the magnetics and whatever?
My goal is twofold. I really want to see if there's a cooling effect to produce cooling without liquids or compression using magnets. The other, the claim from John Searl is that it generates electricity, mainly converting thermal energy or radiation into electricity. That's the claim.
Really?
Joel, did I answer your question? I might have deviated away. What was your question again?
No,
Did I answer it very well?
You basically did, and like Drew's question was also in my direction, so now I understood better. So yeah, thank you very much.
And Isaiah, there might be one thing to add on to that. With your big vertical rolling copper thing, where you're doing the magnet test with that, where you have the roller magnet sitting, you know, with an air space above it, and you can adjust that height there. It's like you're simulating that floating aspect. And with those tests, you've been able to see how that magnetic field isn't just, you know, between the magnet and the copper, but it gets dragged along by the copper, right?
It does. It does. That's an interesting one because traditionally when you're rotating a magnet above the like you got the copper thing and it's spinning and the magnet's near it, it'll just slow that copper down. It'll act like drag because you have these two fields. They're perfectly centered north and south, but when you change it so it's like almost a solid face of south, a solid face of north, it acts like almost like a radial pull. And so that copper doesn't drag anymore, it actually pushes it away. And then when it flip-flops, it pushes that away and just rotates. That's how I understand it.
There's not an instantaneous, you know, magnetic field impressed and then released in that copper ring. It has some decay time. So as this roller is rolling around, it's generating you got so many interactions. You got the stationary magnets right up against that copper on the inside. And then the copper itself is getting a magnetic field in the eddy current. And then the rollers themselves, you got copper around those that are getting their eddy currents interacting with eddy currents. And you got magnets inside that. It's such a complex system.
Yeah. Yeah, it is complex to the nines.
Can I ask you a question? Have you ever thought your setup looks heavy? That means a huge capacity. So, but the air, it doesn't have much heat capacity. So you would have to be blowing a lot of things or a lot of air or be in the different medium in order to basically to test whether you can generate electricity from the heat.
Exactly.
Have you thought of that? Or it's too early?
I have lightly thought about the tests that need to be done once it's completed, and there will be a massive amount of testing it needs to go through. Just particularly, I think my one concern is if that rare earth is worth anything. I'm basing my model, the concept, how it works, off of Roshan and Godin design. You know, they observed cooling in the entire room, and then in 2018 there was a guy on YouTube. His name is Mr. Dolphin. He made an okay replica, but one of his final videos, he had a pure piece of neodymium, not a magnet, just a pure rare earth piece of neodymium that he put inside of his model. And at 200 RPM, it started dropping temperature. He sped the system up to 420 RPM. In under 4 minutes, I clocked like almost frame by frame by frame, watching the temperature dive, relation to speed and relation to time. In 4 minutes, it dropped down to negative 17.2 C, just the neodymium. And it was, when he turned the unit off, it was frozen. There was frost on top of it. And as he watched it on his thermal scope, that coal soaked through the insulator layer, soaked through his aluminum, started going into the rollers. It was like going through the whole system pretty fast. I don't quite understand why that would work. I have done a ton of research with ChatGPT and Grok to come up with some kind of theory of why that is, and they're not solid on it. Neither am I. it could have been hoaxed for all I know.
So what's the expected efficiency of the conversion? Do you know?
I don't know, not yet. I mean, ultimately, my system may not do anything except just sit there as an art piece, or maybe do something really fantastic. I have found a few things, most things I've listed here. The magnetic coupling was very interesting. The spring effect, the levitating across the surface is interesting. But those are so far, because I don't have everything magnetized. I don't have the Teflon polarized yet. So it's like these critical components aren't completed and they're not working yet. So I can't do any.
What did he report it in what did he report in originally, like in terms of efficiency and stuff like that, or is it just a hearsay?
Oh, you mean John Searl?
Yeah.
Wait. From his reports, I don't believe he really looked at any kind of efficiency. His claims kind of, there's a lot of different things he says he did. I mean, his first models, he said he used a tractor engine to start them and a diesel engine. So there was no explanation of how that was connected to his system. Like, how do you have a diesel engine connected to the SEG? How do you connect that? And then other, like his more modified systems, he said he could just basically tap the roller and the whole system would run itself. So my system runs on a brushless motor. I use a Milwaukee battery to start it, to run it. Roshan and Godin, they use I think a 2,000 horsepower engine or 200 horsepower engine to rotate theirs. But it scared them because after 550 RPM, they couldn't stop it. They turned the motor off and the system continued to speed up. And they eventually had to flip the polarities to slow the unit down and stop it, and then install brakes into the system because it was self-sustaining at some point. It terrified them because their system was hundreds of pounds rotating at 550 RPM, and they couldn't slow it down. And the system that held all the rollers in place, theirs was different than mine. Theirs actually had a physical carousel holding these 11-pound rollers, and there was 21 of them. And at a certain point, that plastic would shatter and break. So it freaked them out for a little while until they put brakes on the system.
And guys, so let me see. We're at 154 now. Is it cool if Eric goes? We'll just go maybe at 2. You talk for another 5 minutes or so. Okay, I will be right back.
So very
you guys wouldn't know anybody who has a 5,000 volt capacitor, would you? I'm driving Jared crazy with these questions almost every day.
Yeah, we've got a bunch of doorknob. We got a bunch of doorknob capacitors. What are you looking for?
Film capacitor, not electrolytic. Film capacitor with anywhere between 3,000 to 6,000 volts, and preferably 100 UF or MFD.
100 UF is 100 microfarad.
Yeah,
that's a lot.
That's a lot for it.
That's a lot of juice.
Yeah.
That's a stupid lot of juice.
I'm not using all of it though. I like having the range. There was one experiment I did with 8,000 volts, but most of them I'm only going up to about right under 3,000.
I mean,
that would be a very big one, like I don't know, a few gallon size. I think that's what I would say.
When they fire off, it's like having a 44 Magnum go off in the shop. It's very.
I can grab one right now for you, Isaiah, and show people what it looks like.
Oh yeah, you have it. I had 2 of them. They died. They fizzled out, and I gave him one. That's one of them.
Oh yeah.
Yeah.
So
it's a big honker.
It's huge.
Have you found any theoretical model that could explain the cooling? Because like I'm just starting to think about it. I've heard about it before, but I've never really seen it. And yeah, I'm working in Heim theory, and he has this idea of syntropy, and so in his polymetric theoretical system, there should be a possibility to influence locally a lot of stuff that is in standard model physics should not be influenced in that way. So the claim that in the middle of the structure, which is a symmetrical, interesting point in such a complex system of changing, moving electromagnetic fields, right? That they're like locally the heat is like random movement of particles, right? So that reduces. That's a very interesting claim. So maybe go to the Heim theory website, download some of the books and pages, throw it into your large language model projects and ask it, does it make sense from that perspective? Could help. I have no idea. I've never thought about it in that way, but it should at least be possible to do something like that from in the theoretical framework. If this kind of setup should be able to do it, I'm not sure. But yeah, just an idea. And so the basic question is, did you find any theoretical explanation for how that would work? Because I would think that it would basically violate the conservation laws in every other framework, right?
Yeah.
So yeah. Okay. So in Heim theory, you can get around it because there is a deeper structure of reality. And if you influence that, then you're not violating the conservation laws because you changed something in the equations.
Right. I have personally talked, it was a long time ago, but I talked to one person who worked on the Roshan-Godin project, who saw it work and everything, and he saw it firsthand, the cooling. So it wasn't just like the Mr. Delphin. That's a YouTube video. I never saw it working myself, but I talked to a guy a while back, and he used to see it work, and it literally dropped temperature. It's freaky weird.
For people that want to see more about the Roshan-Godin tests that were done in the US, it's called the Morning Star Energy Box. Is that right, Isaiah?
I believe so, yeah.
By Brandenburg, longtime APECer John Brandenburg, and Paul Murad worked on that. And even though the original Roshan-Godin guys saw like 27 to 30% weight loss, it was duplicated and confirmed at around 7% weight loss by the American guys, and that cooling that Isaiah talked about, where I forget the total amount of 20 degrees or 40 degrees Fahrenheit, like in a few minutes kind of thing.
Yeah, dramatic change.
That's also fast, yeah. And did they report that anything else heated up?
With the Roshan-Godin, they had the magnetic walls, they had the weight loss, or depending on the direction, if they went to counterclockwise, it gained weight, the same amount of weight. It all depends on the direction of rotation.
Mm-hmm. Okay.
Well,
and
where's the heat going? If you're cooling a significant cooling event, the heat's going where? Into the spinny things?
That's a question. If the center is cooling, is something on the outside heating up, or is structurally something's changing? So you're basically breaking locally the conservation laws, but you do it.
Yeah,
it might be possible if you do it in
where's
intelligent
the heat
way.
going? Or where do you think it's going?
I don't know. I know, like on dolphins, it was the neodymium core, and that's the part that got real cold, the rare earth. And because it just kind of everything else was around it, these layers started getting cold because this was frozen. His looked a little different than this. But when Searl did his first several ones, he said they went to like liquid nitrogen cold. Like he touched it with his hand and he couldn't get his hand off of it. That's just Searl.
And Searl also had like a geometry, right? The double donut
double
type
helix
geometry.
Toroid.
That was how he envisioned the energy coming into it and going out of it and everything.
But that's a good question, Drew. It's like, well, where's,
So
my thing is like,
it's almost as if it's dumping energy into, subspace, for lack of a better term, because it's leaving the room.
They're putting it into the vacuum background, and you're getting it back out with your device.
It's basically you're pumping energy somehow via magnetic something into the vacuum, down on the Planck scale or something. That's interesting.
The other part too was the anti-gravity part, right? So it seems like it's futzing around with the local entropy somehow, right? And there's some models for gravity out there where they take like an entropy approach, saying that, how the information is decaying or getting transferred between these spots of space-time is like, that is gravity. So it's just some weird, interesting potential overlaps there. And also, Isaiah, wasn't there something about a pink glow around the thing?
His first model that flew away, and I nailed it down to almost within the day when he launched that model when he was 14 and a half. And it was only about a 12-inch wide model with a few rollers and homogeneous, not layers like this one. He took it off. He had it working in his kitchen where he was staying at, and he turned it on and it shot up through the straw roof, and then it didn't just continue going, it stopped in the air, and he was able to hear it buzzing higher and higher and higher frequency, loud, like not louder, but the frequency was increasing in the auditorial range, and it started glowing pink. And once it reached, like, you couldn't see the device, all you could see is this pink bubble. He said it shot off like a bullet and never came back. Interesting. I've heard this in other UFO reports and other experimenters that people around hit the street up and down, you hear all their radios come on. Radios and TV sets. It was 1946 in the November, was it November 26th, I think it was, or that day I sent you, Jared, or early December that happened. One of those days. And as soon as it left the area, all the radio sets went off. It was kind of odd. But that's just, nobody else saw it, just Searl, so it's kind of hearsay.
Yeah. And guys, we are at the top of the hour. Is it cool to move over to Eric now?
Maybe one last comment, because I just thought about this.
Is my
So
mic
from-
okay?
From Curtis Hearn's,
Somebody said my
we
mic
can hear
was
you
giving
great,
some
Eric.
feedback.
Yeah,
Can
no,
anybody hear
now
me?
it's gone. Yeah.
You're fine. Yeah, you're fine.
You can hear
So-
me okay? And there's no feedback?
Yeah.
Because I don't even know. I've got 3 mics here, and I don't know which one's on or off because I can't.
No, I would just leave it the way it is, and you're rolling, sir.
Okay. Not a problem.
Okay. Sorry, Joel, did you want to go real quick?
Yeah,
Sorry.
one really quick comment, Isaiah, if you're still there. So I just thought about it from Curtis Horn's perspective, because he works in, he developed his own theory now, UQFT, which is very interesting, and also I think very close to what Heim envisioned. And he has this loop holonomy as a big part of his system. And in the center of your thing, you should have a closed loop holonomy geometry, which might actually change how there could be an explanation within UQFT for the cooling effect, at least. So you definitely should look at those two frameworks to see if you can find a theoretical answer or a theoretical clue, even how to better engineer the effect.
I'd love to find even a theory. I want to see something.
Well, and if it's okay, let's table this one for now, guys. Let's table this one for now because we're 5 past. So thank you. And guys, again, one more time, put your hands together for Mr. Isaiah Ritchey. Isaiah, thank you. I am so overjoyed to have you do the presentation. And again, your videos are on the Alt Propulsion channel. If anybody hasn't seen those, they absolutely need to watch them because you are walking the walk, and that is what matters.
Thank you very much. Thank you.
Okay, so I'm going to take everybody out. Apologies for being a little bit slow. This is my fault here. Okay, not organizing things as well as I could. So, Mr. Eric Biggio, you emailed me earlier in the week. Let me put up your slide deck. So this is, let me see, you have several. Okay. So this may appear a little small, but people can boost the size of this if they're on YouTube. We're recording at 1080, which is true high def. So I can read this on the screen. They'll be able to read this as well. It may appear a little small to you or myself, and that's not something I can easily fix. There is a maximize button down at the bottom of the screen if you want to use that. But are you able to read that, Eric, or do you want to try and make it bigger?
I have my own copy.
Oh, okay. Go for that then. Go for that. And then there are slide buttons. If you put your mouse over it, there are slide buttons. If you move your mouse over yes, there you go, sir. Yeah. So what I'll do is this. Again, thank you so much for presenting. You have a mechanical inertial device, but it is kind of gyroscopic in nature. And so you sent me a really excited email earlier this week, and I was like, oh, well, maybe we could get you to present. And so you went out and did a bunch of work. You got your microphone all set up. You got your computer set up. Let me thank you for that. Thank you, sir. And yeah, I would love to get this out there. I would say, take it away. I will be here in the background. Just let me know if you need me. And if you want to put up photos or anything after the paper, let me know, and I'm happy to help.
Is anybody else here? Is anybody
They are, but
listening to this?
they're in the background. They're in the background.
Oh, I was going to ask for questions later, and I didn't know if anybody's even listening.
After you're done, I can bring them back in. Yeah, we have 1, 2, 3, 4, 5, 6, 7 people in the studio, I think, the folks who were just on the screen. And then we are also streaming live. And so we're streaming live to an audience of several hundred people, and then several thousand more will watch it in replay because it goes up on YouTube and Twitter, so they can come back to it at any time.
That's not going to scare me to death.
No stress. Another thing that I do is, this is lately I've been doing this. I have been splitting up conference sessions. I have been transcribing them, and then I've been using AI to write stories as well as drop them as individual videos. And so what I'm trying to do is just maximize the exposure for each presentation. And that's the best way that I know about. And like I said at the top of this, and you had mentioned Jerry Decker, right? Our community, we have a small community. It goes back 75, maybe 80 years. It's one of those things where when folks are really into this, everybody knows everybody. And so the whole idea behind APEC is just sharing, right? Because all of us have more power than one of us at a time, essentially.
Who knows? Keeley might have had something.
Okay, so let me take myself out and take it away, sir.
Okay. Introduction. My name is Eric Biggio. I'm a boomer who grew up as an Army brat and served on the front lines in the Cold War or during the early years. Those familiar with the Big Bang series would probably categorize me as a Sheldon, although I would see it the other way around because, in point of fact, I was actually diagnosed as a young man as a mechanical genius. My family settled in the D.C. area where I spent most of the rest of my time living in Arlington, Fairfax, Sterling, and Loudoun counties before returning to the old homestead in Arlington when my parents passed and left it to my brothers and me. I've gone to different colleges and things around here. I got an associate's in automotive technology at the local community college. That's pretty much it. Except if I see a puzzle, I always have to solve it. So between Rubik's Cube and anti-gravity, here I am. Now, this is the first rotors I started out with in my project. They were large and round, and all the weight was on the outside edge. This is what I've gone to finally. This is twice the weight, but it's much, much smaller, so there's less problems with it killing the bearings. Anyhow, that's a side note. Well, thanks to Tim here, I went online and sought to find a reasonable and coherent explanation of the gyroscopic or spinning top force. Once again, I was hard-pressed to find anything more than the garbage they had taught me in my high school science class. I've long since seen and acted on a much better and more logical solution to this enigmatic actor. Yes, that's what Merriam-Webster calls a force, something that acts on matter that accelerates it in a particular direction or vector. Having taken to heart the suggestion made by Eric Lathwaite, everybody should be familiar with him probably in this venue, I spent quite a bit of time experimenting with and analyzing the actions of a spinning solid, because everyone could see he got that weight over his head, and other people replicated that experiment over and over again. And it looks like you're getting some kind of anti-gravity effect. But science tries to explain it away with putting the weight somewhere else and all that sort of thing. But you could see the weight was spiraling up around him. And I couldn't get out of the back of my head that something had to be going on there. And I finally figured out what exactly it was. And it took a long time and many experiments. Now, at the beginning of the nuclear age, we were given a formula by a renowned mathematician, Albert Einstein. It showed that at an atomic level, there was equivalency between energy and matter. Unfortunately, Mr. Einstein couldn't seem to get his head around the physics aspect of this equation, and he tried to placate the scientific community by forcing the laws of Mr. Newton to be maintained. When Newton, who was a 15th century observational physicist, wrote his Principia, he had no knowledge of atomic structure. It took years after his death for the scientific community to build a coherent structural model for the matter that surrounds us. We now know that the majority of matter is held in place with an electromagnetic balance between positive, negative, and or neutral particles. The nucleus of each thusly constructed atom is the determinant factor in its mass, and generally has a positive electromagnetic charge. A cloud of electronegative particles, often called electrons, surround the nucleons, maintaining their spatial integrity. As my experiments progressed, I soon realized that the thing that made a solid was the unique outer negative particles bonding. The tighter the bonds, the harder the substance was. Even more important was the fact that pushing the solid away from its plane of polarization at a particular point led to a reaction. Wait a minute. Have I lost some here? I'm getting lost. Part of the substance. Even more important was in the fact that pushing a solid away from its plane of polarization at a particular point led to a reaction that was offset by 90 degrees from the vector of the push. This led me to the possibility that it was following the right-hand rule effect attributed to an electromagnetic field propagation. It was immediately apparent that since this was an internally propagated force, it must be coming from electrostatic balance between the atomic particles. At this point, I should probably break for any questions because it gets a bit more complicated from here. I'm getting lost. I hope I have these in the right order. Maybe I should read it on the screen. And that's too small there.
Yeah, and Eric, let me come in for a sec.
Oh,
I was going to ask you, so you're on slide 2 right now. Is this the correct one? If
yeah,
you want,
so.
just say next slide. What I can do, why don't we do this?
Yeah,
you can read from your paper and just let me know what page, because it looks like each page is a slide. So just let me know what page you're on.
I finally figured out how to do it. I've got my thing and it's blown up so I can read it now.
Okay. Yeah. Again, I'm here to help, sir. Just let me know.
Okay. I'm sorry, I got a bit lost there. Okay. But I'm not able to ask for any questions, I guess. So I'll just keep on going. Okay, now that the basics are out of the way, it's time to accept the gravity of the situation. As I was experimenting on the spinning flywheels, at one point, metal fatigue allowed the flywheel to break free of its constraint and go flying across the room. A quick analysis of the situation led me to believe that this was an unfounded reaction when everybody, I don't know, I thought I'd put that in there. Uh-oh, I think my editor took it out.
Unknown caller.
Uh-oh. Sorry, got a call. Well, anyhow, to make a long story short, I realized that the force of a angular momentum in a solid is all concentrated on the outer surface. And the reason for that is because the weight of the structure is all in the nucleons. And the polarization that is created when you spin a solid, call it the spinning top effect, basically, is caused by the nucleons being thrown outward through centrifugal force. Simple as that. And they're thrown outward in a plane that is the plane that the initial force that whatever pushes them initially, the initial vector, and the plane propagates from 90 degrees to that vector. So you have your first layer of polarization there. Now, when you start trying to move that object from that plane at any point along the thing, and you push it with another vector force, pushing force, it tries to move according to the right-hand rule. It doesn't move where you push it. It moves 90 degrees from your point of pushing it. And it's just a right-hand rule thing. And that's what gave me the key that you were actually creating an imbalance between the nucleons and the outer electron shells that was adjustable, because it's mostly just air. Or, well, there's no air there, basically. It's just vacuum. Every atom is basically a big vacuum of space. And the only particles there are the nucleons surrounded by a bunch of negative. Well, actually, it's a cloud of electrons, more akin to photons than actual particles, because they're in a constant state of flux. Anyhow, where are we going here? I'm losing my thing. Okay. What is gravity but a force? A weak but persistent force. The only thing is it's a pulling force. It constantly pulls at all the inertial pushing forces and degrades them through that. Unfortunately, we never end up flying off into space as the Earth bees around its axis. What can be used then to, what are we having? I'm trying right now is to finish this counter. A pulling force? Wait a minute, I didn't write that. Oh God, my editor screwed this all up. I'm sorry, I'm so sorry. Anyhow, the basic thing I was trying to get across is that I was able to get lift by polarizing the forces so that they combined together and gave me lift. Now, I'm not going to be able to give you how they do it, because Tim doesn't really want me to let anything out that might complicate the situation, I guess. But there is a formula and a way that the shift in the electromagnetic stasis when you're going around in a circle, because the fact that you could move the thing around in a circle and it would lift over your head is because when it shifts the polarization, you begin to go, the front part of the flywheel goes like this as it goes around in the circle, and the back goes out, the front goes in. And that causes the already thrown out nucleons to go back and forth, and they go from front to back of a spinning solid. And as they go back and forth, you're getting a linear motion of already energized, because they're out of their normal center of balance, electrostatic balance. And so like an electron that's given an extra energy enough to jump between a bond to a next one in a wire, during that small period that it goes in a straight line, it unwinds with an electromagnetic field. That's why you have electromagnetism come off of a conductor conducting a stream of electrons. But protons, where much more energy is involved, when it starts moving protons and positrons and nucleons back and forth inside an already elevated imbalanced force, you have other things happen that can be used to propagate a transfer of energy that affects and is affected by gravity. I don't want to explain too much right now. It's just that I have built a prototype and it works using this principle. So I guess that's all I'm going to be able to do, because I'm totally lost on this thing. That I should have probably rehearsed this much more.
Okay, and Eric, I am still here, my friend. Do you want me to bring the guys in and you can talk about it with them?
Well, if they want to ask me anything, yeah,
yeah.
I'm an
So
open book.
let me
I'm
do
just
that.
trying to get this out to the world, basically.
No, absolutely. So let me bring the guys in, and before anything else, let's do the. Let me see. We've got that's the whole crew. Guys, please put your hands together and give Mr. Eric Biggio a giant applause for the presentation.
No, it's horrible. Don't do that.
Well, no, we applaud for everybody. This is your first time you're using digital technologies you're not familiar with. You're trying to juggle. There's more going on that people aren't aware of in terms of juggling technology.
I just didn't do a presentation with it.
Yeah. So you sent me a photo also. If you want, I can try and find that and put it up. Is that something that you'd want me to post, Eric? Or?
Well, I don't care. I don't remember what. Did I send you a thing showing how far you've gone up on
you did. Let me dig through it.
Tim, can we ask questions?
Yeah, go for it. And I'm just looking for his photo.
Eric, I gotta tell you, man, I'm lost. What is this thing, and what does it do?
It uses centrifugal force to polarize gravity in a direction that is an exact opposite to what its normal force is. In other words, it turns gravitational force into a upward force.
Okay, so
it reverses it mechanically.
Is it the shape of a frisbee or something, or?
It sounds crazy, but it works.
Great. What's the shape of the thing? Is it a yo-yo, a frisbee, a square? What are we talking about here?
It's a series of rotors like this.
Yeah,
okay.
Just a sec.
Or this.
I'm going to find a photo.
Either way.
Okay.
They're just still rotors. And because they can be polarized in a single plane. Now, when you take that and you move it this way, it tries to go this way. a lot of people don't notice that, but that's one of the facts of what happens whenever you have a spinning top and it tries to fall out of its plane. It automatically rights itself, you know?
Yeah.
And that force is internally propagated. You have to realize that this is all happening inside the substance. The forces, when you build up angular momentum and it goes into a plane, that plane tries to stay and keep the thing in that orientation. If you try to reorient it, it will make a motion in a different direction. That's 90 degrees from the direction you try to move it.
Okay,
and
so
that's
if you took this thing and put it way out in space away from Earth, no planets, no nothing, way out in space, and you did whatever it does, you spin it up or you charge it up or whatever it does, would it begin to accelerate on its own volition? Or would it just sit there and sit there? What's your thoughts on that?
Is it in a gravitational field? Because
way out in space. There's nothing else
way
around.
out in
It's all by
space,
itself.
Can you see the stars still?
Sure.
Okay, then you're in a gravitational field.
Okay, let's do a thought experiment in honor of our German friends. You're in no gravity field. You fire this thing up. Can it move, or is it 100% dependent on someone else's gravity field?
Well, you'd have a gravity field. All matter has gravity. Gravity is a force, a negative force. It's a pulling force.
Actually,
all matter is trying to attract all other matter.
Great. Let's play. I give up. Thanks.
So as long as you have matter, you're going to have gravity. If you're in a universe with gravity or with matter, you have gravity pulling on all the forces in that universe.
This is correct. This is Mach's principle, for example, if you look at that. But whether, it takes time or not and all stuff like that, but that's what it is. It's this. Some people say that's where inertia comes from.
Okay, and I should apologize. So the file, Eric, the file that you sent me is actually on my phone, which is right there because I'm using it as the camera. So
okay, you want me to put it up?
Yeah, if you want. Yeah, I would say go.
No,
go for it.
I really.
Okay.
It's kind of irrelevant. If they can't take my word for it, that I got.
Yeah, no, I get what you're saying. Yeah, and I think that Mikolaj nailed it. You're describing Mach's principle. You're still in a gravitational field, even if you're out there in space, right? So, yeah, that would be kind of Mach's principle.
So what exactly do you mean when you say polarizing gravity? So you're basically saying that you can turn the arrow in the force arrow in which gravity acts upside down?
Yeah, basically you take gravity is a force, and when that force interacts with matter, and matter is basically energy that's spun up in 3 dimensions, then you're adding a single plane force to one of the dimensions. And it's like when you have a populated atom and it starts radiating energy out because there's too much matter in it for the electron shells to contain it. Radioactive substances that are so heavy, they start radiating off energy. But this is all straight line things. I don't know how to explain this to you, really. It's just that it's because the gravitational field is coming from a straight line direction. That force going in that direction adds to the matter in this thing. The matter is now spun up in 2 dimensions when you're in this construct that I put together. So you have 2 different dimensions of spin. And in order for it to exist as a new piece of matter, because if you have gravity hit it, it will have to be going in another dimension, and it'll be 3-dimensional, and it will create faux matter. In other words, it'll try to create matter where it can't exist because you have too much matter for the electron shells to balance it off. And I didn't want to have to get this complicated with everything because I didn't want to give out some of the real secrets here, which that's one of them. That what you're doing actually is creating an imbalance inside the nucleons. That they cannot grow any bigger. In other words, when you say that you get more massive when you go toward the speed of light and all, matter and energy are interchangeable.
Well, and Eric, let me jump in again. You do not feel pressure. Do not feel like you need to share anything more than you feel comfortable sharing.
Well, I've been trying to get this out to the world. NASA just ghosted me for over a year, and I've been trying to tell somebody how obvious this all is to me now because I've been experimenting with it, and I've finally got it to where it works. And it only can work if this theory is right.
So what you're saying resonates with me because look, I'm working in a framework that gives particle a deep internal structure that is cyclical, and UQFT from Curtis Horn is also going in that direction. So I think I kind of understand what you're trying to say, and thank you so much for expressing it, even if it's maybe more than you wanted to express to like protect your like the value that you're building.
I don't care if anybody gets the idea and understands it. I've got a patent on it, it's
perfect.
Irrelevant,
So the next question I would have, just to clarify if I got it wrong. All right. So your device, does it produce a net force on the whole center of gravity, on the whole center of mass of the whole device, or does it just redistribute internal forces through the frame? Because you said that's the question basically.
See, what it's doing is it's influencing gravity by taking the gravity that's interacting with it. And if you go backwards, with your precession, you actually go the other way. It goes down. It increases the gravitation. It goes with the gravitation. So you're unwinding the nucleons in a different direction. And that's all this is. It's winding up nucleons in 3 different dimensions. And I don't know how much more I can explain about it, but that's
fine. Thank you so much. I think Jared has another question for you.
Okay.
Yeah, Eric, it's an interesting idea. I want to try a different thought experiment on this to see if I can understand how your device would work. So if you were between the Earth and the Moon, and you were in this sweet spot where they're both pulling equally on you, right? So you're not getting pulled one way or the other, right? The balanced gravity point between those two. And you put a gyroscope there so that gyroscope is spinning with its ends pointed at the Moon and the Earth, right? Are you saying that gyroscope is going to naturally pull one way or the other, or that you can turn that gyroscope in a way where it could select one of those two? Or does the fact that the gravity is balanced to that point make it hard for your
These aren't gyroscopes. That's one of the keys. See this rotor? The rotor is hollow. It's not sitting on a axle. Now you're talking about gyroscopes. This is not a gyroscope.
I say gyroscope because when you talked about turning the thing and getting the direction, that's the gyroscopic precession concept, right?
Yeah, but this artificially processes spinning rotors, but not gyroscopes. In order for a gyroscope to work, it has to have an axle, and you take the polarization off the axle. In other words, it's polarized in this plane. As you try to move it off that plane, the axle is affected, and that's why it shifts all the force out to here. But this works by not being supported in the middle. I actually have it spun up with O-rings, so there's no solid connection, because this all takes place inside the width of a steel atom. You know how fat a steel atom is and how much space is in there? If you have a gyroscope and it tries to fall in a gravitational field, you know how far it falls? Less than the width of a steel atom before it starts processing. Because as it falls, tries to fall, it doesn't actually really fall. It tries to fall. It's more of a force. You know, Tesla kind of tried to impart this to everybody, that it's the force, you know. That's why AC works better than DC, because you can actually move the energy without moving the physical electrons if you get a high enough voltage at AC going down a conductor, you know. So it doesn't fall down very far at all. It's more the force pushing down, because that's all the gravitational needs you have. I mean, it's hard to explain. I don't know how to explain it any better than that.
Okay, so not calling it a gyroscope, just call it whatever you want to call it. It's at L1, Lagrange 1. Earth that way, moon that way. This thing spins up or does whatever it does. Does it drift toward the moon, or does it drift toward the Earth? Or does it not drift at all?
You spin this up and you drop it. It will not affect anything about the gravitational influence on it if it just drops in the gravitational field straight down.
Okay. Obviously, one of us doesn't understand what Lagrange means. Lagrange means you have equal gravitational force between the moon and the Earth. You're at a spot in space. Irrelevant. If you take that thing and put it at that spot, will it drift toward the moon or drift toward the Earth, or just sit there and spin?
It's irrelevant.
That's the question. So the answer to the question is it's irrelevant?
Yeah.
Okay, that's a terrible answer.
I know. Because your preconceptions are that this is being influenced by the gravitational forces of the Earth and the moon. And
our preconception was, we asked you, does that thing produce its own thrust? Does it move of its own volition? That was the question.
It can, but it has to be in a gravitational field. And
well, it is in a gravitational field. At L1, it's in a gravitational field, the Earth Moon.
Well, so okay, maybe we could split the difference here. So I think I kind of get it. Again, I'm looking at this maybe from a Mach's principle perspective. In that case, if it's in a gravitational field, if it's doing that Mach's principle thing of basically pushing against the ambient curvature or time space, then it would move in the direction of thrust, right? Wherever it's pointed. So it wouldn't necessarily move against or towards the Earth or the moon specifically. It's more like it's in a large gravitational field. It has something to react against in that model, right? So then it's going to move whatever direction it's pointed.
It'll probably start falling into the sun, but that's beside the point. The point is there's gravitational fields all around us all the time. You can't escape it. It's like you don't even realize it, that there's zillions of neutrinos flying through your body every second. This entire galaxy is awash with neutrinos. Every time you see a light out in the sky, there's a zillion neutrinos associated with that little star out there that are going through your body. And I didn't want to get this involved, but it's true.
Which way would it go? Dude, of the 6 people on this panel, we all get it. We all understand the basics of physics. We asked a really simple question. It sounds like if you put your thing at Lagrange 1 or any other place in deep space where there's no real gravity around, and you turn it on, it will just sit there. That's what it sounds like from your lack of answering the actual question. Am I missing something here?
Yes,
Jared, help me out. Does that what it sound like to you?
There is
point
no
it. Eric, you're saying you
gravity.
can point it where you want, right? You can say lock onto that gravity field or lock onto that gravity field. Is that what you're saying?
More or less, yeah.
Okay. Yeah.
But it's more complex than that. Gravity is it's different than what most people think it is. You know, they don't even realize that it's created whenever you create matter. It's the void inside the matter because the matter is created with an outside push outward. And therefore you have a backside that's a vacuum of energy. In other words, it's pulling and trying to get energy because, and this takes explaining the Big Bang to everybody, which wasn't a Big Bang, it was big whoosh. There was no bang. There was nothing that existed at that time. You know?
This sounds like a weird spin on push gravity. It's almost sounding with it's like
pull.
The perpetual thing that Lesage was chatting about 300 years ago.
Gravity is a pull, not a push, but it's a force. It affects matter, so it's a force.
Yeah. Yeah.
So
yeah.
I found.
And, oh, sorry. Go for it.
Sorry. So I found your. Sorry. Do you have more on your theoretical works in written form? Do you have a paper or something that you published, or would you be able to write up, or would you be willing to write up more about your theoretical background of your article, basically? Because I think, it's hard for us to understand because it seems that you have built a complete theoretical background on which your device and on which the effect works. And you haven't explained that to us, and there's no way for us to really understand what you're trying to say to us without the deep understanding of the theoretical background that you have in your head right now.
All I'm trying to say to you is I've found a mechanical way to create a force that will push against gravity and get you into outer space, basically.
Yeah.
And it works by rotating a mass, right?
A mechanical means of countering gravity. That's all it is.
See, and I think part of the challenge is, and this is something I think everyone struggles with, is you're working on experiment and a model at the same time. And that basically, that means you have to kind of fight 2 battles at once. You know what I mean? Like what you're saying is the experiment validates the model, but then at the same time, that gives you a bigger surface area that you have to deal with. You're not just focused on one. It's like, what is it doing? And then how do I explain and predict what it's doing? And that makes it a challenge. I think everybody struggles with that in one way or another.
I'm not struggling.
You're also not explaining. That's the problem.
I'm not really at liberty to explain everything that is going on in the universe.
Okay. We're not asking how this thing works. We're just asking what it does. You're saying that if you turn it on, it shoots into space. Great. If you start from space, will it shoot back down to the Earth?
If you point it in that direction, yeah.
Great. If I'm in space and I point it towards a star, will it go to that way?
Yeah, I just explained to you that if you go this way with precession, and this is all about artificially processing a spinning rotor going around in a circle that basically is like what Eric Lathlake did with the thing.
Yeah.
If he had tried going the other way with that thing, it would have gone boop, right into the ground, because it is influencing gravity, and gravity is being influenced by it.
So the precession is what gives it, and because the precession is a right angle. And so the precession is
It's
what is
all
giving
about
it the,
spin. Yes.
yeah.
Gravity is actually a spin force. I proved that too with this model. It has angular momentum associated with it.
Yeah,
But
Eric, that's amazing, man. That is amazing. And actually, Denny, if I could jump in, Denny just jumped into the studio. If it's okay, let me bring him in as well. Denny, welcome and thank you, man. Thank you.
Oh yes, no, it's my pleasure. I'm on Chrome, and I'm hoping that I'm not like
Yeah, no,
lagging a
looks
bit.
great.
I might have. Yeah. So yeah, I should say, minasan konnichiwa. So from speaking from the loveland of Japan, probably about.
And I owe you many thanks, because in Japan it is like tomorrow, super early in the morning. So
Yeah, not a problem at all.
Yeah, do you guys want to keep doing discussion so I have Denny's in about 10 minutes, or we could go to Denny's presentation early? It's up to you, gentlemen.
please.
Oh, okay. Okay, well, Eric, thank you. I genuinely mean that. I love it that you were able to do presentation on this. I love it that you were able to describe it. It was amazing having you on. And again, so guys, let's do this. Let's put our hands together and give Mr. Eric Biggio one more applause. And Eric, I would love to have you come back and give us updates as you continue to work on this, as you continue testing and experimenting.
Yeah, I'm going to be doing the one I did that I got 1.5 inches on. It was built so it would only lift for a few seconds. I built it with a power supply that broke away as soon as I hit the precession. So these rotors actually degraded in their angular momentum because the motors that were propelling them no longer had input. And that's what kept it from going up through the roof. Because ordinarily, if you have this thing and you eventually make it out in space and there's no friction, this would go on forever.
Yeah.
It just has to be given an initial thrust of energy to basically trigger it. But,
well, and I hope that no one seemed too critical. I think the challenge is, and again, we all struggle with this, because this is an engineering culture. Sometimes it can be difficult to communicate those ideas because you have a lot going on up here, and then translating that into words, right? Especially if you don't have a ton of audio-visual stuff, that can be a challenge. Joel, go for it, sir.
Yeah, thanks, Eric. Thank you so much for presenting on it. And I would love to see you back on here, and I would love to see your device actually, like a video of your device, how it actually looks like, how it works when it's active. So for the next presentation, I know it's hard to do computer graphics or stuff, but if you could show some pictures or video of the device when it's active, if that's okay, of course.
I'm getting ready to cannibalize it. This was the old rotors. This is the new version that I'm going to be building that will be something for the Goody Prize and will be able to maintain lift for a prolonged period of time.
So the Goethe Prize in Germany?
Yeah.
Interesting. Yeah. Very interesting institute. Cool.
It's like Gödel. Am I thinking of the right Gödel?
No, it's a Goethe. It's just
Gödel.
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 Yeah, but the institute is Goethe Institute in Germany. It's just a rich German person who is very interested in anti-gravity research. Funded an institute. Yeah.
Take a look.
I just got in contact with them, and it's a very interesting institute.
Pays better than the Nobel. I'm greedy.
They have some high prizes up there for interesting stuff. I have some. Yeah.
But and Joel, just as a quick, so Joel is going to drop by here. He's Joel is touring our wonderful country, and you're going through Seattle. I swear to God, we've got like 1 month of sunshine here, and you're getting it. So, yeah, so that is awesome. I've thought about going to Germany also. There's some really cool projects there. I'm doing a podcast next week on a fully photonic CPU. Like it's brand new. It's like prototype phase still. So, and I think that's Berlin, but
Very
yeah,
cool.
it's some really cool stuff happening. Okay, well, guys, let's do this. Let me take everybody out. Again, big thank you to Eric. Yeah, and Eric, I would love to have you back. Denny, welcome, sir. You are, I don't even know how to say it. You are a genius. I'm just going to out you. You know, that way people know. Your emails, when you were going through your emails, I was like, you know, you nailed it. Absolutely nailed. There's no other way to describe it. And so you have done a ton of research into anti-gravity and emerging propulsion and stuff like that. The one that got me was, for me, this is almost like the one that got away, was the Repulsine. Let me put the slideshow up. You built a replication of the Repulsine. And of course, you're using CAD, you're using 3D printing, additive manufacturing. So you're bringing Schauberger's work into the 21st century too. It's absolutely brilliant, man.
Yeah, absolutely. Well, first of all, thank you, flatteries. I'm just a normal layperson. Really liked science, and so actually that's why I went back to school. I took a period like of 4 years where I was doing a lot of independent research because I was met with a lot of resistance within traditional.
If it's okay, before you begin, if it's okay, let me take myself out, and that way. And I will create a breakaway too after I take myself out. I'll create another video for this, and I can put it up on APEC and get you some more promotion.
Please. Yeah, it'd be my honorable pleasure. Okay, so I suppose may I start speaking? I guess I can begin with this presentation. I'm not sure, but for those who don't know, my name is Denny Okudinani. So I studied physics and computer science at Georgetown University. May not be the brightest classroom student, but I am definitely probably one of the more sharper ones when it comes to hands-on research. About 2 years ago, maybe 3, I don't remember, I got bored and I wanted to apply some of my CAD skills to replicating some of Schauberger's work. I have always respected Viktor Schauberger. I've actually been following with a lot of this stuff since I was in high school. So, you know, I'm like crustacean of the internet. So whatever I can find, I just go and I consume naturally. And it just so happened that, when I was looking at my old stuff that I've scrapped up, I had enough like images that I could conceive of how I might design certain parts. Now, an argument I'm going to make towards the end of this presentation is that all of the Repulsines that we've ever seen today that have been documented in terms of pictures are most likely never flew. They were probably some sort of prototype or prototypes, which are intended to demonstrate fundamental principles like Schauberger principles, which could be used for a Repulsine which actually did fly. Now, I'm also making the argument that there's more than enough evidence and eyewitness accounts that there was a Repulsine which did fly. And without going into all of the nitty-gritty technical details and making a pure and hard science of it, just like workable science, we're going to go into maybe how that Repulsine would have worked and then some adjacent things as well. He also had a submarine that has some good attributes. You'll see things like a common thread like the diaphragm. So without further ado, let's get into this. So here we are. And so the roadmap today is going to be background or intro. I like science. So I'm going to spend a bit of time kind of clarifying, well, what science is within the world of, well, just in terms of science general. And then we're going to dive into who Viktor Schauberger is, because there's often a lot of misunderstanding with the stuff that Schauberger has done. He's often labeled as a pseudoscientist. And I find that a lot of people don't even know what that means. It's kind of thrown around like the word conspiracy. And that doesn't work to scientific progress. And I'm all about people going out there and doing scientific research. I love scientific research, or loved, still trying to keep that love, even though it's been pretty hard to do with the mainstream. So that'll be part 1. Then part 2, we'll talk about what is implosion. Implosion is key in describing any of the systems that I generally do research on. So if you talk to any normal physicist or engineer, most of the time, if you're ever going to try to talk about a system which is not like spitting something out, they're going to say it violates Newton's laws in some ways, unless you're using a provision, a working provision that comes from a technical framework that, mitigates this or like incorporates Newton in some sort of way with like more modern physics. And the reason for that is because physicists and any kind of operational engineering works from the principles of explosion. Implosion hasn't really been well known. And if you start describing implosion, it often sounds like bootstrapping, and it's very distinct and very different. Implosion as a science is, you can work with it operatively generally. I use a very distinct formalism of Mach. I didn't even know I was dealing with implosion when I first started this field. But Viktor Schauberger is basically the grandfather or the father of implosion technology. His mind is incredible. Working with Schauberger is like talking about Carl Jung. His work is voluminous and he uses very distinct language. And so it's very easy to say Schauberger is kind of an esoteric, person making up his own cocktail of things, but he wasn't a technically trained scientific person. So he's not going to go and invoke something like, Archimedes' principle or Bernoulli's effect. And so that's important. So moving on, part 3 will be the working science. So there is a working science, and I have generalized a few things, but I'm not going to have time to go into all of those things I've generalized today, especially in terms of the math. How I don't like the math, but it's helpful for those who want to go and apply certain principles. I'll go over 3 important things within the working science. So basically, we're going to talk about the PKS method. I'm not going to explain how it all works, but this is the approach that was refined by Viktor Schauberger's son, Walter. And then we'll go into Mach's principle, because the way that we can justify implosive systems, or at least the way that I've been doing so from the provisions of just normal science, without trying to invoke anything new, is by using Mach's principle and a really unique, distinct articulation of Mach's principle. And then we talk about the fluid dynamics, and we don't get into too much of the nitty-gritty because it can really get messy. Anybody who is an actual expert on fluid dynamics understands that. Hate the math. It's a headache. But to describe what are going on, I mean, these are technically fluid mechanical systems. So by necessity, they necessitate something called, kind of putting myself a circle there, something called solitons. And solitons are just basically these wave packets that travel at a constant velocity. And they're mechanical when they were first discovered, or at least articulated in the 1800s. But when we're talking about them in terms of Schauberger's work, and actually in any work, when you're going to find with like implosion, we're also going to need to touch on Helmholtz theorems, which is also often overlooked. A lot of these things are used for very like nuanced things in like physics and other engineering, but their principles of operation actually do scale quite large and apply, especially within implosion. And finally, we'll look at Bernoulli's principle, because for the Repulsine to work in principle, it was operating within a media. So there is no such thing as a perfectly closed system, at least if we're dealing in the universe, right? And that's actually one of the formalizations in Mach, is that, well, if you assume the entire universe is closed, then the subsystems within it are basically like open when you're dealing with things and exchanging with mass. And so Bernoulli's principle is important because it's just talking about what happens when we change the surface area of something that's flowing inside of it. And there are different ways to demonstrate it. All of these like loop together to try and make a working argument of how the Repulsine might have worked if it did. Okay, and then we talk about the actual Repulsine, and I just throw in a few slides of what I did. And then finally, we get into my own work. So enough yammering. Let's just go right into the slides, shall we? So who is Viktor Schauberger? Didn't preface this, but I am both millennial and Zoomer. And so whenever you find my slides, you're always going to find a bit of meme culture in it. I can throw that in wherever I can. I like to do that. And so Viktor Schauberger, as told by Wikipedia, apparently in 2026 was a pseudoscientist, also a naturalist and a philosopher, trying to make him sound a bit like, someone who's just, on the fringe. And being on the fringe isn't necessarily a bad thing, but I think this is a poor representation of our Schauberger right here. And so let's carry on. So if you ask DeepSeek or ChatGPT, as it turns out, DeepSeek will do maybe a better job. It'll say that, there are some conspiracy theories associated with his work. And those usually come out of things related to Nazi crafts and secret things that have happened that nobody knows about. And then ChatGPT did a more honorable job of presenting him, maybe, I don't know, because it called him a fringe inventor. And so I don't know if any of these things are accurate, but let's first tackle this question. Well, what is pseudoscience? I think that's a really important question to tackle. So as told by Wikipedia, let's also try to get into the minds of the people who are using this word. Pseudoscience consists of statements, beliefs, or practices which claim to be scientific or factual, but are inherently incompatible with the scientific method. Makes you wonder, so what constitutes a scientific here? And we can also go into what constitutes as the scientific method. The scientific method is actually quite broad, and there are different kind of variations to it, but in the fundamental way it's practiced is generally the same. So let's look at what Cambridge says. This is just a more generalized definition. And, to get a better definition of pseudoscience, it's probably more helpful to go into the philosophers of science who actually talk about these things. It's a very small niche field within science, but there are a lot of really good philosophers within science which talk about these things. So what is the science of doing science? And what are we doing right? What are we doing wrong? But anyway, so Cambridge Dictionary, I didn't do that because I don't have time for this slide. But anyway, Cambridge Dictionary 2020-60 says, a thought or theory which is not formed in a scientific way. So we're going to have to uncover what that is. So I made a working definition for this, and it wasn't out of a vacuum. It's based off of those two definitions and then kind of qualifying a bit because I was actually in institutions of science. And, I sat down and did work on paper, and I also got to be in labs a bit. So it says pseudoscience, I would say, is any type of research which rejects or sidesteps the scientific method. And so it's the practice of treating subjective principles, beliefs, or dogmas as equivalent to scientific conclusions. And so the best way I can describe that is, so the sky is blue because it's the color of divine truth. In science, when we talk about truth, I always love to default to Richard Feynman. So the test of all scientific truth is by experiment. When scientists are talking about truth, what we are generally talking about is what we have seen objectively, like testing something in lab again and again and again, everyone individually, and kind of reaching a consensus, usually more or less, on something which has happened again. It's not something is going to be true because we have a really strong reaction to it, or it's like a subjective thing. It's an objective thing that happens. But what we consider to be objective, especially if we're trying to use certain working models, is subject to change. And I'm going to talk a bit about that, right? So what are some concrete examples of pseudoscience? I have to be very careful with this. And so I don't mean to offend anybody, but I was just thinking about in the modern day, I think most people would, and it's, again, disagreements are welcome because I think we need more of that in science. But I think the most concrete examples of pseudoscience I could think of is the flat Earth, just because, recently there was the mission again with Artemis and some of the other stuff. So we saw all of those nice balls floating out. So, and then another one would be geocentrism, which is the idea that the Earth is the center of everything in the universe, right? And the sun orbits around the Earth, right? So something like that. I guess by definition, that would be pseudoscience, right? So that's something which, when we all take our instruments and our tools and we look at it, we would probably disagree, because based on what we're seeing or what we're observing, the measurements are telling us these statements don't hold, right? Okay, so pseudoscience, let's talk about the Raven paradox. So science is not true just because 99 out of 100 specialists say it's true. This is a very common mentality that I've grown up with as a millennial and a Zoomer on the internet, seeing people say this works because science, and science is kind of put forward like a god or religion. And science is a democratic process, but it's also not democratic in some regards. So just because 100 people are saying something is true doesn't mean it's true. Science is reliable because claims can be tested, they can be challenged, and they can be revised. So that means that even if 99 people, believe that, I don't know, there's no such thing as an albino pigeon or raven, not pigeon, right? As long as one person finds evidence, hard evidence that there is an albino pigeon, then that is an objective truth that's been observed. And so it's going to have to cause some revision with the way we do things. And that's the cool power with science, is anyone can go out there and test things if they're following the method faithfully, and bring, good data is what we use to change and rework things. So the claim that all ravens are black can be overturned by only one verified raven, in the same way that scientific consensus is powerful, but it's not absolute proof. So then, as I said before, I kind of alluded to this. Here's Richard Feynman. The test of all knowledge is experiment, and experiment is the sole judge of scientific truth. So I love using this as an operational definition for truth in science without getting to nitty-gritty of philosophy, because I do love to moonlight as a philosopher as well, but that's something entirely different. When it comes to science, I am by nature an experimentalist and a theoretician only where necessity may call. So let's take a look here. I also got my notes here separately on an iPad, so I'm looking. So I want to bring in a caution here. So it's very important. So scientific heresy does not equal pseudoscience. So by definition, heresy is a teaching or dogma that differs from what has already been formally put forth by an authoritative body. That's a very concrete, like general definition of heresy that is like interdisciplinary. So scientific heresy is a teaching or approach to a subject which differs from what has widely been taught or expressed by a consensus of professionals or experts. So as illustrated in the Raven paradox, even scientific heresy can be overturned and canonized into scientific dogma. So this is why whenever we're doing science, we have to be very careful, and we have to give a lot of patience to people, even the weird stuff that we don't understand, or the weird stuff that we think we understand thoroughly, because that can always be overturned by, you know, someone bringing in a caged pigeon that we've never seen. Here's some like actual historical examples where this has happened, right? So we got spooky action at a distance with Louis de, I'm going to screw up his name, I'm not French, de Broglie. So we got spooky action at a distance. We got matter waves, very important and fundamental. We got Eric Lathwaite, who is an incredible professor. He actually was challenging Isaac Newton for a time, and then he repented and said, yeah, Newton was right. But that kind of wrestling is so important in science. And he was a real scientific man and a man of experiment. And then I can't say this name correctly, but this fellow, he convinced us that washing our hands could save life. And you'd think like, that's, well, common sense. Who wouldn't wash their hands? Well, back in the day, that wasn't really a thing. And so, again, scientific heresy, not necessarily pseudoscience, but yes. So now let's talk about, well, what is real science, okay? So real science is not what a personality says. And sometimes it's not even what leading theorists might tell you. So like I've been saying before, the scientific method is accessible to everyone. It's democratic in practice, but it's objective in outcome. That's very important. It is limited only by the creativity of the human mind. The scientific method is not an oligarchy of qualified specialists. It's not limited by assumptions or prevalent theoretical works. And it's also not necessarily constrained by special faculties, right? So just because somebody has access to $1 billion facility or, you know, something else, like all these special tools does not mean that other people are like prevented from doing any kind of good work. In fact, you'll find many times in science, the human mind is so powerful that it's able to overcome the barriers of having all of the nice whistles. I can't remember the name, but this is for anyone to go and study. In the field of like neuroscience, we have colorized images of like incredible images of neurons, like before we had any kind of MRI scanning. And we all know that MRIs, for them to work, we had to have quantum mechanics worked out. And that wasn't worked out at all when we got some of these images. And whenever I look at some of these images, it's just like a testament to me that if we really want to learn something, we will find a method of doing it. And there's kind of an art to it. It's very difficult and it seems impossible, but people are able to get through that hurdle with even their primitive tools. And, you know, they're able to graduate into something that is quite workable, right? And so I can't remember the fellow's name. Anyone can go and look at it. But anyway, he figured out a way to like actually get a picture of the neurons, and it just color is absolutely gorgeous and absolutely great for scientific observation. And that's just one example. There are many more examples of this where we're able to prove like really huge and important principles by using very basic things around us. So going on, we got the scientific method. Well, what is it? So this is a non-exhaustive outline of the scientific method. So it's just for the intellectually curious. So basically, what is the problem, or I like to say impossibility? Because most things are generally impossible when our knowledge is limited, right? And so that's where science taps in. Is it truly impossible, or are we thinking about this wrong? So we have a good question. And then from that question, we graduate into a hypothesis or an educated guess. So it's very important that this is falsifiable. So falsifiable means that you're able to prove that it is wrong. If it's not, then it doesn't work well with science. It sounds like more of a matter for philosophy or something else, right? And I'm not trying to necessarily put a barrier between them, because I think that the two, sometimes they meet and then they go away and they do other things. But just in terms of like pure science as an experiment, it is important that you can disprove this, right? So then you create an experiment, and it's advisable that the experiment which you're creating is repeatable so other people can do it, right? That's very important. You also want to be very wary of confirmation bias and the sunken child fallacy. So as someone who's, done work in and out of the lab, independent research, the sunken child fallacy it can work against you, right? You pour so much time and effort into something, hoping it'll work, and then all of a sudden it's like, man, my experiment didn't go the way I expected. Why is that? Okay, so then you get data analysis, and then you try to use the tools of mathematics or rational or applicable rationale to try and understand what is going on, see if there's a pattern. There isn't a pattern, then just write down your findings. And then finally, as I like to say, you have show and tell, or you replicate, you report, and then people replicate what you did independently to see if there's any credence to what you did. People might criticize the process. Maybe there's nothing wrong with the process itself, and people just need to see, well, what were you doing here, and follow with it. So again, restating this another way, it's important to outline that there are several attributes in the scientific method. The first and the most important is probably that the process is accessible to anyone. I've already said this. The second attribute is that the scientific method is a democratic process. I think I'm just repeating myself here, so I'm not even going to bother with that commentary. So let's just move on to the next slide. So thou shalt not remove from the scientific method, and yet, what do we have here? St. Nikolai Tesla. This guy was a legend, right? Oftentimes, he's just looked as an engineer, and I'm also going to put him on a pedestal here because technically he did not finish his university degree, but this guy was brilliant. I mean, if I had his mind, I would do so many things. He could do calculus in his head, like without any problems whatsoever. And he understood, he was like just such a brilliant scientist, right? Such an incredible scientist. But anyway, here's a famous quote by him: "The greatest woe of modern science is that today's scientists have substituted mathematics for experiments, and they've wandered off through equation after equation and eventually building a structure which has no relation to reality." So he is a visionary. And I think this is really important, especially when we're going to dive into Schauberger's work, because the distinction here is that a lot of things related to Schauberger they're dealt with like hands-on work, actually doing experiment and looking at physical principles, right? They're very important. Not everything can be done with pen and paper alone. Pen and paper with the tools of mathematics is meant to enlighten us and help us formalize those things so we can, take that information and share it with other people. Okay, so moving on, next slide. So what is real science in Schauberger's camp? Well, I mean, I took some of these from the like fundamental Schaubergers. If there's a fundamental literary collection of Schauberger, you find these. And then from other external independent research that's been done. I mean, Schauberger's work is broad everywhere. We're talking about in terms of environment. We're talking in terms of like environmental science, even in terms of like medicine and processing other things. And there are a lot of businesses which are using the precepts of Schauberger to, have their processes made more efficient. So here's a lot of just pure data, like observational data. I didn't make up these numbers and I didn't make up these processes. And there are a lot of people who are doing this in an objective scientific way. So whenever somebody tries to say, well, it's unscientific and it's pseudoscience because, I don't know, somebody said it and he had like a PhD, I just kind of go like, that's kind of problematic. You need to use the brain, use the, not the brain, the mind, the human mind to think about that a bit more critically. So, okay, so what is real science again? I put this here just to show that there are variations within the scientific method. So many variations, right? But fundamentally, you're still doing the same thing and you're still going to get the same fundamental outcome. So as I like to say, the scientific method is democratic. It's democratic in process and then objective in outcome in what you get, right? And so bottom line, because I'm a cat lover, especially a black cat lover, there are many ways to skin a chicken because most people love cats. So many ways to do the scientific method, although the scientific method remains concretely the same. So let's move on. So this is just a final note. So scientific ignorance often breeds pseudoscience, right? So much of the work to be covered in the presentation has remained stagnant because of this trend of ignorance. So ignorance can happen in two ways. The first is obvious. People can promote claims without evidence, but the second is more subtle. When experts dismiss a claim purely by appeal to their own status without examining it carefully, they can also damage the scientific process. Science is not protected by rhetoric, it's protected by a method. And if a claim is wrong, then it should be shown to be wrong through evidence, analysis, and clear reasoning. But if the response is only ridicule or credential-based dismissal, then the public is left with rhetoric on both sides. So this is how confusion grows. So we should always reserve judgments after we've completed the scientific process. So it's very, very important. Otherwise, it spreads like wildfire fire like a virus. So let's move on. So who was Viktor Schauberger truly? We can finally get into the meat. So Viktor Schauberger, he was born in 1885. I can't say where correctly because my German is bad since high school. Holzschlag in Mühlswerterg. I can't do this correctly. So in Upper Austria. His early life and professional formation, they were not only academic, but they were also observational. He worked as a forest warden, a senior forest warden, gamekeeper, and eventually became the head warden of the forest. Central theme in his work is the contrast between explosion and implosion. And he believed that modern technology relied too heavily on explosive expanse and heat-producing processes. So he really focused on this idea of implosion, which was supposed to work with nature. So he better framed these systems as as flowing internally through like natural vortices, and then other things related to them, the attributes I'm going to get into later. So his family motto was reportedly faithful to the silent forest. He was truly an environmentalist at his core. And the only reason that you see that straight point that I've included in this slide regarding his work in World War II so decisively is because somehow, despite all of the primary sources which talk about this, and it's well documented and known, it's still considered a conspiracy that he was like literally slurped by the Nazis and forced to do work for them during World War II. Like, that's not a conspiracy. That's well documented. It happened. The Nazis really wanted to use Schauberger's work. And actually, when the Americans came and discovered him, they like kind of, I guess the word is quarantined him a bit. Not actually quarantined him, but said, okay, this guy's working on some advanced stuff. We don't quite understand it, but it seems to be maybe atomic in nature. So he might be a little bit dangerous. Let's take a look at that. So expanding who's Schauberger for real, he continues in this experimentalist lineage. So we got Nikola Tesla, right, who mastered electromagnetism and was largely dismissed by mainstream science, right? So none of these individuals, by the way, I just want to let you know, had a university degree. Tesla failed to finish college. Faraday proved himself by taking exceptional lecture notes. And Ben Franklin was almost completely self-taught. So the works of these individuals, they surpassed many of their contemporaries who had high pedigrees. But so few remember Proteus-Steinmetz. And yet Tesla was the one who developed the most exceptional form of the alternating motor. And then Michael Faraday had no formal training in math, yet his experiments fell perfectly in line with the work of Maxwell. And Einstein was known to have a portrait of him in his office. And then Benjamin Franklin proved that lightning was actually electric in nature. And for better or for worse, he's the reason we have conventional current in the opposite direction. So this is the lineage that Schauberger also continues on in. So many famous, brilliant minds who have done a lot of experiment and made a lot of contributions to science. Nobody can dismiss Faraday, and nobody nowadays will dismiss Tesla. Tesla, getting him to be like also like known in the mainstream as just a brilliant mind has been hard, a huge hype. So anyway, these are AI enhanced images of Schauberger. They're cleaned up, but they're still, I think they're probably the best representations I can get of his sketches without being in the actual Schauberger estate. So he worked on all manner of things, right? So the first image is a trout turbine sketch, and I think it's really more of like concept art more than anything else. And then the next one is a bio impeller, right? So just his conceptual ideas. In Schauberger, he's a great artist. If I could draw, I think that would make me a better designer as well. That's something I kind of struggle to do. But a lot of his stuff that you see is not like, say, Tesla drawing. Tesla, when he draws things, he'll draw them to scale and he'll have specific dimensions and stuff. Since Schauberger understood principles well, and he was also good at drawing, I think in a lot of his drawings, he would have the conceptual part down, and then it would be the work of maybe like a more technical oriented person to draw these things. I did find an old schematic of a home generator, which is signed by him, and I wonder if he actually like sat down and did the measurements. That is a pretty technical design. I think it was an earlier design that he wanted of the home generator that wasn't realized. But anyway, so we have the submarine. Then we have a bio impeller, which is often like pegged on to the Repulsine in a lot of replications. A lot of people like to just peg on this bio impeller, thinking that it solves the problem of why it won't lift, is that it needs to have some sort of suction thing. But I also have my own kind of ideas as to how the thing might have taken off. We don't have a key component that's related to it. Then we have an embryonic implosion chamber, as I call it. It's really probably for mixing. I'll talk about this in a later slide. So let's move on. Okay, so next slide we got, so Schauberger again for real. these are basically the fundamental works with Schauberger. If you want to like find and consume all that you can with Schauberger, you can take a look at any one of these books here. He's just incredibly voluminous, but he's also like reading Carl Jung for anyone who's done that. He has his own kind of language, and it's very, very important that you don't like look, especially if you're a scientist, you don't get taken back by Schauberger's language and say, this guy's practicing pseudoscience because he's saying gravitation is like, unopposed with this other thing, and, you're misunderstanding the guy, right? Like for a lot of people who are practicing science purely experimentally and have not had any opportunity to, go through institutional channels, I should say be domesticated within most institutional channels today. They use the languages that are most like natural to them to communicate the processes which are happening. The processes are true. The language might be a little bit flowery, but the processes are true. And so his language is extremely descriptive and pictorial, and it often lacks technical scientific parlance, and it's prone to being treated as pseudoscience because the way the translator may qualify his words. So principally in the English language, most of the books that have been translated, I think if not all, have been done so by Callum Coates. And Olaf Anderson is also an engineer who did a lot of great work with Schauberger stuff. So let's see what else I got on my notes here. So in some respects, he reads like Tesla, who lacked formal institutional scientific training, but he retained the essence of fundamental principles. If someone yoinked to any one of these books and read through some of the commentary left behind by Coates, they might be more inclined to believe that Schauberger's work was a bit of the esoteric scientific variety. And I think that's just because sometimes when the translators provide this information, they want to give some historical context and some other background. So quote will sometimes quote people who by association will turn off maybe a few like technical guys. Like, so there are sections where like, so if you look at like Helena Blavatsky, who's talked about this and this and that and the esotericism and all this stuff, we're like, I don't know what this has to do with science. But what he's just trying to do is, I guess, help the reader understand, get a more generalized worldview of what's going on. Not a lot of that isn't really fundamentally important in terms of understanding the operative science within Schauberger. Historically, it's important, I guess, and then also, I guess, in terms of the context, when you're trying to like get your mind into, okay, well, how are people seeing this? Like, it's like looking at ancient people and trying to understand why were they building things. They might say that, well, this was because of the principle of a tadpole, which liked to move up the water in some sort of way. And so they draw with a lot of pictorial things, but there's a scientific principle behind that. That's the secret sauce that researchers are interested in. So moving on, there are so many parallels with Schauberger's work when you look at more like refined experimentalists like Tesla. Like what I'm showing you right here is from Schauberger himself, independent. I don't know that Schauberger had any kind of communication with Tesla. In some ways, he predates Tesla, right? This right here is like one-to-one with a Tesla valve, and he did this purely from looking at nature. So these are his meandering valves. And so I have a Tesla valve right here in the lower left-hand corner. And that's exactly what a Tesla valve is. Tesla is also brilliant because it just goes to show you the power of the principle that he's understood, right? And this is the meandering valve. I'm guessing it's the meandering valve at the PKS Society. It looked like that when I saw it. So I just scraped these as some examples of like actual hardcore innovation that he did that is not pseudoscience that's used in modern day today, and also by other people. So we also got his logs here. So some important information on the logs. By 1922, Schauberger had designed and built timber flotation installations, or log flumes in Sterling. So these were based on his observations of nature, and they reduced logging costs to a tenth their previous level. So the success of this led to many other things. And by 1930, there was a film. You can find it. It exists somewhere on the internet there, which is a documentary based on this. So from Schauberger's work here, Schauberger's work in general expanded into forestry, water technology, and many other things. And by 1931, he started the experiments involving the extraction of electrical energy from water, connected to water capillary action research and Lord Kelvin's falling water experiments. By 1932, his work included the production of pure water and even fuel production from water. 1933, he published his first and only book, Our Senses Toil, where he criticized modern technical practices, working against nature rather than with it. Definitely an environmentalist at his core. Okay, so moving on, here are some pictures of his home generator. So I mentioned earlier that there was a technical design, and this is signed by Viktor Schauberger. is what it says there. I'm not sure if he actually like prepared this image, but at the very least, it looks like he knew what he was doing. So the home generator is supposed to be able to create, well, I'm not going to go into that in this slide, but and I don't want to oversimplify how it's going to work, and also don't want to misrepresent how it's supposed to work. But it's supposed to also reach a kind of like equilibrium within implosion. There's something I call kind of like a static equilibrium, and it's basically supposed to keep creating a vacuum where it's rotating at a nice even pace, and then that can be like adjusted. So that was his hope with the home generator. And I think, if I remember correctly, I'm not sure, I think that this home generator, which was built, wasn't actually the idealized home generator he wanted. I don't know that it actually worked. And I think when they tested it, they were careful because, you know, the thing is old, so it's just better as a historical item. Let's see what other notes I got. There are many vortex layers to this device, and implosive principles we'll cover later in the lecture. So when they're built in an ideal way, the several after effects related to temperature, pressure, and fluid flow become quite manifest. These are the things I don't want to talk about because they're actually nuanced to them. And, you know, there's a whole science to them depending on what avenue you want to take. So for any student of science, temperature and pressure are not naturally unrelated. So it makes sense that, you know, he would talk about these things and take them into effect. He's always talking about temperature falling and like decreasing. I remember in high school, I was always bored by this. It's like, why is he talking about temperature? I don't care about that. Difference in pressure, like air pressures, like differentials, I get that. But like temperature things, why is that important? You study physics and you realize, you know, these drops in like pressure can also cause, you know, an effect on temperature and vice versa. Thermo is interesting, also a very annoying course that I didn't like. But anyway, that's beside the point. It's also very important for my field of research because force is a process. But anyway, so Schauberger for real, some innovations. Here is the innovations we see in like pharmaceutical industries and treatments and stuff. So it should be noted that Walter Schauberger, not Viktor Schauberger, accomplished a great deal of developing several types of spiral treatment systems involving both gas and fluids. And here are some of them. The first image shows Marcus Kiesder, head of production at Walla, Helmiter, using the apparatus designed to mix plant juices, mistletoe, winter mistletoe, and summer mistletoe. And so the purpose of this process is to separate the mineral components from freshly harvested mistletoe through a specialized form of motion and mixing. So the device actually emerged from discussions related to Rudolf Steiner's ideas and with Schauberger. So Steiner had envisioned a separate preparation method for mixing these materials. So actually, excuse me, correction, it was Karl Kohler, who was familiar with Steiner's thought, who later met Viktor Schauberger. And then following this encounter, the egg-shaped mixing device was developed, and it produced a distinct kind of vortex-based mixing process. So in 1976, the first version of this device was transferred to Walla, and that is shown in the image to the left. It's a photographic teaser. And the next example is a water appliance, which is designed to revitalize distilled water based on Schauberger's designs in 1938. So if one looks just above his hand, they can see a civil prototype of a Schauberger's transport wave diaphragm. So I'm speaking now of this image here. So this was taken, this is Klaus Rauber, and it was in well-known, like the most well-known Schauberger documentary that, or maybe not, it might've been 2004. I can't remember which one. But anyway, you'll see the diaphragm plates, which will be kind of like this recurring theme, especially with the Repulsine and his like turbine here. So basically the way this is supposed to work is the water is pulsed through the diaphragm, and then it continues along a screw-like meandering path, vertical path. In Rauber's words, the hole is covered by a lid so that light is excluded. This is another thing with Schauberger. He thought that water became more energetic within darkness. And so Schauberger believed that the more energetic in darkness, especially in the presence of moonlight rather than direct exposure to light. So that was those were some of his environmental practices being put into use the best they could for producing some of these systems. Moving on. Now we're going into the his actual direct lineage. So Walter Schauberger. Walter Schauberger is also an incredible person. I didn't know this until I did a bit of digging. He studied mechanical and electrical engineering, so he was a bit more technical oriented, and believe me, it does show. So rather than simply preserving his father's ideas and historical curiosities, he tried to systematize them through principles and through like physics, biology, and all sorts of other scientific principles. In 1949, he helped found the Green Front, considered Austria's first environmental organization. Make the earth fertile again was their kind of mantra. And then in the 1970s, his work expanded into the PKS school, the Pythagoras-Kepler school, where he invented harmonic theory, non-Euclidean geometry, and prime numbers, nuclear physics, what he called the tonal nature of physics. It might sound a bit esoteric to people because, again, it's just kind of a misrepresentation, but a lot of times when people go into subjects that haven't really been covered in mainstream circles, the moment they start talking about like fundamental properties, then it sounds like you're saying, well, 7 is the, best nature, is the best number to use to tune everything in nature because it's the number of divine cosmic truth. And that's not so. We all know Pythagoras and his work with mathematics. Everyone loves him, right? Because of all of the triangles and squares we've had to work with in primary school for all those painful standardized tests. So no one doubts his work, but a lot of people don't actually understand the more fundamental nature of things like Euclid and so on and so forth. And that is like the ground level, like the base, like assembly language level, where a lot of Schauberger's work came from. And Walter worked to formalize a lot of like that to like say, okay, so when we're talking about implosion and things which are happening in a process, a good way to illustrate this is by using some of these tools which already exist here in terms of mathematics. So he was a smart guy. And here are just some pictures from the PKS Society. I'm not going to go into any of them. They're actually really, really useful when you're designing any kind of Schauberger system. So you can basically create anything that Viktor Schauberger, if you ever want to make anything from Viktor Schauberger, you can start off by making this is like just the secret sauce in terms of the industry making stuff. So just start off with like a hyperbolic cone and then slice that. There's so many different ways to slice that. And you can create any kind of geometry you want. And it'll be very easy to create a geometrically advantageous object. How you do that in terms of the 3D becomes a bit of a method. But this can help you. And so moving on to the next slide, this is another, it's like looking at the hyperbolic cone from far away. And so these are just things that he developed. He didn't really develop them. They've all been there, but they're just useful in terms of, I guess, the science of Viktor Schauberger. And then everyone knows this lovely face. This is Jörg Schauberger, which is the grandson of Viktor, son of Walter. And he carries on the legacy of both his father and his grandfather, spokesperson and lecturer and collaborator of Schauberger material, and the current presenter and overseer of the PKS estate. So he's overseen many of the independent studies of the work of both his father and his grandfather. Okay, so we've done it. We've gone through Viktor Schauberger the best we can, and we've done so fairly fast. So now we're going to go into the more technical details. So this is the general part. So we're into part 2. So what is implosion? That's a very good question here. So let's look at implosion. What is implosion as a science? So implosion, the process, let's talk about it. So you can think of it usually as the inverse of explosion. So if explosion goes out, then I guess the inverse is it goes in. So explosion is a process whereby mass, energy, is released outwardly, usually in the form of heat, and that causes an expansion of a given volume or space. So implosion differs a little bit. So implosion is a process where mass, energy of a given volume or space is concentrated inwardly by a kind of compression. It can be a compression. And it's actually also directed as well. It can be directed. So instead of spitting stuff out to get kind of like, energetic, I'd say useful, energetic motiveness, you contain things and you just kind of like you have that directed in a way within a contained sort of way. Okay, so moving on to the next place. These are really cool slides. So this is really important. So the explosive process is basically summarized really well here in this very simple diagram here. This is what you learn. I remember in like mechanics, fundamental physics course where we had to use the Rocket equation for this. But basically, as I was saying, in my crude millennial language, you just take, so when you take mass and you spit out mass to get something to move in another way because of Newton's third law. So the implosive process honors Newton in every single respect. There is no such thing as a reactionless system, so far as I understand. Everything must be reactionary if it's having some sort of motion. This image I took actually comes out of a NASA document. Anyone who's done the field of like researching any type of alternative propulsion critically and rigorously, it's like a huge 1,000-page document, or maybe 500 pages, I can't remember, by AIAA in Advances of Propulsion. And when it introduces Mach's principle and Woodward's work, it had an illustrative, which is actually just a powerful illustrative overall. And this is why I will go on to talk about why Mach's principle, at least the formalism I'm using, is a very powerful tool in describing implosive processes. And as you can see here, I mean, this isn't, if you actually built this mechanism, this is not necessarily how it would work unless you had some sort of like pressure differential. But the idea is that, you know, as m is changing, like mass is changing, right? So the delta m is changing. So as there's a slower contraction and then a full expansion, it's moving forward, right? It's kind of breathing. And actually, I defer to a lecture before this about a month ago, which was given by Michelle Boyce. Forgive me if I mispronounced her name. And she does an excellent job in talking about how Woodward's Mach effect thrusters like work, because a lot of the principle, fundamentally, we work with the same kind of principles, right? In terms of the breathing and the pushing. And the push is basically the pull, and the pull is basically the push sort of deal is what's going on. And so this is the implosive process illustrated mechanically, and the explosive process chemically, which is also, I mean, if you want the mechanical process, just open the hood of your car engine. Okay, so moving on, what are some good analogs for those who don't understand with my word fruit salad? So a useful analog would probably be fission versus fusion. Fission generates energy by splitting mass energy. It's probably even more powerful than an analog. It's still the same kind of thing in explosive process, no? So it generates energy by splitting mass energy, right? The contents within an atomic nucleus. And then fusion generates energy by combining the mass energy of atomic nuclei, right? And so, I mean, this is probably a very good way of explaining how implosive works. So then what is an implosive system? That's a really good question. Okay, so these are enhanced images I had. Actually, I believe this doesn't come from a Roger Penrose thing. Penrose has some interesting work as well with rotation matrices. I'm not even going to go into that, like with spinor theory and some other stuff, but the illustrative is a very powerful illustrative that can be used anywhere. So I had it color coded, right? This is a very, very powerful illustrative for many different reasons. But anyway, an implosive system, this is a very good illustrative for illustrating an implosive system. An implosive system is a system which is driven by an implosive process. So that is a process where mass energy or inertially, or the inertial content is cyclically retained and redirected. So it differs from an explosive process where mass energy or inertial content is either expelled or discarded throughout an impulse. So the flows or the transfers of mass energy within an implosive process tend to be vortical or vortoral. The words that we're using here, they're not really neologisms, but like, you know, a lot of people haven't been doing work in vortex stuff in mainstream. So it's kind of hard to give this an adjective word. So a vortical or vortoral, both should work, right? Usually it's vortical or vortoral, and then you'll have a particular vector of movement. You don't always have a vector of movement. You can have like a counter-rotating vector system. And I might talk about this a bit with the repulsing, but basically you end up having like two counter-rotating vortex within like a gas or media. And then within that, you have an embedded bigger vortex. And that general vortex often just looks like a giant donut. But a lot of times people don't see the counter vortexing that goes on. But it's just a different thing to talk about. It can get a little bit complicated. So anyway, what is an implosive propulsive system? A reactionary implosive driven device which does not expel mass in the same sense as an explosive process to generate thrust. An opened or Mach emitting system whose process of force generation is implicated with the rest of its surroundings. I say open or Mach emitting system because when we're talking about these systems, there are different ways to qualify them. And over the years, I've seen a lot of people go to great lengths to make very, very nice frameworks that are distinct. Sometimes they say like Newton is lacking completely, or this doesn't work. But Mach is very easy to use. Well, it's not because of convenience, but in terms of doing the science, right? There is nothing necessarily fundamentally wrong with the science, but there has been a misunderstanding in how the science has been applied. And so everything that Ernst Mach had already been articulating in things like mechanics and on fits snugly with things like this. It's just that in a world where explosion is kind of like the way that everyone understands energetic processes and motion, it's very hard to talk about implosive systems. They almost sound like fantasy or something made up, right? And so Mach helps to offset that and also helps to formalize that in a scientific process that can be like replicated. So what is an implosive system? What are the types? So my area of specialty, I always say, is in solid state inertial mechanics or solid state implosive systems. And to the left, we have one which is mechanical. And so as the name implies, solid state. That means I deal with actual concrete masses. And what we do is we arrange those in space according to an advantageous geometry, use a 2 pi Mobius band. And that's just because it has some really nice attributes. It's non-orientable. And that non-orientability, it almost sounds like I'm talking about general relativity here, because anyone who but uses GR knows that there are advantageous geometries which allow you to do special things in space-time when, say, you want to traverse a wormhole or make a really fast kind of like, system that displaces space-time. And the principle, even though general relativity is not at all necessitated with the formalism of Mach I use, the principle is absolutely the same, is that, and I mean, it goes back to even Walter, who's using PKS stuff, right? Is that there are geometrically some advantageous geometries that let the implosive process work with great ease. You're able to achieve a kind of static equilibrium, and I qualified that in a different paper I released last month with 2 pi Mobius band, but there are other kind of geometries that you can use as well. So we have a fluid-based or hydrodynamic-based system here, hydraulic, and that is the Repulsine. I'm going to have to speed through this a bit more. Okay, so we have perfectly ideal implosive systems here. So what happens in a perfectly ideal implosive system? Okay, so if you have a system like the Schauberger system, you have the gaseous reactant. So that means it's working within air. So I call it a pneumatic system. Then you have the hydraulic system, which is like what you see in kind of like the submarines. Okay, so for the hydraulic systems here, this is really important because eyewitness accounts of the Repulsine, if it took off, and this is Viktor Schauberger's own word, the apparatus, it first functioned at the first attempt, it rose upwards, trailing a blue-green and then silver-colored glow. That implies to me some sort of ionization with like stepping up the energy levels. So in an ideal implosive system that is a pneumatic type, working with air as the media, gaseous reactant, perhaps there's a sort of concentrated coronal discharge, right? So triboluminescence takes place when a material is mechanically stressed by rubbing against something else. In this case, the something else is the air. For something like the Repulsine, that thing which was rubbed against is probably the air. Like I said, for this condition to take place, one must consider the type of material which is being used, the construction of the turbine. And again, it's possible that this is a standalone effect or it's concurrent with ionization. I'm not sure because I haven't been able to replicate this effect myself. So for those who don't know, ionization is when the orbitals of an atom lose or receive an additional electron. We physicists like to say it's something like positively or negatively ionized. So coronal discharge occurs when the electric field around a conductor becomes strong enough to ionize the surrounding gas, but not strong enough to form the full spark between the two conductors. So the Repulsine most likely behaved as an advanced pressure transformer or Van de Graaff generator in its most ideal conditions, having a concentrated charge of ionization within the right below the cowl, when the conditions were just right. If the historical accounts of the prototype are as described, then it probably looked a lot like this. So here are some coronal discharge examples. Obviously, we have the Tesla coil. So when you have systems that work really well, physical systems, then the physical environment around them also become integrated into the circuit. And that's exactly what happens with the Tesla circuit. I mean, Tesla coil as well, is that air itself is also a great capacitor. And so the air around it becomes becomes ionized as well. This is a very specific kind of Van de Graaff generator, and I forgot why it was made. It was like the research. It was done in a very particular place, so Round Hill, Van de Graaff. Someone can look into that. This is really important in terms of Viktor Schauberger's work. So, like a Mirabeau, so more immediate demonstration of what the region beneath the cowling system of Schauberger, what it looked like with a highly energized when it was highly energized. We can get an idea from borrowing from the work of Dr. Mirabeau and his laser beam powered light crafts in White Sands, New Mexico. So geometry plays a critical role. And if you look at this, it has quite the hyperbolic geometry, And so what he does in his design, it's much like a normal implosive system design. So the Lightcraft is a specially shaped object resembling an upside down spinning top. Its base has a cross section, which is similar to the hyperbolic parabola. And so the region is energized by an intense laser beam heating up the craft somewhere between 20 and 30K Kelvin. So saliently, his Lightcraft is also able to incorporate a shroud or cowl, which you can see, which helps concentrate the directed laser beam energy to a focal region. And once the energy reaches a critical intensity, the air beneath the craft breaks down into a plasma and expands violently. It creates shock waves, propelling the model upward. So maybe that's what we were seeing with Schauberger. And just to give to help the imagination to see what that looks like, this is what it looks like when Mirabeau is doing some work with his light crafts. And I'm certain that if the eyewitness accounts regarding the Repulsine were as stated as before, then this is probably what they saw, right? In an ideal condition. Now, this is incredible because here Mirbeau is energizing the thing to reach a really high critical temperature, and then it does this. But the Repulsine seemed to had really nice principles that were just working, like where it somehow achieved this. This is an incredible after effect. I don't know how you would achieve that. The way I've designed my Repulsines, they have a little Easter egg where you can kind of induce this effect. Well, I shouldn't say induce this effect, but induce some appreciable effects similar to this. Okay, so moving on. Another ideal thing, we're just going to touch on this real quickly because it's adjacent to the Repulsine, is cavitation. So in an implosive system. So cavitation takes place when a local pressure in water falls below the liquid vapor, causing bubbles or vapor cavities to form. This can occur within the wakes of low pressure regions around rapidly moving objects. So this is the process here. Got to go through this. I actually had the opportunity to speak with some of these Schauberger veterans who've been doing Schauberger research like since the 80s, right? And I sent them some of my PowerPoints, and I didn't even know. I got on an email with this guy, Kurt Halberg, who owns this company, Walter Recco. And so anyway, I grabbed this because I think this might be an example of cavitation within one of the Schauberger systems with the hyperbolic geometry here. And I'm just going to speed through this again. These are Trout engines. So in their ideal case, the analog of the triboluminescence which goes on should be cavitation. And these are just some of the diagrams again. So Trout engine, same. You'll find things like the diaphragm and some other stuff. Okay, so moving on. A working science. So working science, we have the PKS school. So basically, the tradition just deals with tone. It deals with ratio and proportion. Okay, what do we got here? The PKS system. This is nothing new. I'm really not going to go into the nitty-gritty of how this works. But again, it's just fundamental Pythagoras here. So these are just some slides. I enhanced them that you'll find within the PKS Society. We can talk a bit about Mach's principle. So because I have done quite a lot, at least in my own formalization of that. So Mach's principle implosive forces, if the universe is a closed box, then the constituent parts are just basically subsystems. Mass, energy, and inertia are transferred through corridors of interaction. So this is important for describing Schauberger type systems, since these systems are fundamentally implosive. So the thesis of Mach's principle is predicated on the idea that matter in this place does not go uninfluenced by matter elsewhere. So from a theoretical approach, there are several ways to approach this into a working theory. But most are usually only familiar with Woodward's approach, which does a great job of formalizing Mach within the bounds of GR. So the systems I work in don't necessitate GR, but it's still Mach's principle fundamentally. So an implosive system does not expel mass. It reorganizes motion inwardly. It produces a force through a localized redistribution or a contained wave packet, essentially a soliton. This is a soliton here. I didn't even know what a soliton was when I made these designs way back in 2018. So I use something where force is a process of inertial confrontation. So force treated as a process is something which isn't actually really done standard in physics. And there are different ways to do that. So Mach's principle and implosive forces, this is just something I took from another slide of mine as well. And so we got here, basically confrontation is basically when you apply some sort of action to one mass part, but then that does not influence the other part here. So you can leverage this kind of principle to create unidirectional force. So that's force in one sort of direction, or just a static equilibrium of motion. So you need to apply Newton's forces concurrently. And so now let's go into the fluid dynamics of the implosion process, right? So we're going to talk about three things here. The first thing we're going to talk about is a soliton, right? So a soliton can be classified as three things. So basically a soliton is a self-reinforcing wave packet having a constant velocity. So first, it is of constant form. Hello, hello, hello. Can anyone hear me? My AirPods died, but hopefully I'm still heard loud and clear. I don't know if I am. Okay, so first, a soliton is of permanent form and it's localized within a region. It can interact with other solitons and it can merge from the collision unchanged except with phase shift. So that means you can have two soliton things that run into one another, but their forces are still remaining the same. And the image to the left is a diagram. It just shows how solitons work. And then the images to the right are actual solitons as well, mathematical solitons, most notable the 2π. So then next we got the fluid dynamics Bernoulli's principle. So I stole this from a Schauberger slide. Basically, fluid speed increases static pressure. As fluid speed increases, static pressure decreases. Okay, so don't have time to really go into that. And then we're going to dive into Helmholtz theorems a bit. So Helmholtz theorems, in short, basically how implosive system works will be contingent upon these things. I don't have time to go into great detail about these, but anyone who's really interested in the nitty gritty, there's a great book by Safman, which has all manner of really hard, I shouldn't say hard, it is complicated math, dealing with fluid dynamics using some calculus, higher level calc. But anyway, so this is the first theorem here. So the first theorem is basically, it strikes a similarity between Maxwell's equations for a magnetic field. But here it says a tube's structural integrity will remain constant with respect to time. So the strength of a vortex line is constant along its path. And then this next one over here, basically, again, extraordinarily similar to electrodynamics. A vortex will go on into some boundary like a wall or wrap itself into a coil. So that's what we have. This is very, very similar to some of the electrodynamic principles you'll find when using Maxwell's equation. And then finally, we have here vortex theorem 3, a fluid element that is initially irrotational remains irrotational, and a fluid element which is free of vortices continues to remain free of vortices. So if it got no vortex, no spinning, then it won't be spinning. If it already is spinning, it will tend to be spinning. Okay, so let's go in. We finally made it. So the repulsine / repulsator, okay? So you'll notice that I have left out the maths and all of that stuff because we just don't have time for that. We got to get into the real sauce. And I had to give all of the background for this. So let's go into the lore, right? Because there's so much lore surrounding this. I have to bring some clarification into this. Okay, so these are taken from books, assortment of Calvin Coates and Alex Anderson's books as well. So basically, here's what happened. So in 1943, Viktor was declared fit for active duty by the SS, and under the control of Heinrich Himmler, forced him to develop a new secret weapon. And so he had to work at, I think it was Mathenhouse concentration camp to supply the work, which was supplied with a workforce of prisoners. He was strongly opposed to this. He didn't like this. And so, he was trying to resisting and finding unique ways to work around the working conditions. So this here, my highlighted poster talks about the device. So basically, let's see if my notes can condense this a bit more. So the excerpt on the left is in 1956 letter to Franz Strauss. Schauberger claimed that a working model of his repulsine had actually been flown by the, I'll read this anyway. So by American intelligence investigators after being seized. The same account also reports an important component which had been removed in Vienna by Russians. If the component really exists, and given that the visible incompleteness of the present repulsing designs, this is not unreasonable, then an obvious question is, why did Schauberger not redraw the component or provide a more previous detailed description of it? Perhaps he forgot, perhaps they were the ones who figured out how to make this component and understood enough Schauberger that they just went off and made it themselves. So one possible answer is that by this point, too much time had passed, the war was over, his circumstances had changed, and his attention had been shifted into other projects. It's also possible that the component was simply not a detachable part, but something whose function depended on tolerances, material pressures, internal conditions, and other things which were difficult to reconstruct from a material memory alone. Okay, I may have preemptively read those notes, but again, these are just like primary things related to lore. So yeah, moving on. So lore part 2 we got here. So this excerpt is quite important because Schauberger himself says that the device which worked during a try had a trailing blue-green silvery glow. That's why I brought up like Mirabeau's work. And it's interesting to consider because if the conditions were ideal, then a truly operational device might have looked closer to the light craft like Mirabeau's work, which produces a trailing kind of energetic light streak from shock waves and the craft as it continually ascended upward, right? So I prefer the alternative, and about a year later, the first flying saucer rose up unexpectedly. At first attempt, the ceiling was then wrecked. A few weeks later, an American group appeared who seemed to understand what was happening and seized everything. And so again, here in Calvin Coates' book, he says that the compact side, so I think referring to this event, the machine generated such a powerful levitation force that when it was first switched on without Schauberger's permission, it sheared the 6 1/4 inch, I guess, diameter tensile steel anchored bolts and shot upwards and smashed against the floor. Very powerful principle, like implosion, man. So anyway, moving on, next slide. So here we got more lore. So at the end of the war, he was confined for a year by American forces because of his knowledge of atomic energy production, right? And after his release, under the threat of rearrest, he was forbidden to take up any research again in atomic energy field. Although I guess other people have been interested in it. Also, by the way, that was taken from Alex Anderson's book. So let's look at some past and present current reconstructions of the Repulsine. Okay, so this is the Repulsine B. I may have switched them up. This might be A, I don't know. But again, like I said earlier to preface, I don't believe any of the historical Repulsine crafts that we have today actually ever took off. I think if they were, I'm pretty sure, so when they were constructed, they were probably like, little step ladders to get them to the real Repulsine, which did work. And one reason for this is because we still have mostly all of the parts for these things intact. And so we know for a fact that for the one that did work, there was a part that was intact and it was destroyed. I think in Viktor's department, if you look in the lore that I provided before. So historically, there are only two major versions of the Repulsine. A lot of times these also get misunderstood and mixed and matched incorrectly. So this version is probably the earliest patented form. And another thing to know with the patents, and just Viktor Schauberger in general, is I get a lot of faithful Viktor Schauberger followers who will be like, you did Schauberger wrong, you did this. And like I said in the beginning, Viktor Schauberger's work a lot of times is pictorial and descriptive. And so what you see in drawings, especially as somebody who loves patent dumping, so that's basically going into the dumpster trash of patents and looking at patent designs, what you see in a patent is not necessarily one-to-one with a design. And so you should probably it's better you understand the principles that the inventor meant for the design, but sometimes those don't equate to having the thing actually work one-to-one, right? Okay, so here for this design here, in this model, you have a series of covering tongues. So they're about 60 degrees from one another. There's also a large snake-like opening associated with the lower membrane with internal features whose exact function remain really difficult to interpret. This version is not known to produce lift. For this reason, I treat it as an earlier prototype than a final operational form. This interpretation also seems reasonable when examining the patent, since the device is more explanatory and structurally developmental in the later Repulsine. Okay, so the Repulsine A. So that is the Repulsine that everybody knows when they think about it. So over time, Coates and Freibende, I forgot his name, established a relationship. So so in a lecture given by Richard Freibende, former U.S. airman, Callum Coates was reportedly in attendance in this lecture. Freibende presented images of what he claimed to be Viktor Schauberger's last Repulsine. So over time, the two got a relationship, and then through the exchange, basically word got over to the Schauberger estate. Jorg went over to go and visit Richard Freibende's widow in the United States. And during that visit, several important primary documents were uncovered. Among them was the so-called Purple Report, a 1952 paper associated with the University of Stuttgart, bearing the signature of the professor, but also more things related to the Repulsine A, as we have here. So in my view, the photograph on the left appears to show the same device. A lot of people say these are two different devices, but I think it's the same device with just a different top, a different upper component. Many people, including Callum Coates, have treated these as distinct Repulsines, with the one being the earlier version covered from the previous slide. I've come to a different conclusion. These images most likely represent the same Repulsine with interchangeable modified upper sections. What remains unclear to me is whether the impeller type cone in the lower section was used together with the acorn structure of the upper piece. So basically, what's unclear to me is whether the images here were both combined and used together or separate. I still think there was a crucial piece that might have been missing. I'm not sure. So what else? Let's see what else. For example, the impeller cone could not easily coexist in the same position with the bio-impeller type deal. And there are images that you see here, obviously the bio-impeller. And this doesn't really look like an ideal bio-impeller. Some of these look more for show, trying to work off of Schauberger rather than functional engineering stuff, in my personal opinion. So this is where the engineering begins to blur. And if there is a missing component that enabled the machine to lift, it was likely connected to this upper section in some way. And that upper section seems to be the area where the most significant functional variations occurred. Okay, so then this is another important thing running out of time here, so I might go over just about 5 minutes. There's been a emulsifier misattribution. So this device has never required a emulsifier. And if you look at all of the primary documents, you'll see that the only case that you ever hear of an emulsifier being mentioned within Schauberger's work is with mixtures. And then also this was taken from the Tornado turbine, which I had translated in English, and with my own little hand-drawn notes. In a documentary, I think Jorg made the mistake of accidentally misattributing the ability of the Repulsine not working to a emulsifier that was needed. There was never an emulsifier needed. When the thing took off accidentally and sheared its way through stuff, there was no speak of any kind of emulsifier. I think it was purely from the implosive principles that it worked. I think it's more than likely, more than possible for such a thing to take place. Okay, so moving on. here are some images from a Repulsine, which was replicated by somebody in the aerodynamic industry. This was from a global BEM presentation by Jorg in November of 2019. He said there were folks trying to replicate it, and the quote is, "There's interest from the aircraft industry. It was remodeled some years ago, but they told us there wasn't any effect." And so as someone who worked on this particular model, I'm not surprised, because just some principal things in mind when you're thinking about it. It doesn't look like this will just give you an aerodynamic effect from the images alone, right? So my own work very quickly here. So basically this is what I did. You know, I had a lot of time on my hands and I was bored. I went through and I counted all of the slots, and I, you know, did some digging on the internet and found like people who had actually gone to PKS and posted those images. I counted all of the rills or gills, and then I counted the waves within the diaphragms. A lot of people get on my case, say, you did the waves wrong, this and that, whatever. If you look at the designs, the historical designs which were made, I assure you that the people who were making these were not paying attention to the finer details. They weren't as refined as we Schauberger researchers are. And so they had no cares for things like Kudel horns or, you know, harmonic, you know, distances for the waves to be there, right? And so my intention in making this was just trying to make a historical craft that could be replicated by anyone, anywhere, and reused, and then improved upon. And so that's what I did here. These are my notes studying that image, which was provided for Callum Coates. The only distinct things you'll find in my design is I made the plates a little bit thicker for 3D printing. If they're too thin, it's going to be a nightmare and give you like a squirrel's nest for 3D printing. And I've also combined some parts, but I also have the parts which are not combined. It is not necessary for many of the components here to be like separated. Some of them can be fused together, and that's perfectly fine, but you have to be careful with where you're doing that. So here is the annual ring. For example, the annual ring part was more of a like separator between the functional parts. It really had no, it was just a separator between the cowl and then the lower fram waves. You didn't need it there. And so I was able to get rid of it. It was more of like a man-made need. This was reproduced by Putoff's lab when they did research back in whenever they did research. He's disappeared now. And so these are some of the internal slots. And then I went to the CAD Fusion 360. I reproduced things the best I can with the nice sweeping gradient edges. And I made different variations. So these are just some of the variations I have here. This was the 3D printing design. I forgot how long this took because I tried to make it as large as possible. And I think the printer was like an Ultimaker 3. I can't remember, but my school library had some really nice 3D printers then. And so I would always come in and sneakily do my work and leave. I didn't like talking to people because in the past, well, you get bullied quite a lot for working on things that everyone in institutional science is like, yeah, this is stupid. This doesn't work. It's not real, right? And so, I mean, if you're not working for me and not helping me, then it's better to keep it hush-hush, right? So anyway, I finished the end product. I did end up showcasing it in one of our little library presentations, and I did not test it. This one probably wouldn't be good for testing. It's weak. But the good news is that with all of the files that I've open sourced for anyone, you can go and rebuild this. And you can actually use a CNC machine to make it as well. And so you can do some really interesting things if maybe you get it up to speed or improve upon it and solve the mystery of the upper chamber that all of us are trying to figure out. But I think is a pretty darn close replication as is just based on eyes. How it works in future work, I just haven't had the time. I've been procrastinating. And to be honest, I've been a bit on the low trying to get back into doing this work, but I've been working on Schauberger tubes. That's probably the best place to start when making Schauberger, and doing so using the PKS stuff, like mathematically. So you want to start with these three geometries with the tubes. We have the hyperbolic thing, we have the general cone, and then we have, this was really hard to make, but it's also easy. Again, just make the hyperbolic cone, cut into it, and then you can get all of the nice little geometries you'd like. And so then you can wrap around that and make any kind of tube that you like, and then you get some of the nice little After Effects swirls, right? Okay, so wow, I guess I finally did make it to the end, and I made it to the end, unfortunately going a bit 5 minutes over. I was going to give some final remarks, but I don't think that I have any, but here are the links I have. My guiltless plug is the Inertial Propulsion Workshop, which was started by Brian St. Clair. It's a nice little cozy community for those of us who have been doing work. Again, my field of specialty is in implosive, solid state implosive systems. So a lot of times that roughly translates into inertial propulsion systems, but I have distinction and nuance within that because a lot of people say, yeah, inertial propulsion, I know that. But a lot of the work I've done is very distinct within inertial propulsion, and I do make distinctions when I talk about it. But anyway, it's a cool community. Regardless of whatever you're doing, it doesn't matter. It might not even be inertial propulsion. It's trying to make it more expensive. You're welcome to come and join us. If you have any questions for me, you can always shoot me an email. There's my YouTube. Please give me a subscribe. And Patreon, I'm still setting up. It would be nice to get some monies. And I open source all of my work. ResearchGate has all of my papers and stuff for anyone who's interested. I have also kind of branched into other things. I talk about time a bit, but that's just because Mach effect, when you treat force as a process, then mass also is not necessarily just like a simple spherical point cow as you think, right? And as a computer scientist, or maybe a fake computer scientist, maybe more of a vibe computer scientist these days, right? Because I have great apathy for many things. I like to explore some physics things without using physics. So I've used, like, for example, Leslie Lamport's, he's done incredible work, Leslie Lamport. And there's a way to talk about like things related to like Everett in multi-world theory of quantum mechanics using the work of Leslie Lamport. So I tried to do that. I have that in a paper up somewhere. Or at least my crude attempt. I don't even know if I understand it. So just being completely honest, it gets really weird and wacky. But generally, yeah, I'm into these kind of systems. But I guess that's it. I don't have anything else. I hope everyone was able to hear me clearly. And I guess that summarizes everything. And so I'm waiting for Tim or anyone who can come and slurp me from this as it's been done.
Yeah, actually, I was waiting for you. Let me bring the guys in. Denny, you are a rock star, man. You are an absolute rock star. Looks like Isaiah isn't here. Guys, big applause, giant applause for Denny. I love it, man. I love it. And this is just one of your many projects. So, like, again, I mean, you are on the cutting edge, right? This is like the young, vibrant energy that this community desperately needs to move these things forward. So thank you so much. So yeah, we're at the top of the hour. Do you guys have any questions? We could go to I think that was everything.
Yes, sir.
Good. Have you ever heard of decaf?
Decaf.
Decaf.
No. Decaf. What's a decaf?
Like a decaffeinated coffee.
Decaffeinated coffee. Oh, I drink cocoa. I'm actually a cocoa kind of guy. So I drink just the pure raw cocoa in the morning.
The energy level is off the charts. Loved it. Didn't understand much of it, but the only question I got is: this thing was actually built by somebody or some buddies years ago. Somebody actually built this thing.
Yes. Yeah. So
and they launched it through the roof.
Yes. Yeah. So we have good evidence based on primary documents and also Schauberger's own telling that there was a Repulsine built during World War II, and he was using work, unfortunately, from people inside of the concentration camps. And one accidentally took off because it wasn't supposed to be released at all. One of the workers accidentally did something and it took off. I don't know if it was it took off because there was a high pressure thing or there was a motor to it. I have no idea. But there are eyewitness accounts, principally Schauberger himself. And the Americans apparently also were aware of this. And so that's one of the reasons they were hush-hush about Schauberger and then obviously confiscated some of his stuff. So to date, I don't know of anyone who's been able to reproduce that original one, but we have found around the place different iterations of the Repulsine lying around. And so there are different models that exist with different parts. And a lot of times, most of us think that, oh, these ones definitely were the ones which flew. And I actually had the opportunity to, again, talk to veterans of Schauberger who've been working in his stuff for 20 years, randomly reached out to me. I was like, oh, who am I? Honored to talk to you guys. And they were like, yeah, we also agree. We don't think these actually took off. And there was probably more to it, right? And so probably with the upper chamber, there was something there. I suspect, and I suspect there was something going on inertially in the upper chamber with implosion. In the video I have, I talk about something called the Garuda Sinjavi. And it's basically this root which twirls, and if you put water into it, it goes up this way. And so it's like a geometric effect, but there's also some other stuff to it. It's nothing esoteric, really. It comes down to the fundamental things I talked about with implosion. One of those three things are all combined. And it's really more of an inertial effect when you have a heavy body. So it's conceivable to me that maybe when they understood, okay, the signs between how this is working, they probably had some sort of inertial type thing, maybe like the inertia Plutus and Javi to make it go up. Maybe, I don't know. I have no clue. So yeah. No, please, yes, go ahead.
Yeah, Denny, outstanding stuff. Again, love the energy. You're doing awesome stuff, man. So, couple of questions on it. One, the working medium. So it sounds like water was often the thing, but I imagine you could use air, you could use mercury, you could use, liquid metals if it can handle the high enough thing, high temperature molten metals. Is there like a whole like split there on what mediums to work with?
Yeah, so first let me ask, are you speaking of the repulsing or are you talking of implosive systems?
Specifically the ones that do the thing.
So I guess implosive systems. Okay, yeah. So for implosive systems, yeah, you can have any kind of medium, right? So let's just talk about maybe the repulsing. So repulsing we have, or implosive systems, maybe general. You have mechanical systems, and then you have fluid systems. And within fluid systems, you have pneumatic or air-based systems. Then you have hydraulic systems. So Schauberger's work is with hydraulic and pneumatic systems, which are air-based, right? And so you can apply implosive principles to get the fluid to work for you in very advantageous ways, right? In solid state mechanics, it gets a little bit harder because you have closed looping systems, but that doesn't mean you have a closed system. You have to be kind of clever if you're dealing with masses. So you were talking about having maybe some sort of fluid. So I've proven pretty thoroughly that it's possible and like thoroughly that you can have solid state things in like a closed loop to create a unidirectional force. For an inertially driven thing, without talking about a system, I need to make a distinction between a fluid system that has like maybe a fluid system of mystery fluid, which gives you a gravitational effect from the atomic things happening at the lower level, versus a fluid system where the fluid is actually making the craft itself move by inertial principles. And so I've not ventured into the former, I've ventured into the latter, because the former requires maybe a bit more work with like gravity at the subatomic level and stuff. And, I've moonlighted in that a bit, but not anything too critical. And so, yeah, it can work for kind of anything. In the solid state case, you have fluid systems and you have solid state systems. And so for fluid systems, you have two working solid state masses, which are working with some sort of fluid. And that fluid can be air or it could be water. It can be any kind of fluid thing, which causes an interaction between the two bodies. And then I also theorized, and I think I've kind of proven it through a simulation. I'm not sure, though, 100%. The logical next step would be you could have a purely fluid system of maybe two densities, where it's the same thing. It's just Newton operating again, his third law. So that way you can have a way to yield a single vector of unidirectional thrust in some sort of way. So maybe that answers your question, hopefully in some ways. I don't know.
It does. I have a follow-up.
Please.
So since you brought it up, a variable viscosity fluid, right?
Mm-hmm.
If you had looked into any of those things, there's some of those non-Newtonian fluids out there. You can have rheostatic fluids where you can throw in some, non-Newtonian ferrofluid type stuff. There's a whole bunch of different stuff you can do with fluids besides just regular incompressible water. So I was wondering if you'd gone down that route to see if you can get your asymmetry for your uppiness.
Yeah, I don't know if you've ever seen the movie. What comes to mind? Is it Flubber or something like that? I can't remember. But I'm terrified of fluids, right? I've only kind of gotten into them because of Schauberger. And the only reason I'm terrified of them is just because they're such a mess to deal with, right? They're not concrete, and it's very hard to reliably know how they're going to behave unless you have the environment fine-tuned correctly. Now, that being said, I do have a working fluid system, one fluid system. I wanted to include in this presentation. I didn't, but eventually I'll probably put out with my work. And it just deals with water. And I think water is just a convenient fluid, and I'm interested in inertially driven devices. So devices that can produce just sheer mechanical force in any kind of condition without any kind of tethering. And I was wondering if you could accomplish this with the fluid approach. So it's not purely fluid, it's two masses inside of a fluid using this principle. So I haven't gone into that route too much. I am working to generalize it, though. That constitutes as what I call a category 4 system in terms of the solid state mechanics of things. But yeah, great questions.
So Denny, awesome presentation. I really like the beginning of it as well. I think this is something that we have to remind ourselves, especially here in APEC, from time to time. What is actually the scientific method? Where also maybe we should go there and talk again about philosophy of physics. And we actually should do that, because if we work on the boundary of the known, then you really need to understand what the scientific method is, where its boundaries lie, how it came to be that the current paradigm of physics is what it is, and how to go beyond, right? So I really liked your presentation, also the memes included. It was a very good, very fast presentation, very funny presentation, so awesome. And so I'm a German citizen, I'm German. I read some of the Schauberger stuff in the original German, and it's very fascinating and interesting to me, especially because he fine-tuned geometry to get to his effects in a way that was highly motivated by nature, right? Yeah. So you talked about, like you mentioned the names, Helena Blavatsky, Rudolf Steiner, and maybe some more which are esoterically tuned, but they had a part to them which was deeply, which had deep connections to mathematics, right? So if we go back to Pythagoras and stuff like his society back then, so the order of nature and the mathematical description of that, and using this to engineer, right? So there is a whole scientific path to use stuff that, for example, biological systems came up with, and to learn from it to engineer stuff, right? So I think Schauberger was one of the pioneers of that in a sense, but he was never given the right credit for it. Great presentation. I think you really did it justice. So my biggest question would be, do you think it realistic to actually reproduce the effect in the near term with the schematics and the 3D printable stuff that you have done? Or what is missing to go there? Is the stuff not there, or is it just not printed in the right quality, not put together correctly? What do we have to do as a whole community to make it happen within this year, basically?
Okay. So I think so far as the repulsing goes, the designs I've given are really good designs, very modifiable designs, and they have everything you need. I think the next step is trying to make a metallic version of this design here. So actually, because if you're just going to make it using plastic parts, it's not going to work. The RPMs are just far too high with what they required for this. And so you want to make something which has some structural integrity. But the bigger question is figuring out what happens in that upper chamber, right? And so I think there needs to be some critical thinking there. I think something which might be a bit of a misdirection is that everyone assumes that maybe it was just like I've said this, I think there's an advanced pressure transformer, but that doesn't mean that there's just like really nice impeller sucking in air there. I think there was something else going on there. So there's going to need to be a bit of creativity to figure out what was going on in the upper chamber.
You think there might be something exotic going on, like an inertial reduction or an exotic type of force, or is that too far out there?
I don't think there's anything like extremely exotic, right? So I think that so far as so inertial reduction, right? Or I would just say having something inertially going on there, right? I think basically there's something heavy, like literally a heavy mass. And like you talked about, there's fine-tuning of geometry, and like I mentioned with the Garudas and Javi, so that heavy mass is working with the medium, which is air. And then consequently, the ultimate, the end goal of that reaction process has an effect on the craft as a whole, and is actually like sucking it up as well. That's one hypothesis I have. But the other hypothesis I have is just that the implosive process, whatever is going on in that chamber, was just done correctly, like fine-tuned correctly, so that you're basically just traveling along the, for lack of better words, the vortex inside that's sucking it out. And so that's where most of the work needs to be done, is just in that upper chamber, I would say. But I've said this on my commentary, and I'll just put it out here, is I'm no stranger to many other things within the research of propulsion and whatnot. And so, I've also been interested in the bifield Brown effect from a physics perspective. And I built my repulsines so that they can take full benefits of the bifield Brown effect. So they can, if you put the right kind of dielectrics in between them, and you can go and calculate the Ks, they can be repurposed so that they will work as nice little things which utilize the bifield Brown effect. So you can have a charge with this, and you can also spin it around, and you can use that to test. I would first recommend doing the mechanical stuff. That is more important than anything else, so we can see what's going on with airflow. But I included that in mind when I was designing this, because I said, well, you know, like there was the triboluminescence effect. So let me see if I can just have a working electro aspect to this to see if that relates to this in any kind of way. I mean, that's a distinct, the triboluminescence, like Mirabow's work. I don't know that that qualifies as triboluminescence at all, but just to get an idea of what was seen, you know? So yeah, I hope that answers.
Yeah, perfect. Are you actually planning on doing the metal parts, or are you putting it out there and saying, here are the prints, somebody please use a big CNC and make it happen?
The latter. So I hear the prints, somebody go out there and do it. Because I no longer have access to a lab or anything. At best, the only thing I have access to now is computer-aided design. But I don't have access to make anything or do anything anymore. So I'm just kind of limited to pen and paper now. And so my goal with open sourcing everything is that community efforts will be driven for literally anything and everything I've done. So convenient, because especially for Schauberger, I've often seen like paywalls and then little esoteric groups of like, I am the one who has figured out everything related to Schauberger, and here I will seed this with you if you give me your email. And I'm like, I love the work you've done, but let's just give it to everybody instead and see if this makes this faster, you know? No hate against people trying to, you know, like I definitely need monies too, right? So, but, you know, but like, you know, like also I would love to see a Schauberger Repulsine working. So that would be cool. Any more questions?
Sorry, I'm dealing with a couple other things going on in chat here. Okay, so
I got one more for Denny.
Yeah, and we can do, guys, we can do open discussion too. It's like 4 or something. So we could, unless you guys have lab updates, but we could just go right into open discussion and keep going.
I got another question for Denny.
Sure.
So you mentioned the triboluminescent kind of thing in conjunction with the bifield Brown. I was just curious though, again, that would go back to the working fluid, right? Because triboluminescence with water, very different than triboluminescence with something like mercury, right? So I was just wondering how far down that rabbit hole you had dove to see about agitating the conductive liquid in a way that you can achieve the charge asymmetry within the device to get your Brown type thrust.
Yeah, so I mean, I've not had the opportunity to work with anything that is conductive. So everything that I have done, I try to, this is where I leverage the physics background and principle. So to the fullest logical conclusion, when I'm designing something, I just try to be informed by the physics. But I like to treat triboluminescence as being like distinct from the bifield Brown effect. They all might be related in some sort of way, but the triboluminescence is like a mechanical effect, agitation with a medium, which like is kind of like an after effect, which causes it. And so just so far as trying to get in like a medium which works for you in the most ideal way, right? To have, you know, some sort of force and going upwards, I'm still doing work on that right now. I think right now that's why I'm tackling the problem of having an ideal fluid. And I'm doing it kind of like from the inertial kind of angle. A lot of people are kind of brute forcing through using common aerodynamics, which is great. But I think that if I've understood Schauberger correctly, I think that the aerodynamic qualities we see in the Repulsine were kind of like just attributes, and it was kind of a comprehensive or synoptic system of all of the things that he had understood, like in applying implosive dynamics, like together comprehensively. Like if you're looking at a jet turbine, for example, like I don't know, the SR-71, 72 now, Blackbird, you have like a rebreather kind of thing going on where there's so many different things going on in the process. So we have standard aerodynamics and explosive stuff going on, but there is other stuff within the explosive process that is happening in different stages there, right? And so it's a similar thing for implosion as well. There's an inertial aspect to it that I think maybe people are ill-informed. That's just my hypothesis. Maybe at the end of the day, it's really just like a impeller thing, you know?
You want to go first?
No, go
Okay.
first.
So my question would be, have you calculated the Reynolds number for the main flow path?
No,
Or
no,
at
no, I've
certain
not
points of the...
Yeah, like I said, I've not done, I've been afraid of the fluids, so I've stayed away from them.
Okay.
I've not done anything. But it shouldn't be too hard, right? Maybe that'll be a subject for another YouTube video to do that. It shouldn't be too hard. Fluid
That would be very
dynamics-
interesting.
Yeah.
And
yeah,
it could also, like, because I'm working in a framework which is highly geometry driven. That could, if you calculate that the Reynolds number and the Strohal number, so the pressure mapping at all, and the spin direction reversal, like looking at that would help distinguish if there's a real geometry driven field effect. That would be very interesting.
Yeah, that would be especially interesting for the rills or the gills, because those are effectively airflows, right? And so I just took those designs one-to-one from what I saw there, but there would be optimal, probably Reynolds number for those to allow them to work in a really good way. And then the same thing for the little impeller thing as well. So for the entire system, and that's where the community effort comes in. Hopefully somebody, builds one, and then we can look at that. But fluid dynamic model, I could probably examine and see that. That would be interesting as well. So, next question, Nikolai.
Okay, so look, this is, I love your energy and stuff like that, but I have a suspicion that I like the lore. Okay, there's no doubt about that, but I think there's something missing. Absolutely, because if it weren't the case, then people would have reproduced some effects, but you don't see so many passionate groups and stuff like that doing this, and not. So I think there's the lore. Okay, I like it, but there's something missing, in my opinion. What do you think?
Yeah, no, I agree with you. There are definitely passionate groups, not as many as we'd like, right? But I agree with you, and I came to that conclusion with the other guys who have been working on Schauberger longer than I've been. I want to say longer than I've been alive. But anyway, I think for the Repulsine, I have a very strong suspicion that there's something missing, and we know that because in the lore it says that there was a critical part that was destroyed, and so that critical part, that could become the subject of all sorts of like fiction. It could be a glowing gem that is bringing forth ninth dimensional energy from God knows what dimension, right? I don't know what it is, but the point being that there is, at the very best, we know that he was using implosive principles. And so there was something which was doing that to work to the benefit of this system in some sort of way. And we have like kind of the fundamentals there, but we don't have everything. So yeah, something is missing, critically missing. Otherwise, yeah, you'd probably see it on YouTube. Oh, I made a Schauberger turbine and I'm testing it out for my drone, but we don't.
It sounds to me a bit like of the Nazi bell, a bit.
Yeah, so that's where I would say it's different, because I've also done some work. Yeah, so however,
but in terms of lore, in terms of lore.
Yeah, so Schauberger, in terms of the ufology of German ufology is really interesting in World War II. And I'm not sure if I can remember all of the UFOs off the top of my head. And they're not really UFOs because they were built. So like the Schreiber models examples, I think were pretty inspired by Schauberger. If you look at the way they are from like the Coanda effect, right? I think Schreiber, if my memory is correct, came to the US and then was like asking for money to try and continue that. And I think there's evidence that those kind of machines were built. They're gas, they're clunky, and you can definitely get something up in the air using the Coanda effect in that way. Now you can improve it by using the principles of Viktor Schauberger. So there's that. And then there's the Hananabau, I can't pronounce correctly, which for me still remains, that remains like an esoteric. The principles there are like just pure, some sort of like electrogravitic, if it was ever built, if it works, right? Again, it's just lore for me because I just don't know. It's farther away from the Schreiber is closer to reality for me. That is farther. And then you have the Bell, which I think was actually built. I think there's really good evidence that it was actually built, but we don't really have any kind of primary documentation to prove or anything about it. But so far as what has come out of the lore with that, a lot of people say, well, and it's possible, like if you look at the home generator, right? In terms of the way Schauberger's pumping system works, if the Bell was something that was built and the Nazis were experimenting with, it would make sense to use a Schauberger pumping type thing. But I don't think that the bell had any kind of relation to Schauberger. I've seen a design on the internet where a guy's been like, oh, the Nazi bell, look. And he's just basically put the home generator and called it the Nazi bell and says the Vimana, it's the missing bell, right? And I'm not convinced. I'm not convinced because I think the timing with what Schauberger was working on, the Repulsine here, yes, it was during World War II, but that was a separate project entirely. And then you can also look at where it was done. There's evidence as to where it was done as well. You can look at that place. And the bell, like if it was done at all, right? And so I think Schauberger's principles weren't used for the bell. I think the bell was something different. That's why I said mystery fluid. And I think the bell, if it worked, definitely leveraged things like velocity, but it was also doing something electromechanically there and nuclearly that I just don't understand on the nuclear level with fluid dynamics. So they all might be related in some sort of way. I mean, at the end of the day, it was a closed system, right? So it wasn't spitting anything out. So by definition, it's a sort of impulsive system, an esoteric impulsive system. Not saying it's not. I mean, esoteric and sort of like, wow, I don't know why this thing works, if it worked at all, right? So,
but it's not bad to use the term esoteric here, because we have to realize that the Nazis actually had a state-funded esoteric research department.
yes.
And that's just true, okay? They did that. They had thousands of people with a lot of money and the whole backing of the Nazi state researching esoteric stuff. And going all over the world to get information and bring it back and do something with it, okay? If something came out and blah, 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 this is a completely different question. But we know for fact that this was real, and we know the reports, like we know parts of the reports that they brought back because they are there. You can go in the archive and read them. They're yeah, right? And I've read a lot of them. Sometimes they're really crazy.
Really out there, no?
Yes, they are really out there, but they are out there, right? They are really out there. They are. And so, yeah, the place where the bell was built and where it was placed, it exists as a giant underground structure. And you can go there today, right? And Jared.
Yeah, Denny, I was wondering, I know that you're focusing heavily on the inertial side of things, but since we're talking about implosion, I can't help but wonder, and the tribo thing, I can't help but wonder if there could be an electromagnetic component to it, possibly something along the lines of like doing separation of isotopes, right? If we're talking about any of the radiological stuff, or alternatively, or completely separately, you could be looking at like an MHD kind of angle. Or you could be looking at a sonoluminescence kind of angle where that cavitation rate, that implosion rate was somehow set by the materials and the pressures. And in my mind, that would be the most interesting one because there is some data out there that suggests that you can get extraordinarily strong magnetic fields at the very last instantaneous moment of a sonoluminescent cavitation.
Yeah, no, I hear you. So two things. So first, for Joel, I want to say, as I mentioned before, I think it was Heinrich Himmler who was like the esoteric king or one of these Nazi like in command. Literally, that's all he did. It was just wild. I have a friend from my university days who is, I think, a professor now in Germany. And his major was basically specializing in Holocaust studies. So he knows the Nazis through and through. And I talked to him about that. He's like, yep, Nazis were definitely into ufology and all this weird stuff. And it is out there and it's very weird and it's strange. It's not comfortable to talk about if you're coming from like a nice, institutional place. But yeah, it's just so strange. And yeah, it's there. It's out there and it's out there. And so now to answer what you were saying, Jared. So I guess for me, there are many ways to skin a chicken because I really like cats and we don't want to do any harm to kittens or cats because we like cats here. And I think there are many routes at approaching gravity, so to speak, or whatever we're calling gravity, because honestly, I think many of the things I think gravity is just one component maybe of something else as well. And it can be, but I don't know. I mean, this is just me talking. Like that isn't my area of specialty. My specialty is within solid state systems, because for me, in my mind, it's easier for me to like touch them. It's easier for me to hold them and I'm familiar with their dynamics. And in terms of like implosive systems, using them for all of this stuff, right? So at the atomic particle level, to exploit things, whether it's through Sono such and such you mentioned, which definitely relates to cavitation. I forgot the name of the chap who's done a lot of work with that. And then the electromagnetism component, right? In my work specifically, nothing necessitates electromagnetism at all. But so far as just talking about gravity, since we're here, I haven't gotten the opportunity. I just have had so many other things I've been working on. I mentioned temperature having an effect. So obviously electricity, if you've heard of anything called the, I'm forgetting it, there are actually two types of effects. They're well known in physics because we have to go and do them in lab and they teach them to us. The Pelter effect, Pelter something effect, and the sensorite effect or something where you have like a, voltage difference with that sort of stuff. And then you can like get like, some sort of like electrical thing from temperature, right? So these are well-known effects. And actually, this is something I wanted to do in a paper. I just haven't had the time to do it. There's a chap, let me see if I can remember his name. The something ring. Anyway, he built a ring for cancer. And there was some research which was done on it. And he basically it worked with the temperature differentials. And it also had some proof of having some mass, some like losing its mass, right? And so I think they just kind of all work together. Adjacent to that, there's a patent which exists. And I'm pretty sure the guy built it just because of how technical it is. And then also I was able to find some obscure papers which say that, like, the United States government was interested in it, again, just more lore. But it was really popular when I was younger, of a gravity generator. And so again, my approach has never been electrodynamically because I'm quite frankly afraid I'm going to do something dumb and like get cooked. And it's easier to explore some of these effects just by using normal masses. So he used basically a bunch of brass discs and had them rotate really fast and was looking at things related to the moments of the individual atoms and having them arranged. And that could cause a measurable effect in gravity and also temperature as well, if you're looking at things. And actually, my working framework that I like to use when I'm talking about things comes from a guy named Theodore Edmund Davis, who did work on the cosmic matrix displacement model and had a very good theory for gravity and a working hypothesis, which he actually probably had tested in some place, where he used a very dense disk and just had it rotated. I mean, this is nothing new. I forgot the name of it, but in the physics world, when we're talking about analogs for gravity, we just imagine a really fat thing that has a lot of mass, rotated a bunch, and then you'll drag space in some sort of way. And we hope to see an effect with that, right? So anyway, I guess what I'm trying to say is there are different avenues. And then when you start seeing like parallels with effects related to temperature and related to like electronics and stuff, and then you start seeing maybe some slight decreases in mass, they could be something else. But from some of the stuff I've read, I'm not an expert, right? So I can't conclusively make any statements. Sure, they could be related in some sort of way. But my area of focus has only been with inertial stuff because I don't have to deal with all of the higher order weird things as of yet, right? I can leave those alone for now.
Have you looked into Kava Mead's G4V gravity framework?
Yeah, I'm familiar. So the reason so it's actually really interesting when I came across this work. I have to like sit down and actually really like meditate on it. But Curtis Horn has done a lot of work trying to. So he came out with his new paper, his unified quaternionic model. Quaternions are very useful mathematical tools to use things, especially with like imaginary. So imaginary numbers are not like useless. They actually have real physical purpose. They're actually telling us some important things in space, right? So it's interesting again with the parallels. I'm just when I say I'm GR agnostic, it's not, I don't believe in Einstein. And I don't think GR is like real. It's that the frameworks like we're talking about, I work from a very fundamental level and I've not needed to use GR or anything that necessitates it yet. But you can still get a lot of those effects that a lot of people will have to go and do a lot of hoops with really complicated equations. I still get the same end result using very simple like matrix rotations. So the model you're talking about is really nice. I like it a bit, or I mean, I need to read it. But there are some other frameworks as well. I mentioned Theodore Edmund Davis's model, which is more descriptive. And it hasn't had any math to it, but the math already does exist. There are a lot of people, and it gels well with these sort of things. And the reason I like the model you just mentioned, Mead's approach, is because he's an engineer. And engineers, I feel like historically, we've been more faithful in dealing with reality as it actually works functionally than in theory. And so, I mean, I still consider myself an engineer, even though I studied pen and paper physics in university, right? And so I think that's why there are some appreciable attributes I see inside of that theory. I have to go and look at it. Again, Curtis Horn makes a covariant theory for that as well, with some assumptions, right? There are a lot of assumptions with these models whenever you put them forth. Minimal assumptions are good because then you have other assumptions which appear by accident that you don't need to describe. But I find that when you put so many assumptions to a thing, it doesn't actually help you. Sometimes it can limit the scope of what you're actually trying to put forth. So it's an interesting model. I really need to sit down and meditate on it more, because these are all behemoths of works, right? So in one sitting, I've mastered it.
Curtis sends his regard, and I think like his framework is like it's a unified field theory, right? So it's like extremely big, but Cover meets G4 V framework. It motivated a lot of Curtis' work, right? And it's like a predecessor of UQFT in a way. So it's basically, I think, what you might be looking for, because it's a lower level of Curtis theory in a way, right? And just a part of it, also like simpler. And as it treats gravity in a 4-vector potential language, it's more closer in spiritual electromagnetism than standard curved spacetime general relativity, right? So that might be good for you. And I think in general, it's very useful to think about rotating vertical Mach-coupled momentum exchange systems, right? So I think that would be very interesting.
Yeah, no. It's there are a lot of appreciable attributes. I think right now for me, I think it's a good framework. There are many like unified theories, and I think that these are some of the more robust ones systematically in terms of the way they lay out the math. So like the what's his name? Curtis Horn's work is definitely like the natural logical like subsumption of the previous work there. I think the cosmic matrix displacement model, Theodore Edmund Davis, is also a unified theory. What it lacks is, because Davis is like the same lineage of Schauberger and so on, is that he was not a physicist, although he was talking with physicists, and I had the opportunity to talk to his son. I put a dedication at the end of one of my papers to him because a lot of his working assumptions are correct. For example, in terms of magnetism, and this kind of surprises me. I don't know if anyone here is familiar with the work of Howard Johnson and Gerhard Bayer. And so they did a lot of work in like the 80s and the 90s with magnetic field sampling. And they even had some of their data featured on the front cover of the National Laboratory, right? And so it wasn't like made up data, but to this day, nobody is talking about it. And it's almost like it doesn't exist. This field of spintronics has been developed, but has been developed within a very narrow kind of gating for like semiconductor things and whatnot, but nobody's talking about it from a macroscopic perspective. And so I think this is just so important because these are really interesting physical attributes which aren't being discussed. And Theodore Edmund Davis, who I did not come in contact with his work, makes like physical assumptions which are one-to-one with the magnetism he's talking about. And then in terms of gravity, his assumptions for gravity, again, I don't know that he was aware of any of these researchers, but another parallel you can find is with I call him irresponsible. I think he knows what he's doing. He's also German. Martin Temjar, I think he's sometimes very irresponsible with his work. He's not being a fair researcher in some things, especially with some of the work on electrogravitics. But anyway, he had a really nice paper on a kind of gravitational monopole. And it was so strange to me because that was the working hypothesis that Theodore Edmund Davis had. And not only that, the patent I mentioned before, which came way back in like the 80s, was the same exact principle that was used and actually had some data. And anyone can replicate these experiments. And they're kind of hard to replicate and make sure that you get the data correctly. And so they're just using literally heavy masses, or they're just rotating things which are heavy really, really fast. And so the reason I think Edmund's framework is just so appealing and easy for me to work with is, first of all, no one has taken time to articulate the mathematics. And then secondly, just because maybe I'm still a little bit quasi-domesticated by institutional physics, before I graduate to start using higher level tools, I want to make sure that everything I do is at the lowest possible level with the things that I've known to be true and faithful within Newtonian mechanics, which in of itself can be like insufficient in some ways, but not like it doesn't work. Like it definitely works. It just needs to be qualified, right? And so very excited to go through these papers and work. And I'm just very happy the work that's been done, especially in terms of Mach, to have these things existing as articulations for unified theories, especially with space-time. But there are just some treatments of space that don't rub me correctly. that I'm still trying to work through, right? Like I have my own qualms with things that, I'm just not completely bought in on. Like the formulations and stuff might be fine, but I don't know that they're necessarily the right angle to go. And speaking of which, I got to look at some of your work with, I wasn't aware of him before. It's a 2-part lecture. I forgot his name. Very He's very, very interesting stuff with him. He's brilliant. He's absolutely really brilliant. Like his stuff is like really interesting. Yeah, I'll have to like sit down and like also read some of his stuff. I don't know that I agree with some of his assumptions and stuff as well, because his stuff implies like a graviton. I've never been a fan of the graviton, so to speak, right? Like existing. That's not to say it doesn't exist. It's just that, when it comes to particle physics and doing certain things, there are reasons why I feel uncomfortable. But what we can operationally call the graviton, I'm fine with. But he reminds me a lot of Christopher Langen from a philosophical perspective, because Langen has done absolutely incredible information theoretic work. I think the problem is because he wasn't accepted in mainstream circles, he didn't have the opportunity of being like refined in the way that he like communicates in the accepted academic language. And so you'll find a lot of like maybe verbosity in his work, but the content is incredible. It's absolutely incredible. And if you take it just a level lower in terms like from the logic and the other stuff, it is kind of a nice gateway into some of the other stuff. You can see parallels like with the guy you were talking about in that slide there. Not slide, in that presentation as well, right? Langen's work is absolutely incredible, but I don't think it will be truly appreciated until we do a better job of developing the informational theoretical aspect of physics, which I don't want to talk about because right now I'm trying to strike a nice balance between being not so fringy and then still being somewhat like, I was on the leash.
But that's like the biggest problem, that you're like, you already see how science needs to be in 100 years, right? Mm-hmm. And you're not allowed to talk about it because you want to be part of science right now. And you are not allowed to be a part of science right now if you understand what the shortcomings of the scientific system right now are. And that's like, it's completely stupid. And it is also, I think, one of the reasons why some of the most brilliant people in like throughout history had to work from outside of the system, because inside of the system, you're not even allowed to think that far ahead, right?
Yeah, no, I could go on. I could make an entire lecture on this and my experiences, right?
I felt that in the beginning of your talk, and I really liked it. Yeah, you should maybe do it for APEC if you're comfortable.
If Tim allows me, I'd love to do that. I mean, like, so, I kind of wear it like a badge now, but it was actually kind of annoying in the beginning. Is that during my tenure, my journey within academic circles scientifically, they would just say I was a philosopher because my stuff didn't look like the stuff they were doing. And I was using real scientific language and mathematics to talk about things. And yeah, I moonlight with philosophy, but I'm a thorough experimentalist through and through. Like I've done research with like toroidal anipoles and dipole moments.
I think that's a high compliment, because all the sciences are just small parts of philosophy. And
yeah, I was just going to say the same thing. When science started, they described themselves as natural philosophers. That's so.
Yeah, I started to call myself a natural philosopher. Like I was a physicist for all my life, but since like 1 year or so, I shifted, because I think that terminology is more broadly describing what I'm actually doing right now, and I think it's a way. The term is just way more mighty than physicist is. And people should understand that. Well, and if they don't, then
y'all know what the word science means. Do you actually know the actual definition of the word science?
I think its root has to come with like something with wisdom, something of the sorts.
It's science.
Science.
It's literally of the mind, a new change.
I did not know that. I did not know that.
It's a contraction of two words, psi and ensia, which is essence. So it's of a new mind essence.
Oh, I mean, there you have it.
So it's a philosophy. And, experimentation is the is the root of it, and then physics is the death of it.
That's what
You know,
PhD
I
stands.
love all
Yeah,
of
exactly.
I love it, Andrew. I love it.
And
But
that's
you're
why I
totally
like
right.
to call, that's why I like to call myself an experimentalist. That's like the short blade edge. Is that I also do consider myself in many ways a philosopher. Thank you. Yeah, I do think it's a high, like I wear it now, but you know, especially when I'm trying to communicate my ideas, you know, to all of these other people.
Denny, I think what you're doing is absolutely wonderful. I mean, everyone has it's like their own mixture, right? And that's, I mean, I'm going to sound preachy, but like that is what the dream of APEC is for me. Is I mean, I'm 50, right? So when I got into this in the 90s, I know Mikolaj is smiling because you're probably at least in your 40s. So, but
I am in my 40s, yes.
there you go. Yeah, well, give it a few years. When I got into this, it was looking up old textbooks in a library card catalog where you pull it out and you thumb through, 3x5 index cards, and then you walk 4 blocks or you walk 4 floors with a bag full of photocopier change, right? And the biggest thing that struck me back then, the reason I started doing interviews like back in the 2000s, was you have this community of brilliant minds and they're all different and they're all unique, but they overlap. And then like the challenge is like some of them meet up at a conference, but not all. And then they pass stuff around through letters and email and VHS tapes, but not all. And so when we started doing this conference, I mean, it was just like, we've got this community together, right?
Yeah.
And so, yeah, I'm all for it. This is like the best of I think what APEC is all about.
It's an honor to present and be on this platform.
Well, thank you. Thank you for coming. It's I mean, I don't think we're trust me, if anyone deserves to feel honored, it's me. I'm happy to try and move things forward, right? Because I've seen in the past, I mean, you have groups of folks and everybody has like limited money, limited time, limited bandwidth. And it's like, what if we could get them together? What if they could share and collaborate?
Yeah, cool. Would be real cool.
Hey, Tim, can I do a quick update? Because I got to cut out it pretty soon.
Yeah, go for it, man. Go for it.
All right. So, can I upload or no saxophone situation, but
yes, please, no saxophones.
Yeah, no saxophones. Looking to see where buttons are. Not seeing button. Is it this button? Share screen. Okay. Yeah, everything's different every time.
Okay, there we go, sir. Ooh.
Okay. So, big news. Exodus Propulsion Technologies has moved to its new lab. It has 1 full-time employee, me, and soon to have several more. We've got a small staff that's forming up. We've got some exploratory operations going on, and we've got the big first public showing of Warp Drive at Dr. Charles's Electrostatic Conference of America or something. Electrostatic Society of America, the friendly conference or something. Anyhow, it's about 2 weeks. And we've actually had a visitor, our first international visitor come in. Visitors. There's a better half of that team, by the way. Yeah, we had Joel and La Nina. I cannot pronounce your La Nina. I cannot pronounce her name correctly.
We started to name ourselves Andrew and Linda for Starbucks and all the places that need names because people can just not pronounce our names. So,
well, we're honored. So anyhow, this is the shop. We haven't moved in. Since this is 2 weeks ago. We've moved in a whole lot of stuff. There's Dr. Charles, deep in thought. Trying to figure out why the propulsion unit was making an absurd amount of thrust. We didn't figure that out, so we just threw it away as an outlier, and we're moving on. we're doing great things. Really are. So, if you're in sunny Florida and you feel like signing an NDA, come by and visit us. That's it. That's all I got.
Sorry, I'm muted. We got to give another applause to Denny also. Another applause to Denny. So again, thank you, man. Especially with the time zone thing. I have a friend, Will Riken, who is at Nara in Japan. I don't know.
Nara.
Okay. Yeah. I just know that it's in Japan.
Lots of gears. I call them gear because
he comes on calls sometimes, but like half the time you could tell he's like not sleeping, and it's like, dude, go to bed. And dude, Jared here has no excuse because he's like an owl, but
amazing.
Yeah. Well, and then Joel, you're driving up, right? So you'll be here you'll be passing through on like the 17th, I think, or something like that.
Yeah, I think the 17th or the 16th. I think the 17th, yeah. So,
Joel, what was Falcon Space like? You went and visited. I saw a picture.
Yes, that was awesome. We met Mark Sokol, of course. Had a tour through Falcon Space. They're trying to build something to convert this kind of inertia into this kind of inertia, right? Or momentum, I should say, probably. And I've met with Michael Perron and his dad. They are both terrific people and very good theoretical people. And I got them interested in Heim theory. We had a great talk. They were also they had a great talk with my wife as well, who's a mathematician, right? So they were very interested in what she was doing. And we had a very great time at Falcon Space. And yeah, Mark is a very nice guy. I really liked him, and it was really a good time. We had great food, Peruvian food. Never tasted something like that. It was very awesome. Yeah, I've never seen a Peruvian restaurant. They just had one right next to the lab. So that was a great time. I'm looking forward to all the other APEC stops that we're going to do on this American trip. So yeah, so far.
How was New Jersey barbecue? How did New Jersey barbecue compare to Florida barbecue?
So far, Florida won. But Daniel Davis, our next stop at the upstate New York, he said he has some secret barbecue places that will not be beaten anywhere else in America.
I can attest to that because I spent many of my summers in upstate New York. So upstate New York barbecue, they got the Amish there too. Amish barbecue is still quite delicious. So
I think that is his secret sauce, an Amish barbecue. Yeah, so
there's a divine sauce.
It's all homegrown and it's with love and divine inspiration cooked, right? So it must be amazing. I'm really looking forward to it. Yeah.
And then I want to go on the record to say that Joel had never had sweet tea from Southern Sweet Tea, and full of ice, nice big Sonny's cup, and he about drank the whole thing. I was stunned that he drank a freezing cold cup of sweet tea.
It was very nice. Yeah, I like sweet stuff. So yeah, what can I say?
Well, guys, I put in an entire water system today, and I am tuckered out. I did want to show one quick thing. This is some amazing German engineering. This is a vacuum chuck, and them little tiny holes. There's hundreds of them. You can't even see them. They're like 10,000ths of an inch across, and when you put a real flimsy, like a sheet of saran wrap on here. Okay, you just anything, a piece of paper, it's just absolutely held down under vacuum. This is the finest. I mean, I got to tell you, I've bought a bunch of vacuum chucks over the last couple of years. This is the first one that actually does the job without deforming the material. It's stunning. It's like $800. So there's nothing cheap about German engineering and German manufacturing. But this thing is a quantum leap over anything else that's on the market. They're out on eBay. You got to pre-order them. Takes about 3 months to get them. Thing is amazing. So, manufacturing's important too.
Absolutely. When you said this is a leap in German engineering, and then I just saw the USB with TIG, I was like, interesting.
Oh no. Yeah. I had to draw up and in order to hold down the stuff, I got to actually print up a frame, put it down so that the laser, because when the laser hits it, the stuff wants to warp a little bit. So I got to hold all my soft materials down in the laser manufacturer. So it's a very complex process, but it all starts with being able to hold a piece of saran wrap. I mean, the stuff I work with isn't much more than that. So it's really kind of it's been an interesting challenge to find manufacturing. I noticed nobody talks about manufacturing, but TRL, technical readiness level. Everybody's into technical readiness level. They want to get to space or whatever with TRL level 7, 8, 9, whatever. That's manufacturing. Nobody ever talks about MRL, manufacturing readiness level. And if you don't have a manufacturing plan, you can't convince money to come flow your way. I did not understand that. So I spent the last year working on manufacturing. And once we cracked it, it's impressive. If you have your TRL level stuff lined up with your MRL level, it's a whole lot easier to convince people to fund your dream. Anyhow.
Isn't the MRL the whole reason why some solar tech and some battery tech and basically everything graphene, like it's always comes down to we made a really cool thing and we have no idea how to scale it.
Exactly. Yeah, we got one of the guys on our team, peripheral team. He's a battery genius, and he spent 15 years figuring out how to make his research project he did in college into something he could actually manufacture. And as soon as he did, boom, he got all kinds of military contracts and stuff, and it was well earned. I mean, he had a brilliant idea, and he spent an insane amount of time making it actually manufacturable. Because if it doesn't matter if you create the ultimate unicorn, if you can't build a simple assembly line of them in some way and crank them out in some way, you have to be able to reproduce the stupid things. So that's been our Achilles heel for a very long time. Is we can make one-off amazing thrusters, and the trick is can you make 100 of them? And that's been a real hard slog. Real hard.
Definitely attest to that. I mean, doing a lot of independent research because I had to outsource so much of the manufacturing because I couldn't get anything that was reasonable and also within the tolerances that I needed for some of the more refined things. And once you get that worked out, the manufacturing process worked out and dirt cheap, it is way more beneficial to the field than to share with people, right? So that they can go do it themselves, or then you can, go into, hopefully maybe make a business out of it too, right? And so that's something which is often overlooked. I guess just because most people, when they're in the institution, it's like unlimited funding, but because there isn't the laws of economics, they're not reined in to think about, okay, well, how do I make this to scale? So it can be something that is easily replicated and used everywhere else, so, yeah.
Yeah, and, I came from it's not really the commercial space program, it's the U.S. space program. They had unlimited money in the 60s and 70s and then into the 80s and 90s and aughts with the shuttle program. They just kind of went up and spun around in orbit. But to go from unlimited money but someone else's plan to no money and your plan is an absolute paradigm shift. That's why I funded my own project for a better part of 10 years. Yeah, pretty much 10 years. It just, there was nobody out there that had any kind of vision to go as far out on the limb for something completely impossible as I did. But, I'm not the only one out there. I mean, there's lots of other guys that are doing, crazy edge physics and crazier edge, manufacturing. So I wish them all the best. I really do. I'd love to team up with a couple of them, but doesn't seem to happen. So if you ever make it to Florida, man, you need to pop in here, Denny. I know Japan's on the other side of the world, but I don't know if I can remember any of my Japanese that I actually spoke semi-fluidly, but we'll come up with something.
It'd be fun. I'm actually I'd love the tea. I'm actually an East Coaster, so it's not far away if I ever come back.
Oh,
so.
What are you doing in Japan?
That is the question. So I guess work is probably the answer, or what was work. So, and also a way to step away from all of the stuff that I have been doing, because there was like no movement whatsoever. So, yeah. There are more concrete answers, but I'm not giving them here.
If you ever come back to the East Coasters, I don't know about north of the Jacksonville, but if you ever make it south of Jacksonville, come look us up.
Sure.
We're just outside of the Kennedy Space Center.
Sure, yeah, absolutely.
Like about 200 yards.
Unbearable humidity, but...
It is. It's 100% humidity outside right now. And it was all day. It was miserable.
Yeah.
So that's why I'm inside with the air conditioning and a working water system now. So, gentlemen, it's been a pleasure. Tim,
Drew, it is wonderful. I am not going to be able to make it down there by the 16th, but I will try and make it down there this summer if I can.
That's okay. We have postponed our great media blitz.
Woo-hoo,
a couple of months so that we can prepare. Because I don't want to speak. I don't want to speak bad of the people I don't like, but there's recently been a major media blitz over a guy who built a battery that sucks energy out of nothing. Amazing physics, amazing engineering, but apparently the media presentation flopped, and I don't understand that, but apparently it got a big backlash, and we don't want that to happen to us, okay? Because we're about as free as you can get.
Really? So you're talking about? I mean, if it's okay, can I be more? And you don't have to mention it by name. I think you're probably talking about Sonny White, right? With the Casimir.
Could be.
Casimir
I don't want to talk bad about anybody I don't like.
So there was negative. You're saying there was negative media.
As far as I can understand, if you go look it up, there's a whole bunch of stuff in front of his stuff, and it's all the negative stuff. And it has nothing to do with his physics. His physics is rock solid, and his engineering is brilliant. But apparently, he's made enemies during his lifespan of screwing people, and apparently some of that negativity fed into the media release. And I have done the same thing. I've made a lot of enemies in my life, and I don't want our big media release to get bungled up in. So we're planning on some kind of coordinated media release.
It's interesting. It's interesting that you mentioned that. Yeah, it is interesting that you mentioned that.
Sabine Hossenfelder gave him a 10 out of 10 on her bullshit meter for that project. So she has about 1.6 million subscribers. So
again, I personally believe the engineering is brilliant. I personally believe the physics is solid. Everything else, I'm not going to comment on, because my mama raised a Southern gentleman.
Wait, this is warp drive, Sonny White, right?
Yeah.
Yeah, he's known for that as well, yeah.
Yes, it is.
His warp drive didn't work, and he's trying to make money using micro generation.
It's a micro Casimir effect. Yeah. Again, I think it's brilliant, and I'm sure it works. And Dr. Charles has struck up a friendship with the guy.
Okay.
There's also theoretical work from Germany from like 20 years ago that really suggests that what Sonny is doing is a way more advanced version of that. And that worked. It definitely worked. I knew the person who did the research. It was just not scalable. And Sonny found a way to make that even better and make it scalable. So, yeah, I'm I think it's solid what he's doing.
So we just want to make sure that we don't make the same mistakes, because we're even more fringe than that, and I've made a lot of enemies in my engineering career. So we're just trying to learn from a media experience that we know nothing about, and that's what I'm saying is we're not gonna rush our media release. We're gonna time it so that we have a decent website, because our website's terrible. And even if I don't even know if it's up right now, it goes up and down like a pogo stick. And we want to have documentation, and we want to have Charles wants to have one of his papers released, because I told him he wasn't releasing anything until we were out and a going operation, which we now are. So we're trying to get all our ducks in a row, and hopefully we'll have a better public going. And who is
Drew,
the person?
I think what you guys are doing, one of the things that strikes me, right, is like, because, and again, this would apply to everyone, to all of us, like you're up close to these things. And it's like, up close, where is this? It's like, I don't see a lot of change on a day-to-day basis. I see an obstacle and thank God I got this taken care of. But then like you zoom out for a few months, or even a few months for what you guys are doing, or zoom out for like a year, it's like amazing progress, right? So just, yeah, stay enthusiastic. I mean, you're doing it, man. I mean, you're making it work.
Yeah, today was my first day off in 3 weeks. We're doing 12-hour days, pretty much 7 days a week. I just had to fix my water system today because, wives are crazy about that whole running water thing. They don't want to go fish water out of the pond. I just don't understand it.
Yeah.
So.
Well,
yeah.
I was gonna play Todd Desiato's. You know what? Maybe I can do that next. Maybe I'll do that next time. I think here I'll bring Denny back in, because you guys are having a good discussion. I don't want to interrupt that for Todd's thing. But what I will do is I'm going to have a good one, Drew. Yeah, so why don't I keep it an open discussion, and then what I'll do is drop a link in. So Todd Desiato did a really great presentation. I do want to get that out there.
Maybe you can show it at the next APEC, or if at some point you have
and it's
not
a
that
YouTube
many
video.
presentations.
And I actually put it up on the website too. It's the operational. So I don't want to. So let me put this out there in the comments. Todd Desiato's amazing presentation on, and you know what? I'll put it up for just a sec so that folks can see it. So there we go. Okay. And so I'll just do a quick screen share just so you guys can kind of see it. It's a 45-minute presentation. That's the thing. So I don't want to totally interrupt everybody, but yeah. And he runs through, it's mostly him talking. He discusses a paper. And then if you go down into the comments here, his paper is on ResearchGate. And if you want to help support Todd's work, I know he would appreciate that. He has a PayPal link, and I believe he has a Patreon link also, and he is on Twitter. So the links and stuff, the ResearchGate links, all of this is down in the video. I'm going to post this into chat. And so guys, I guess just keep an eye on it. And as you can see, there's more videos down by him there. And look, Star Trek and Superman. Yep, that's mine. Okay. That is definitely my feed. So.
Epic. That sounds like a good feed.
Yeah, it is a nice feed. My feed is interesting.
Yeah. I can
I've been writing a lot lately, and I did a story on Superman, so.
Yeah, but I can attest to Andrew's work ethic. It was really amazing to see him, basically starting to build Exodus, and crazy work ethos, and some motivational Star Trek in the evening to get inspirations and to cool down, and then just start again from the morning. Very amazing. So I'm really excited to see where Exodus is going now that they're funded, they have the space, they actually have way more working hours that they can put into the manufacturing and all of that good stuff. It's going to be very interesting to see where they go within this and the next year.
You know, I should have asked him. I didn't get the opportunity since they were talking about Casimir effect, about Garrett Model's work in Boulder, Colorado, and some other stuff, because these are interesting.
Yeah, and Denny, I might be able to add a little bit to that. I've been digging in there. So Sonny's work, it is not the same, but what Sonny White is doing with the Casimir effect is related, and I think that they kind of crib notes from each other with Garrett Modell as well, right? And Charles Chase from Unlab, if I remember right, he did a video that had both of those gentlemen in it. So they know each other, right? They're cross-collaborating. Garrett Modell is also claiming real valid scientific results. Sonny has been claiming real valid scientific results. Tom Vallone, I asked Tom about that, and he said they're running into some engineering challenges that are slowing things down. Now, that may or may not be correct. They may or may not have overcome that. That was at the time, but this was like 3 or 4 months ago, and Tom was like, they're hitting some headwinds, right?
It's not easy to print what their geometries. When you do chips, you can have a few layers. Normally you get 32 layers of even when you print a chip, okay? But in order to achieve their geometry, it has to be in 60 or more, and that's bloody expensive. And to say something, I think Garrett Modell was first. His idea was first, and then that's how I see. I don't know how they connected, but the way I see it, Sony's idea, it's difficult to print the chip because of cement layers.
Okay, yeah. So I didn't know that there was a spat, if you will, going on with their data. So at first I thought Sony's data was fine with the warp drive, and then also Modell's work was really innovative with Casimir stuff. But from what I'm hearing, it seems that as people are trying to replicate it now, they're running into some issues engineering the setups that they had to cross-check their data.
That was for Garrett. That was Garrett's issue, because the people couldn't reproduce, and it was a picoamps and stuff like that.
But what was Sonny, I just saw a new post on a semiconductor slab that he'd manufactured. So he's, all of these guys are continuing to push forward. I feel really bullish on it. I think that they are going somewhere. They may have some headwinds, but I mean, good God, this is 0-point energy, right? Like if it was easy, it would be easy. So, yeah, I think it's really exciting. And then the other part, and this would, Jared is in, actually all of you guys are in this, like the other part. So I did a podcast interview with Leap 71 with Lynn, and then I talked with Josephine, but we didn't do an interview. And then I did one with Elaine Richard on 2D materials. They're doing AI. Elaine is doing atomic tesslator materials development using AI systems. Leap 71 is doing engineering. They're the guys who did the Aerospike engine in like 2 weeks. They put it in. They're like, hey, make me an Aerospike. Here's what it needs for fuel. Here's how hot it can get. Done. Right. 2 weeks later, the 3D metal printer in China sent it to them. And I just had a fellow reach out to me the other day who does 3D metal printing in Vancouver, right up the road from me. So that's my bent. Like I want to get you guys better tools.
Amazing stuff we have. The resources we have today didn't exist. Like I remember being in high school when 3D printers were just becoming a thing, and just basic print jobs were always failing. We're talking simple PLA ABS plastic. It's just like ridiculous. And now, I mean, it's really impressive. It's literally like putting a hot potato into a microwave. So it's kind of cool.
Yeah, Tim, you should send the person a little bit north from you the designs from Denny, and let's see if you can build a Repulsine engine. That would be fun.
I'm working on it. I'm working on it now. In
Awesome.
his case with Atomic Tesslator, he has a business, he has clients, he has development, so his bandwidth is limited, right? And the same thing would apply to Leap 71. But what is interesting is, like, in their case, they open sourced a lot of their model for people to download and use. People are actually using it too. There are folks who have downloaded it and are using it to build things. And then just like as this stuff comes up, right? It's like grassroots. You have these different tools coming up here, there, and everywhere.
Awesome.
I think the Leap, if I'm remembering correctly, is that the company so the AI tools with the optimized kind of jet engine, space engine thing?
Yeah, that's the Aerospike engine.
Yeah, I was trying to look at their Git or something. Yeah, I have them on a few tabs.
Here, I will share screen, Leap 71. I'll share the gallery. This is the stuff that they made.
Yeah.
3D printed rocket engine.
Yeah. I think it's interesting how the AI was trying to do some of those things. Well, they work, but I also still have my reservations about the efficiency of how they work. I feel like it's adding far too much complexity into these systems, right?
It's possible.
But it's incredible.
Yeah. And it's iterative, right? I mean, look at like LLMs. Look how far they've come and how fast they're doing it. So,
but nobody touched to design an Aerospike engine because it would be so costly. And now an AI just did it, right? So it's amazing. And you're right. It probably is not that efficient, and you would still have to optimize it. But if you use that AI iteratively and you use 3D printing methods, maybe you could get a very good Aerospike engine with very low cost for design. So
yeah, over time,
and this is
go down.
And this is just the start of it, right? So this is the first time that this has been done. Wait 1 or 2 or 3 years till the systems get better and they understand how optimizing works from the get-go. So that's really amazing technology.
Yeah. Well, guys, should we shut things down for today? It's 5:20. So this is okay. Yeah, I would say this has been an amazing show. And I did get the thing out there for Todd, so we were able to cover all of our bases. I did not play that on the screen, but that's fine. It's out there. So and maybe I can coax Todd into doing a presentation for us. And thank you guys so much. Denny, thank you as well. And if you have more that you want to share, man, I would love to have you back. So
it'd be my honorable pleasure.
Okay.
I always have things to share. So it's
okay. Well, this has been APEC. It is Saturday, June 6, 2026, signing off.
See you next